ProFuture conference. We are really excited to see so many people here in person and also joining us online. My name is Marie. This is Rike. We are from the European Food Information Council, EUFIC. We are organizing this event, so for any questions throughout these 2 days, just come to us. Before we give the word to our first speaker, a few words about Slido.
Yes, so we have quite a few people joining us online today, and we would also like to send a very warm welcome to those people. To engage them also in our discussions, we have created a Slido, so you can also, people here in the room, you can go to slido.com and type in ProFuture EU. And there will be some ice-breaking questions, and also for the online audience, you can post your questions through the Slido throughout the entire day. Exactly. And
we're gonna show the results a bit later, so Massimo, if you could come to the stage, please.
Yeah, I would like to introduce Massimo. He has a very special role in the project as he is the project coordinator of ProFuture. Massimo Castellari is an agricultural engineer and holds a PhD in food biotechnology. He's the director of abiotic food safety sub-program at IRTA, and as said, he's the scientific coordinator and participates also in other EU-funded projects focused on the valorization of alternative protein sources.
Thank you very much. Good morning and welcome everyone. I am the scientific coordinator of the ProFuture project. Before starting the presentation of the first session of this conference, I would like to give you a short overview about the main concepts behind the project. The next one, please. Okay. This one. Can I see the slides on the other screen? Well, anyway, the full title of the project is Microalgae Protein Ingredients for the Food and Feed of the Future. It's an innovation action granted from 2019 to 2023 in the framework of the Horizon 2020 funding program. And one of the most asked questions people made me just before starting this project is, why did you decide to focus all the project on the microalgae? So why we decided to work with microalgae? And the answer is quite easy. Microalgae are interesting organisms, perform photosynthesis, and they produce more or less the half of the oxygen we have in our atmosphere. And microalgae are also interesting as a food source since a long time. They were used by ancient civilization as Aztecs in Mexico. They cultivated spirulina, and they prepared a cake with a name I cannot say, of course. Tecuitatl. Okay. So these unicellular microorganisms are very interesting because they grow quite quickly in comparison with other terrestrial plants. Their biomass is rich in protein, unsaturated fatty acid, and other bioactive compounds. And another important point is that they capture CO2, so they can contribute to reduce the concentration of CO2 in the atmosphere. Oh. So, what is this? This is not my presentation. Okay, no, thank you. So, considering that these microalgae are interesting as an alternative source of ingredients for food and feed application, why their presence in the market is still marginal? so especially in Europe. So which are the main bottlenecks that restrict the large use of and production and consumption of these ingredients in the food and the feed sector? In this case, the answer is a little bit large. There are many factors influencing this situation. Probably the most important is that the cost of the biomass is still too high, so the biomass is still too expensive, and this mainly because of the fact that the process and the technologies which are available today are not still fully optimized and developed. So there is still a low efficiency in the process. And another important issue is the characteristics of these ingredients, because the microalgae, for their properties, for their organoleptic and technological properties, can provide undesired changes in color, taste, and structure in the food matrix when incorporated in the food. Furthermore, we have also observed a certain issue with the digestibility of the ingredients, which is usually lower than other protein sources. And finally, at this moment, we don't have available protein isolate from the microalgae biomass. This is a problem because protein isolate, which are more refined, which are more easy to incorporate, could help the use of these ingredients in the food and the feed sector. Regarding the environmental aspects, there is still the need for comprehensive economic and environmental studies to optimize the sustainability, to support the optimization of the sustainability of the microalgae value chain. And from considering the problems, the critical aspects we have to incorporate to the ingredients in the food matrix, there is still the need for innovative food concepts to increase the acceptability of these microalgae ingredients in our diet. And finally, considering the regulatory framework, many microalgae species were not consumed in Europe before 1997, so they are considered as novel food and require a special authorization for the use in food as a food. And in the case of feed, the situation is similar, so there are very few species authorized for aquafeed and for livestock nutrition. So, considering all these limitations of the sector, the main objective of ProFuture has been to try to overcome these bottlenecks by boosting the innovation all along the value chain, from the production of the biomass up to the consumer research. The speaker today will give you an overview of the main results of the project, but I would like to thank all the 31 partners involved in the consortium for their activities, for their work, for their support during these 4 years. As mentioned before, this is the last year of the project, and this is all for the moment from my side. If you want more information about the project, you can enter the website of the project or the social networks. I hope the conference will be interesting and fruitful for everyone. And thank you very much for the moment. And, well, that's from my side. Thank you very much.
Yeah, Thank you very much, Massimo. For the online audience, just to let you know, the Q&A is now open, so you can ask any questions. Is there any question for Massimo at the moment already? Yes.
Yeah, Massimo, I'd like to understand which is the obstacle in order to obtain isolate proteins from microalgae, from the technological point of view. Thanks.
Well, our colleague Ima later, I suppose that she will explain more details about this, but in few words, the problem is mainly the low yield of extraction of these extracts and the purity and the need to clean this extract to obtain an isolate with high content in protein. So it's actually it's a big problem from the technological point of view, and I suppose it's a good field of work for the future. No more question?
Okay, then we can start with the next speaker, Iago Teles. Iago is research manager of microalgae biotechnology team at Wageningen University, and he is passionate about science, answering practical questions, finding solutions and opportunities in the field of microalgae biotechnology. Okay.
Thank you very much, Marie-Christine. Good morning, everyone. I'm very happy to be here. Thank you for being present and for your interest in our project. And following on Massimo's introduction, there is one big issue with microalgae, that it's costs, of course, and resource efficiency. And that is the title of my talk today. That's the result of a group or effort that I'm going to show you. But we wanted to improve. It's not moving. Yes, it is. So very quickly, who we are, and bear with me, I have a challenge. We are 6 partners in this, in our work package, focused on the issues of improving production, and I have the challenge to talk about it in 20 minutes. So I will be quick, I will be brief, and if you're curious, I want to incite your curiosity to ask us questions afterwards. So bear with me, that's the results will be quite summarized. We were 2 universities in the Netherlands, Wageningen University, where I'm from, University of Twente, 2 research institutes, Norse and Green Collab from Portugal, and 2 industrial partners, algae producers, also from Portugal, all microalgae and Acton. Our goals involved cost reduction, improving production, increasing sustainability, so the sustainability performance of our the production, and of course a very noble and task that was supplying biomass for our partners working on product development, extraction, as you hear after me. Well, the introduction, it's not really necessary, just some pictures of the beautiful creatures that we work with. Massimo already explained why microalgae are relevant. Some people call them primitive plants. If there are other biologists in the room, we usually cringe at that definition, but it does the trick to communicate. We can find them in different environments, from salt to freshwater. What they have in common, because they are very different creatures from each other, they usually do photosynthesis, which is a bit ironic because we are going to talk about also heterotrophic production. That means algae growing in the dark. And also, we clump them together with the seaweeds. Often. We can do a lot of things with them. That's why we are here. That's why we are here in an innovation action. And this is a brief list of possibilities using microalgae. So we can use the whole biomass as a source of nutrient, as a food supplement, feed, aqua feed. But what we are interested in this case is proteins, but they also have sugars, oils, special oils, polyunsaturated fatty acid, pigments, and so on. These are the 6 chapters. I told you I had a difficult task today. So I divided that in 6 chapters with some hopefully interesting titles. But I go to the first one. If we need to improve production, one of the things we did was developing novel strains, strains that have better industrial properties. We wanted to explore nature's potential, so we worked with non-GM techniques. Of course, in Europe, that is still a discussion. It's not allowed. And here I have some pictures of where it starts in the lab, in a Petri dish with agar, gelatin, nutrients, and they're growing. I don't know if with the spotlight if you can see, but they go from very green on the... Do I have a laser here? No. No. From very green to less green. And the question I think that arises from it is, why do we need less green algae if they're naturally green? Well, the color is not really easy to work with when you're formulating food stuff with them. You see on the left, the actual green color of the biomass, and to the right, different variants, mutants. Like we all are mutants. Everyone here has different mutations, all of us. So do microalgae. We use random mutagenesis, a lot of selection at lab scale, but the final results were 6 novel strains with improved capacities, 3 pale green, you can see them on the top. They are lighter than the original one, the wild type, the so-called wild type. 2 yellow and 1 white strains. Some of them had higher growth and a little bit less proteins. Others had lower growth, but higher protein content. That means a higher protein productivity at the end of the period of production. All of them showed improved glutamic acid content in comparison to the standard sources for human nutrition, and that indicates a stronger umami, savory flavor. So that has implications for its use in food formulations. Chapter 2 said sun and sugar. We're not there yet in the darkness, but we are working on under mixotrophy. You know, autotrophy is when the organisms can produce their own food, like plants, algae, with photosynthesis. And heterotrophy is when they have to take up their food. They cannot produce. Mixotrophy is when it happens simultaneously or close to simultaneously. So we let algae grow under sunlight and sugar sources. For this, we work with a very exciting organism called Galdieria sulfuraria. The name gives a hint. It was isolated from volcanic hot springs. It's a very lovely environment. That means there is a lower risk of contamination, simply because no other organism wants to grow where Galdieria grows. That's why it is called a polyextremophile. Sometimes algae can grow at higher temperatures, but the rest of the conditions are, let's say, less mesophile, so not extreme. But this one likes it rough, you know. Life is difficult, but not for Galdieria. There is another reason, of course, why we work with Galdieria. It has 60–65% protein, and considering the standards of the FAO, you can find in Galdieria a higher content of methionine and cysteine, 2 essential amino acids. Our approach, this is summarizing the life of my colleague, 4 years of the life of my colleague. I will tell you his name, sorry Pedro, but that was the time that it was available. We started with a scale down. A scale down is when you already know how to scale up, how to produce something in a higher scale, and you scale it down to improve it further. So you know somehow what you're going to do. So the first step was to work on simulations and some pilot conditions at lab scale, bring it down, feed the models, design and simulate the supply of glucose, that was the source of sugar we were using, and then go back to the scale up, which we did in an algae park pilot facilities in the Netherlands. So here we have 2 of my colleagues and someone that I had to hide for privacy reasons, with Galdieria growing in our greenhouses in the Netherlands. Yes, it is sunny in the Netherlands once in a while, but we have state-of-the-art lamps for the very dark days, but these runs were done in the summer when actually it gets pretty unbearable to be inside the greenhouse. More pictures of the different runs. We did autotrophic, mixotrophic, heterotrophic runs. Here's my colleague Pedro. Please raise your hand. Watch out for your coffee. If you have specific questions like how many grams per liter can you produce? Well, actually I remember, but I'm not going to say it now, just to keep you curious. You can ask him. But the summary of 4 years of his life is that Galdiera can use sugar efficiently. It opens up the possibilities to use other waste sources. We achieved a stable production of this polyextremophile. There are very few records, at least officially in public, about growing this strain at this scale under the conditions that we did. So that was a very good result for us, a fulfilling result for us to achieve. And the productivity is within the range or a little bit above, but that is a question for Pedro later. He also has a poster, so please contact him. Now I want to talk about microalgae and insects, the unlikely synergy between the two of them. We here used waste from insect production, so insect frost, as a nutrient source for microalgae. Basically what we did, we tested different waste sources from industrial, municipal waste. From this selection, insect frost was identified as the most suitable, both due to the amount that, of its production per year and the nutritional value they have, so the nutrients they can supply microalgae with. Then we had to optimize those trials at lab scale. We used Chlorella vulgaris, a very industrially exploited strain, using it. And of course, it finished with the data analysis comparison and studying the composition of the biomass. Being very brief here, it's again my colleague Dorinde Kleinegris. Raise your hand if you want to know more. She's your person. These graphs here, being very simple. The left one, top left, you see there's no difference. Everything's overlapping. That means that the controls and all the different treatment that we tested show the same growth. And here, on the right, you see that the protein content has some variation, but that is not considered statistically significant. So when you compare controls with the medium containing insect frost. Then now we go to the darkness. I promised you some lack of sunlight. Microalgae in the dark, heterotrophic growth. Microalgae can also, most of them, I don't know if most, but a lot of them can grow also, can be fermented like other microorganisms. And it has some advantages. Often, when they grow in the dark, they don't have to be as green as when they grow under autotrophic conditions. So they need the pigments to capture light and convert light into the food that they need to live. So when they're heterotrophic, it changes a little bit. So we tested different strains at lab scale to develop the developing trials for developing and improving the production protocols. That included also the novel species from chapter 1. They were also sent to the partner all microalgae to be produced at lab and lab pilot scale. In this biomass, both wild types and novel strains were sent to partners for trials. Here briefly, Elena, say hi. If you need to know more or if you need to buy some biomass, you can ask Elena as well. Our microalgae can supply you with that. On the top we see some of the novel strains we developed, the mutants. Here, the lab trial, just to give you a taste of what it looks like in the small scale. That's what it is, the vessels covered because they have to be in the dark. And bigger vessels for pilot industrial scale production. Now the CO2 paradox. I don't have a picture of my colleagues from the University of Twente. They are not here today, but if you have questions, you can ask me. I can redirect you to them. I call it a paradox because we hear a lot of CO2. It's at very high concentrations in the atmosphere, but there in the atmosphere, luckily, down here, it's 0.00 something. And that's not enough to optimize your microalgae production. What people have to do is to buy CO2 in bottles, pressurized or liquid, in liquid form, and that represents also a cost and an environmental burden, you know. What we wanted to do here, our colleagues from Twente designed, built, and tested a pilot DAC, direct air capture unit, that was placed in all microalgae. You see there in the installation, which was today's 13, right, of September. It was literally 1 year ago, right, Elena, that we were there. This is the pilot already installed. It's a vertically stacked container for you to have an idea of the size. This is us, annoying the people that install, you know, after people install something, then the visitors come and want to see things. And this is all of us doing the technical visit. You can see some reactors around it, but you'll see better pictures in a bit. But this was September last year. How the process works. I'm not a chemical engineer, so it's not oversimplified for all of you. It's oversimplified for myself as well. Basically, there is a vent, atmospheric air is being vented in. The CO2 is absorbed by the sorbent, by the particles, and lean air is sent out without that CO2. That's 0.00 something. With time, you saturate the sorbents, and then by playing with heat and cooling under vacuum conditions, the sorbents release the CO2, and that gives us a stream of CO2-rich gas, which can be 95% pure, so high-quality CO2. And if you have, if there are investors in here, yes, we could use this CO2 for other stuff as well, not only for microalgae. Keep that in mind. But the pictures on the left show us the green tubes around the unit, and that it's not only for our picture purposes or PR. Those tubes were running on the CO2 supplied by that unit. This data was gathered. It's included in our reports. This was from September, December 2022. We produced about 150 kilos of CO2, like I said, a purity of 95%. And one remark is that the weather conditions were not very optimum. So the relative humidity was above 75%, and for some reason that I cannot explain you today, this is not good for the process. So then take my word for that. Here below there are some graphs and numbers, not for you to read now, but that means that the logging of the temperature, performance, efficiency, costs, and where the energy is going, they were gathered. So these numbers are available for sustainability studies and assessment of the technology. Then we go to chapter 6. I hope I'm not too okay on time? Okay. Have enough? So I'll talk slowly. 6 is reducing consumption of a energy consumption, resource consumption, in this case mainly energy, of a microalgae production facility. Here you see another person that can help you improve your process, or maybe contact you with buying some more biomass as well. That's Alexandre, say hello. This was the Necton. They live in this horrible place called Algarve in the south of Portugal, you know, bad weather, and they have a tough life in there. What we did in this chapter was, well, designing and installing novel reactors, not novel but new reactors, using state-of-the-art knowledge. They were made of glass. That has some implications for the sustainability aspect of the process as well. Glass is more expensive, but lasts longer as well, and gives you our, let's say, cleaner and more controllable process. The PVs were already installed in Necton, but they were optimized, connected to the control systems, and that was done with the goal of achieving an off-the-grid reactor. Come with me. Let's see if I can explain this clearly. We're talking about 27 cubic meters of tubular reactors. There's, we have the drawings first. Remember that Necton is placed in a very beautiful location, a natural park, so it's not easy to have permits and to have this installation. But here they are, inoculated, beautiful, green. And we did a few trials. So the first trial was, and here I have to explain you a little bit. The main part of the process of producing microalgae, the main part that consumes electricity, is often the pumps. Algae are in the liquid, they are in suspension, and you have to keep pumping them so they recirculate around the tubes, right? The standard practice is to have the pumps 24 hours on, you know, even at night when they are not growing, if they don't have sugar in this case, they are growing on sunlight and CO2 only. So the first test we did was what happens if you turn off the pumps. The first reaction of people working with microalgae is panic. I mean, they're going to settle down, they're going to die, they're going to collapse, and we're going to die, all of us. That's the first reaction. But what we showed is that you can actually turn off the pump at night. They will settle down, and apparently they only fall asleep, you know. And they wake up in the morning and they were fine. So we compared two conditions, completely off, and turned on 5 minutes every hour, check the effect, swapped between reactors, and it was a very positive result, we believed. The other trials were already in duplicates with the new systems, and we wanted to run them completely off the grid. One of the reasons why the pumps had to be off at night is that if you want to run it off the grid, either you put a battery or you turn off things at night. And since we found out that we could turn off at night, it was possible to compare them. And this is another picture. We had an on-the-grid and off-the-grid reactor, one next to the other, swapping them for controls. You know, we're all scientists and we want things well controlled. And comparing the growth, we see very little difference between the two modes when we compare trial 2 and 3. Another thing we did was to solve another issue, the issue of contamination. We had already tackled the subject with Galdieria. So with contamination, you have a few options. One, to be a clean freak and keep everything very clean, you know, quality control to avoid contaminants coming. You might ask, what are contaminants? Many things could contaminate your culture, but normally bacteria, they are not detrimental, they don't collapse your culture, but the grazers do. The grazers are animals that, although are microscopic, they are much bigger than the algae, and they literally eat them. And they go grazing, grazing, grazing. The culture on the left, it's green, healthy. The one on the right, it's collapsed. They can collapse your cultivation in a matter of hours or days, depending on how bad they are, or good, if you look from their perspective, you know. You can, of course, be very clean, like I said. You can use an extremophile, like Galdieria, that grows under conditions that do not allow other creatures to grow. But you can also, you have to find other solutions. Sometimes they show in your culture, and if you can do something, you might save your production. So that's what we did, checking different nitrogen sources and different strategies. We came to ammonia as a replacement for nitrate. Normally people use nitrate. And in this picture, actually, you see on the right the control with nitrate and the left one with ammonia, and the contaminants that we identified in those trials. They didn't like ammonia, so that is one possibility. Microalgae can withstand the change in nitrogen source, but some of the contaminants might not, and that was also a very interesting result. And here I'd like to summarize what I told you here today in all 6 chapters. We developed here to achieve the overarching goal of reducing costs and improving production and efficiency, both from the production and sustainability aspect. We developed novel strains, mutants with improved industrial properties. We showed that insect frosts can be a source of nutrients for microalgae. We scaled up a polyextremophile under industrially relevant conditions. We found strategies to reduce contamination. We tested and we developed, built and tested a CO2 direct air capture unit on the grounds of a production facility. and we ran reactors off the grid. With this, I love this picture here because it's from 2020. I don't know if anybody remember those years. Something happened. And this is to show my appreciation to all my colleagues. Some of them, they are here, not all of them. But this was really a group effort and a lovely group of people to work with. And it's a pity that our work is done. And we still have one meeting in November. I will chase all of you. And of course, thank you to all the partners of ProFuture, to Massimo and Fabio for having us, and Marie-Christine and her team for coordinating. And if anybody has questions, I'm happy to answer or to tell you I don't know it, but I will look it up for you. Thank you very much.
Are there any questions for Iago? No? Okay. Maybe if you could shortly introduce you when you ask a question, that would be nice.
So I'm Johan Robbins, I'm from ILVO in Flanders. And one of your first steps, you look to alternative species, but from the regulatory point of view, it's actually an extra burden you have.
Sorry, I didn't...
You're looking for new species, you want to use them in food and feed,
Yeah.
but the regulatory, it's a new species, so you have to do actually a lot of regulatory work before you can ever use it.
Thank you for the question. Again, it goes into that warning I gave in the beginning that I was not very clear and quite on purpose. It's a tip to get questions. With the novel strains we developed, they were all from Chlorella vulgaris, is a strain that it's already accepted and commercialized. And since they are not GM, they are just variants of it. Yeah.
Galdiera?
Galdiera, yes, it is still novel. The last information we have is that if somebody knows that, please help me, but a request is being prepared by some actor in the field, right? For Galdiera, yes. But you are right, every time you work with a new strain, you have to consider that burden of doing that. I think Javier had a question, I think.
Thank you. Javier Berterreche from Bridge to Food. I have a personal doubt. When you say, for example, in the case of Galdiera, all the extremophiles are better to pick because there is less contamination. I understand this when you pick them, but what happens after that? How you avoid contamination?
Perfect, the perfect question. When we bring them, when you grow them at a lab or industrial conditions, we try to mimic the conditions they come from. Of course, not the sulfuric part of the hot springs, but the hotness and the acidity. So by keeping the pH 0, it can grow from pH 0 to 4. That is a quite unbearable pH for most microorganisms. So far as my knowledge go, only a few fungi can actually contaminate it potentially, but most bacteria cannot even, unless it comes from a hot spring. And the chances that you're going to find organisms that can grow in hot springs in Wageningen is in the Netherlands, it's very small. So we keep the temperature very high and the pH very low, and that keeps the contaminants.
So the second part of my question, I understand this. Do you think you can scale this up at an industrial level?
Yes, and that's what we showed in this in the trials we did. The systems that we worked with, they are commercial systems. Those tubes that you see, they are from the company Algae in the Netherlands. So they are scalable. You have to take care. The main challenge is if you already have established microalgae production, having your medium with a pH 0 might be a challenge for you, because at this pH could even be corrosive to certain parts of it. So yes, if you already have a production facility, it might be, you have to consider if the investment be worth it, because you have to prepare everything to withstand 50 degrees and a very low pH. But if you can tackle those things technically or investment-wise, there's nothing forbidding you. Yeah. And by the way, there are some information that some industrial actors here and there in different countries are already scaling this up. But of course, if it's an industrial project.
Yeah, I have a question. I am Estelle Coillier from Nantes University in France. And you have described several strains with different colors because you've cultivated them in heterotrophic conditions, for example. And is there any impact on the composition of the microalgae? Because the photobioreactors in autotrophic conditions, they use autotrophic will lead to the production of specific interesting compounds that could not be produced in heterotrophic conditions. So do you have any data on this and nutritional interest?
Well, thank you for the question. Again, I will give an answer and ask my colleagues to complement if they see something missing. There will be some changes in some components, but the macro components, we focus heavily on protein content, right? So the pigments, of course, they tend to go down, although there are reports of strains that remain green under dark conditions, heterotrophic conditions. So the pigments will disappear, but that's exactly what people want. But as far as I'm concerned, there are some minor changes, but no major change in the composition, right? Like that impactful.
There can be, but we can also. Okay. There can be significant changes, and we want generally to lower the chlorophyll content because the taste is very pronounced. But we can also change the medium conditions or try to optimize a given reactor conditions and parameters to stimulate the production of specific compounds. So for now, we have optimized to increase the protein content and growth, but we can also try to fine-tune the medium to produce a specific lipid or increase the content in some mineral or some specific nutrient that we want to enrich our biomass in. Does that answer?
Thank you very much. Angelos Harlaftis, Epafos Advisors. Have you investigated, researched these microalgae systems? Can they exist in minus 300 Celsius or pressures which are not on the earth and environment? Because as I understood, they need darkness, they need sugar, and they need CO2. So only CO2. So they produce oxygen from the CO2. Have you investigated such a thing?
Are you considering taking microalgae to the space or?
To Mars.
To Mars, yes. Well, not in the scope of this project, unfortunately, because it would be very cool. But I happen to have a colleague in Wageningen working together with the European Space Agents. They are investigating the possibility. But minus 300 Kelvin, you said?
The minus depends also from the pressure of the environment.
Well, that I certainly don't know if we went that extreme, if anybody has a record, but at least to provide, like to take up the CO2 from like the International Space Station and to provide a source of nutrient for astronauts, for example. This work people have been trying and studying. Yeah. If you really want to know more, I can introduce you to a colleague of mine, but that's outside the scope of this project. And if you know anybody working on it, please call me. I would love to join such a project. Huh? Go to Mars, indeed. Anybody else? Going once? Going twice?
Then thank you very much. And then I'm pleased to introduce our next speaker of today, who is Emma Gifuni. She's an R&D project manager at Algosource, and her main expertise is in a biorefinery applied to microalgal biomass. Let's say, microalgae have always been her thread topic of all her academic studies in biotechnology till her PhD. And she's now going to talk about production processes and analysis of nutritional and functional properties.
Thank you for the introduction. I would like also to thank all the people that were working with me on this topic, Ilvo, Dil, Irta, and Necton. We will see together which were the most important points about protein, the production of protein ingredients. I will clarify the objective of our study, and then I will talk about the main results we obtained about the development of two main products, the single-cell protein and protein isolate from microalgae. Then we will see together the conclusion and the perspective of this work. So, the general objective was the assessment of the most affordable and suitable technology for the production of microalgal ingredients. We had two targets, single-cell protein and protein isolate. The single-cell protein, as the name suggests, are the entire cells that are directly available for food and feed reformulation in the form of dried powder. For this application, we selected light green chlorella, tetracell mistui, Arthrospira platensis, also known as spirulina, and Nanochloropsis oceanica. The protein isolate are more purified protein coming from the entire cells. They are expecting to have higher protein content and purity, higher functionality and digestibility, and of course, lower color, lower off flavors, and so on. For this application, we focused on light green chlorella, tetracell mistui, and spirulina. So, in order to produce these two new ingredients, we focused on three crucial steps in this project: was the processing, stabilization, and characterization. The processing is important, especially for protein isolate, because we need to assess which is the most affordable process chain to produce the protein isolate. The stabilization is important. You know that most of the protein ingredients that are produced from plant, they are stabilized by drying. So drying is a good technology to stabilize product and improve the shelf life. But we want to go deeper in this project. We want to analyze more drying process and see which one was the most sustainable and was able to also preserve the quality of the product. The characterization is the most important point because we need to assess the nutritional and functional properties of the final product to see if our process was more efficient and respectful of the quality of the protein. So I want just to clarify why we choose to analyze the nutritional and functional properties. So nutritional properties are defined by the measured organic compounds of the product. We can see these nutritional properties normally on the nutrition information that we see on the packaging of the product. More and more consumers look for that because they want to see if actually the product corresponds to their needs. And plus, these nutritional properties also give the right to put some labels, some nutrition claims on the packaging, like rich in protein, low in fat, rich in fibers, and so on. Functional properties are really important. They are non-nutritional properties, but they are important for the utilization of the proteins, especially for the production of processed food. So these are the properties the industrial partners are looking for the formulation of foods. For example, if you have protein with good solubility, they are particularly required for the formulation of soft drink. Protein with good gel formation are important for the production of processed meat. If you have protein that are able to help cohesion, they are good for producing crunchy nuggets. And if you can find protein with good emulsification protein that are really required for infant formula and instant meals. Let's go now to the results. So for the first product, the single-cell protein, as Iago explained, we had the Portuguese team of microalgae farmers that were really producing the biomass. We just worked on the stabilization by drying. The objective was to select a more sustainable and less invasive drying method to reduce the energy consumption and preserve the protein quality. You can see here the picture of the equipment we used. We applied 3 innovative technologies: the agitated thin film drying, solar drying, and pulsed combustion drying. And we compared their performance with the spray drying, which is the benchmark of the market now. We concluded that with all the drying technologies, we could have suitable and stable powder, and the behavior during the drying was really strain dependent. So each time we changed the strain with the new drying method, we need to optimize again the parameters and fine-tune all the crucial point of the drying. In the end, we found that the solar drying was the most performant method. It gave the best yield and the best environmental and cost impact. You can see here a picture of the equipment from the outside and inside. It's installed in net tone for the moment. And we need also to point out that this is a batch process. It has a maximum capacity of 150 kilograms of dry weight per week, which is for the moment in line with the production capacity of the facilities. And what about the quality of the final product we obtain? Here you can see a picture of chlorella dried with different drying method. It looks different from, you can see different green nuance. But the analysis showed that the drying method were not affecting the nutritional composition of the powder, neither the digestibility. We find some difference, especially for the degradation of sensible molecules like chlorophyll and vitamins that were more affected by solar drying and agitated thin film drying. And about the techno-functional properties, they were even improved with agitated thin film drying and pulsed combustion drying. Here I want really to point out that we had big difference among the analyzed strain. If we look at them in terms of final product that we obtained, so these are the single-cell protein in the form of powders, the strains are different just in terms of green nuance. You cannot see a real difference between them. But if you go deeper and you look at them at the microscope, you see that they have different shape and different size. And if you go even deeper from the taxonomic point of view, you see chlorella is different from Nanochloropsis as an elephant and a shrimp. So we can see this difference even on the nutritional composition of the strains. Chlorella has only 25% of proteins, but it's really rich in fibers. Spirulina reaches 60% in protein. Tetraselmis 37%, and it's also really salty. And Nanochloropsis 48% in protein, and it's also rich in lipids. Of course, we went deeper in the analysis of this powder to characterize them from the nutritional and functional point of view. And we saw that each strain has a peculiarity that can orient some food and feed applications. For example, chlorella, it's widely cultivated even in Europe. We have low color mutants that are available already on the market. They are produced by fermentation, so we can lower the cost and be in line with the food application. Chlorella is also rich in linoleic acid, beta-carotene, lutein, fibers, and we found that it has 67% of protein digestibility, so it's highly digestible. Spirulina is also widely cultivated all around the world. It's well known for the phycocyanin. It's a blue protein pigment complex. It's also rich in omega-6, and we found that spirulina has the highest functionalities and highest protein digestibility. Tetraselmis is now accepted as novel food. It's also well known in the aquaculture feed. It has a really high polyunsaturated fatty acid content. We found that it has a salty taste and really pronounced seafood taste and smell. It means that it can be used in some food formulation with the processed fish or even in fish replacement. We found also that it has good functionalities and good digestibility. For Nanochloropsis, it's not food grade for the moment. It's also rich in polyunsaturated fatty acid. And interestingly, we find that it has almost no functionalities. So it can be good for some application where we have to avoid foaming, emulsion, or gelling. And we also find that it has lower digestibility in comparison to the other strains. Well, let's go now to the second product, protein isolate, the tricky one. So the objective here was the identification of the most efficient and suitable process for the production of protein isolate from microalgae, because we wanted to reduce of color and of flavors and improve digestibility and functionalities. As you can see on this little scheme, if we want to access the protein that are inside the cells, we need to disrupt the cell wall. Then we need to purify the protein from the other components and dry them to stabilize them. These are the three main steps that we analyzed. And here I want to underline the commitment of this project on this topic, because from the beginning we wanted to use only sustainable and solvent-free process. So probably you can have better yield with other processes that use chemicals, but this was the commitment for the beginning. We didn't want to provide a protein source that has the same environmental impact of the one that we are currently using. So we selected some technologies for the cell disruption, the bead milling, which is applying a mechanical disruption to the cells, the pulsed electric field, which is using electricity voltage to permeabilize the cell wall, and for the purification, some well-known technologies like membrane filtration, precipitation, and chromatography. Here, the result about the processing. So for chlorella, we obtained that the best process chain for the extraction of protein was bead milling, so for the cell disruption, and then clarification and purification by membrane filtration. The final yield we obtained was 4.7%. For spirulina, we saw that simple thawing and maceration was enough to release protein, and then we clarified and purified them by filtration. The final yield we obtained was 30%. And more interesting was for tetraselmis. So we received 2 different batches of biomass from the producers. And you can see the picture there. They look different in morphology. So they are probably associated to different physiological states. And the optimal process chain is quite different for the 2 batches. But in the end, finally, we achieved almost the same protein yield. About 7% of the protein were recovered. So this was just to underline that the optimal process chain for the extraction of protein is really strain dependent as the performance we can obtain. And the more tricky result was that even the physiological state of the algae at the harvesting time can influence the process performance. Going to the final product, so the protein isolate that we obtained with this test. For chlorella, in the end, we could produce 11 grams of protein isolate per kilogram of biomass. That was quite low. So we thought that it was more interesting to work on single-cell proteins with low color, especially the only chlorella mutant that have been developed in this project. You see, it has a yellow color. I tested it. It's really nice. It's a nut taste. It has improved protein content and fiber content, so it was really interesting strain. For spirulina, we can achieve 185 grams of protein isolate per kilogram of biomass, but you can see the picture here. The protein isolate is dark blue because of the phycocyanin protein, but it has also interesting functionalities, improved functionalities in comparison to the entire biomass. For tetraselmis, we can produce 25 grams of protein isolate per kilogram of biomass. And you can see the picture, the protein isolate has a light green color with increased also functionalities. Just for comparison, soy protein isolate has a productivity of 220 grams per kilogram of biomass. So spirulina is not far from this productivity, but of course, here we are talking about different kind of proteins. The spirulina one, they are really blue and probably with other activity than simply the techno-functional activities. Concluding, for the first product, single-cell protein, we selected a low-cost and sustainable drying technology, the solar drying. I told you the equipment is installed in Necton, so if you want more detail, you can ask Alex. We also saw that each strain has a peculiarity and it can orient different food or feed reformulations. Not all of the reformulations have been analyzed in this project. For example, the fishy taste of tetraselmis has not been considered in this project, but it's really interesting. So if there are some people interested in, please. And we saw also that the low-color cholera mutants are really promising as protein ingredients. They are obtained by fermentation, and the taste is nice. Spirulina is still the richest in protein, with the best functional properties and digestibility. For protein isolate, so the protein extraction process we saw is really strain-specific, and even the performance. So for the moment, spirulina is the only one that is the most adapted to produce protein isolate, but the final protein are colored. In general, we saw that we had really low yield, which are normally associated to higher costs in processing, but the final protein isolate has improved functionality and digestibility, and probably they also have other properties that we didn't investigate in this project. So, how far we are from the arrival? Well, the current production facilities in Europe are still small, and they are associated to high cost. So the microalgal products are still in a niche market. But in this project, we found that we have special properties associated to microalgal product in terms of smell, flavors, and nutritional properties. So we are open to all the companies and stakeholders that want to push this field. The second point that I want to underline is on the production of protein isolate. On this topic, we had the feeling that our research was really limited speed research. We were working hard on these years, but we had quite low yield because of the process we selected in the beginning, and we were also limited to food-grade strains. So we just felt that the time of our research was not in line with the time of the market and with the time we have to provide new ingredients to the population. So what we can do about that, I think that it's important for the future to broaden the range, especially about new strains, and invest a lot in new and sustainable and even performant extraction process for the protein, for production of protein isolate. And another strategy can be to focus on byproduct of entire biomass, but we can talk about that later. So we think in the end that, yeah, of course, obtaining protein isolate from microalgae is difficult, but it doesn't mean impossible. We just need to give ourselves the means to fulfill our ambitions. And with that, thank you to all the partners that were collaborating to this work, and thank you all for the attention.
Hello, Lina Joller from Poweralgae. Thank you very much for the presentation, very interesting. Question regarding the single-cell drying approaches. You mentioned that the best came out solar drying, but considering that solar is not plenty everywhere, what was the second best?
It depends also on what you are targeting. If what we are targeting is also the functionality, the final functionalities, we had quite good results with pulsed combustion drying, which is a good alternative. The research institute that has this installation is IRTA, so you can ask Fabio and Massimo about this technology, and they can perform some tests also with innovative products.
Hi, thanks for the presentation. My name is Gustav Vaschatko and I'm from Kagel. I have more lipid background, so I will ask a bit, I know you focused more on the proteins, but I was wondering basically during the drying tests, did you monitor oxidation, for example?
We didn't perform the analysis during the drying test, but we analyzed the oxidation of some interesting product after, so in the final powder. But of course, you see, it's a research project, so we need to optimize the parameters, and sometimes we didn't measure online or everything we wanted. So it was just in the end of the process.
And for your isolates, how did you separate the lipids or the lipid droplets that were in the algae?
Well, that was the point. We selected some technologies that were performant on this part. So we just applied the solid-liquid separation, and then it was a membrane filtration with specific membrane material that retain lipids and let pass the protein, the soluble proteins.
And what was roughly the leftover lipid content in the isolate?
It depends on, in the isolate we had almost no lipids. It was less than 10%.
Thank you.
Any other questions?
Hi, Emma. Thank you very much. This is a little bit of a provocation, but imagine that they would give us funding for another 4 years. Anybody willing? What direction would you go? I mean, to increase the yield of the protein recovery, just to hear from you as a perspective, or how would you?
Yeah, I think that we could focus on two main things: is looking for new strains that are adapted for protein extraction. So as you did for selecting a new microalgae strain that were producing more protein, select a new strain that is adapted for the extraction. So that not only contain protein, but soluble protein that are extractable. And the second point is also, I think it's a good topic to work on the valorization of the co-product of the current extractions. So we already have some microalgal company working on the extraction of high value. They have residues. We can work on this residue. I think it could be a breakthrough for the protein isolates.
Thank you.
And we do have one question online, which is, a much used method is high-pressure homogenization for industrial-scale algae cell disruption. Why was high-pressure homogenization not used for cell disruption?
Well, we didn't select this at the beginning when the project was, we prepared the proposal, and we didn't have the equipment actually. But yeah, I saw that in this year they started to use this method more and more, and it's quite scalable now. So it can be also something to investigate for the future.
Thanks, Emma. Anyone else? Otherwise, we can start the first coffee break, actually. It's on the first floor, so just walk one down. And 11:15, we're going to meet here again. So thanks a lot to Massimo, to Iago, to Emma. I think that was really, really interesting. Welcome back, everyone. So yeah, I think some people are still coming in from the break, but we will start now. Our next speaker is Jean-Paul Cadoret, and he is the CSO of Algama Foods and also the vice president of EABA, which is the European Algae Biomass Association. He has 35 years of experience in this field, so in research and industry in the field of algae and marine biotechnology. And yeah, he's dedicated to innovation within this field. Yeah, Jean-Paul, please come to the stage. Thank you so much for joining us today.
Thank you. I'm not sure it's a good news that I'm working since 35 years in this story. It's not an easy task because, you know, to talk about the European industry in 15 minutes or 20 minutes, I cannot. In a way, I cannot. So I will just talk, and I will show you some examples, and to probably tell you how well this is now organized at the European level. I might have a. Thank you. Okay. So yes, and this is much more an excuse so that we have the contact and we can discuss after about the points. Thank you for inviting me, because in a way I'm not part of ProFuture, but I was following it since the beginning, because I was invited, I think, in the first at the first meeting. This, in a way, is the best way to start to show that there are now 230 members in the European Association. So gathering from macro, micro. In this room, you have some partners. Dorinde is even in the steering board now, and Olivier, you are in the industrial committee. Probably I forget somebody, but anyway, we were able since 10 years to gather, because 10 years ago the European Commission and the national institutions were saying, "Who are you, the algae?" So it was started at 10 or 12, and with 250, you have big one, and you will recognize yourself very probably in the two slides. A lot of small, so Necton is here, and one of the big now, but a lot of producers, even the spirulina people. So please, if you are not part of it, join. Join. We're here. Actually, we're here to help the community. So the more we are, the easier it is. I will show you after what we do with the European Commission. Very probably, all of you know this GRC paper. Coming back to some points, I'm not following my presentation. Iago, for the definition of algae, there are plants or not. It's not easy, you're right, because it depends if you talk about as a biologist or not. When I was a biologist, for me, spirulina was not an algae. Now that I am in a private company, it's an algae. So you see the difference. The European Commission decided with the standardization at the CEN that cyanophyceae, micro, macro, and even labyrinthulomicetes for the Schizochytrium are algae, because this is an economy. The only story is to know what we're talking about, but there is a definition. And anyway, for algae, we will never have a definition, because algae is not a group. Okay, but there are papers on that, and EABA published a paper 2 or 3 years ago, 4 years work with 10 people. This paper is a position paper. What are algae? That we're able to give to the politicians and to the Commission and to anybody that doesn't really know the field. Now I will go very, very quick to some examples. You will recognize yourself for some of them, all microalgae. Just to show for the people that are not really in the field that there is a lot of production facilities, there is a lot of work, there is a lot of research. In Europe, for example, you have now algae leaf in Iceland that's relatively big. Here is Ecoduna. We're in Austria. impressive plants also. Here, Green Aqua, we're in Portugal. Very important achievement too. They're still working. One of the first one. This was in the time of the East Germany. I just put a rocket. I read it because they were just sold, and this is no more a rocket, but this is still Klötze with the Jörg. 1 hectare of greenhouses in 90. You have here Microfit, which is one of the achievements in France. They are going very well and very quick. And 3 examples in Israel: Yemoja, Algae technology. We can go back if you want for some of them. I removed probably 20 or 30 slides because I just wanted to give you some example. Fotanel in Netherlands. You have here Simris. So you see, every country in a way has this big facility, and there is a paradox for the moment. I can tell you there is a lot of biomass and stocks of biomass, because for a long time, and I was in this story. The story was to produce, how we can produce, and now there is a lot of stocks in Europe, and this is not a question. I can assure you. Algamo. You have also ProFuture, even in Belgium, so we're home here. They make a very good journey. Phytoplankton Marino, a success story not only for the production, but he was the first one really having a novel food story, a novel food dossier with Tetraselmis shui. And if we're able to talk about Tetraselmis shui now, this is because of Carlos. Carlos is now the president of the EABA. Vaxa, Algae cell. So you see, I have only 15 minutes, so I just go. Algicides. You have also ponds, quite impressive ponds. This is in France. This is in one of the nicest towns in the world, Nantes. This is my hometown. In France, you have 200 spirulina people. Usually this is 2 people, but 200 spirulina pounds, small companies. And funny enough, in the world, you can find spirulina from €5 the kilo, 150 euros the kilo, and they're online. All these people are online, and when they sell me for 110, they make me a favor. So you see the point, the difference between the prices and probably the quality. Surely for the quality, Spirulina du Soleil. I give you some live rain. We're in Sardinia, one of very good producers in Europe of spirulina. Very good quality. Italy with Archimede. You have here Silvio, very active in the algae in Europe. All Microalgae is producing also in ponds with the cascade and so. Alga Spring in Netherlands. And again, these are only some examples, so that you see that we don't have a big problem of production. We can go back to the real problems if you want after, but this one was not my talk. Bioresin. Bioresin are very interesting because with algae energy, they are probably the best in the biostimulants from algae. And I just finished with Spiromarine because this is in Brittany, so this is my country. And because spirulina and marine is not that easy, and there is not that many, and this is probably the most interesting story because for all the countries that have a freshwater problem, to use the seawater to make spirulina will be an achievement too. Very quick, we're very organized at the EABA level, but also at the Commission level. The Commission started a tender called EU for Algae, trying to gather all the stakeholders in Europe. So if you are not, this is voluntary and this is free. If you're not registered to EU for Algae, please go. You will be able to participate with us to the working groups. We have 7 working groups. I am, for example, coordinating the microalgae production, and each time we're something like 60 people online, and the story was what are the questions bottom up, so that we're able to bring after to the politicians, commission, national authorities our questions, and it can be in micro and macro. For that, were several animators at the senior level. The financing was around 1 million. You have here all the people that are registered in the world on this EU for Algae. So EU for Algae is not from EABA or from stakeholders, it comes from the Commission. And this is a tender, and we try to give, in a way it's quite easy. We want to help them to help us. So please participate. Very quick, because they pay me, I'm at Algama. Algama is it's important. It's a small company. We raised 22.5 million. The story of Algama is how to use algae as a functional compound in the food. So the functionalities can be physical functionalities or nutraceutical functionalities, how we can create food not only in using algae in a bread or in, but the function. And I can come back very quick. We are 40 people. We have 38 patents actually now, 22.5. We have an office in New York, but we had to slow down because of the COVID. And we have a few 4 spin-off. Our flagship is the replacement of an egg replacer called Tamalga. With this Tamalga, we were able to make a mayonnaise, but we are selling it for patisserie. So making brioche, cookies, and all of this with Tamalga, where you replace an egg with our ingredients based on algae. All of this were done. These pictures are from Algama. We have a chef patisserie chef. And I will finish in saying, please join us at the Algae Europe. Last year in Roma, this is the conference of the EABA. Last year we were 430 attendees. On all the algae, I'm fighting against this story. I'm micro, you are macro, I'm seaweed, you are spirulina. I'm fighting against. I want to bring all the, I wanted when I was a president, I'm just a vice president now. We want to bring all the stakeholders together, because I want to convince that there are more similarities than differences among all the algae. It is true for the biology, for example. If you talk about biorefinery or applications, this is the same. Okay, sometimes the production systems are different, but we want to bring all the people together. So please join us. You can still send your abstract. We said that. No, you already sent it. Good. Send your abstract. We had last year 285 abstracts sent. So we try to be representative. And if the people that are not members, if you join, you help us to be representative. And this is pro bono. We are not paid for that. So this is not a story of money. And this is not very expensive to be also part of EABA. And I will just finish with I'm finishing. So presenting myself very quick now. At the end of the talk. Time, because it's yeah.
You spoke about stocks. Why do you have stocks? What can we do with the stocks? And third. What's going on in Asia and America continents, south, north?
About the stocks, for years, we, as biologists and people developing the production of, because I was 30 years in research, and we forgot that this was a whole story. It's not only producing. Business is to sell, marketing, having people that are trained for that. And we forgot that the economy is a whole, and we were so sure that having a good product is enough. It's not enough. And now you see that all the companies now bring back people that are good in selling, commercial directors. So we need to go to the commerce to be able to sell these stocks. This is first awareness also, if we cannot talk about this, because in the world, this is not a trend to eat algae. I mean, this is not majority. So you have an awareness. apropos awareness, the European Commission with Global Seaweed Coalition is organizing in Paris the 7th October the first algae awareness summit, bringing politicians from all Europe. This will be in Paris, in Monaco, House of the Ocean, the 7th of October. They call that the first Algae Awareness Day. So bringing the public and trying to show to the public what are the... So the commercial story, we still have also to prove applications, real applications. There is a lot of work to be done on clinical trials, for example. I'm looking at Algosuo's clinical trials to show and to prove that you don't have only an extract, but you have also an active. And to come from an extract to an active, usually it takes you 3-4 years, and it takes you, for cosmetics, for example, something like 200,000-300,000 euros to prove that what you extracted as an activity here. Can I answer your question? Yeah.
Our competitors, what are they doing in Asia, in America? Do they produce also? Because this is a product. And as a product, it has a price, as you told about spirulina, okay? The others, what are they doing? And if we have a stock, this is to understand, to be understood, what we can do, what is this stock? Is it spirulina? It's not only for clinical trials. This is not a big quantity.
For those that I know, the stocks in Europe are spirulina and chlorella. In the States,
spirulina has a big price. Why don't you put the price down and the stock
I don't know. I'm not responsible of the prices. I don't know. But this is I think, going back to my point, we have to bring all the professions together, economics and marketing, and so people that are really good in economy, for example, not only in the biology, and selling is something that we biologists are not good at. And you can see that because all the universities in Europe, each time they try to give you an answer on economy, it's so funny. Each time. And I can give you a lot of examples. Even in my own institution, IFREMEA, they were very good. But we can talk about, probably I don't have all the answers either. In the States, funny enough, I am on the board of the Algae Biomass Association in the States, on the board of directors. And funny enough, in North America, there are only industry, almost no research in this association. This is very, very business-oriented.
I agree there is a lot of stock, and also in Asia you have some very cheap stocks, but what I have experienced is a huge variety in the quality. So isn't it time to have a kind of quality label for it?
This is on the way. It comes from the thinking, so the brainstorming at the European level to have a European label about the quality. But in a way, the Chinese, they give you, they are intelligent. They give you the quality you want. If you want a better quality, they will give you a better quality with a higher price. But this is because we ask for 5 euros, 7 euros the kilo that they give it.
Yeah. But at this moment, you can just buy the biomass. You have no idea, even not European biomass. They give you some kilos, and you don't know what is the history of that biomass.
I agree. We don't know. And sometimes you are very surprised of the quality. We bought some from China. The level of phycocyanin was something like 5%. Normally it's around 12-15%, and it was around 5%.
You know, we have done a lot on taste. If you compare our fresh biomass with all the commercially available biomasses, it's completely different. Eh?
I agree. Yeah. I agree. Which is, in a way, is a chance. Europe has to fight about the quality and applications. We have to put an added value because we will never be able to compete with South America or Asia in terms of hand labors and so on.
Any more questions? No? Then thank you very much. Okay. So the next talk... The next talks will be about food and feed reformulations, and I'm pleased to announce Josep Coma Posada. He works at the Institute of Agri-Food Research and Technology, short IRTA, and he's an associate professor at the University of Girona. And I'm happy to give the microphone to you.
Thank you very much. Okay, good morning to everybody. Thanks for the presentation. And now is the turn to present the results of the food and feed reformulation done in the ProFuture project. Many people have been involved in this work package. Many companies, food companies, and also research institutes. We'll see all of them through the presentation. No. Okay. We will go through the objectives and the results that we got and how we reach these objectives. Then the objectives were four. The first one was defining the technical prerequisites of the microalgae and protein ingredients. The second one was assessing the interaction of the microalgae and protein-rich ingredients in the target matrices. And the third and fourth was designing and producing food and feed at pilot plant level and characterizing the quality, safety, and shelf life of these food and feed products. The first objective about defining prerequisites, this was done in Algo source with IMA also. And in this case, we gathered information to the partners at the kickoff meeting of the project in Barcelona, of the ProFuture project, and also was sent a questionnaire to these feed and food partners to know which were their needs. And from there, the information of these questionnaires gave us already all these type of microalgae that has been presented before by Ilme, the protein isolates, purified microalgae proteins with a protein content over 60%, and also the single-cell proteins, bulk microalgae proteins with 40–50% protein. But also, the partners were interested in other properties. We can see the functional properties. Some of them, they are more interesting than others. We can see here water solubility, water holding, that are, for them, is much more important than others like foaming or gel strength. But also, for the partners, was interesting the digestibility, that should be high, the amino acid profile, that should contain all the amino acids, the color should be light, and the taste, aroma, and also it's important that the answer of these questionnaires gave that these partners would be willing to pay up to 30–50 euros per kilo of these protein isolates. And about the bulk proteins, they would be willing up to 10 euros per kilo. About the second objective, assessing the interaction of the microalgae and protein-rich ingredients in the target matrices. This work was done at ILVO with Simon. If we have any question, we can ask him and Gert. And in this sense, okay, we evaluated the techno-functional properties, foaming capacity, emulsion capacity, water holding capacity, and solubility of the different cell proteins, ingredients, Chlorea vulgaris, Tetaceum lichui, Nanochloropsis, and Arthrospira platensis, the spirulina. And of course, we got this techno-functionality under different conditions of the food matrices, changing microalgae concentration, pH value, salt concentration, and applying different processing temperatures. About results, very summarized results, just saying that different relevant food parameters have distinctive effects on functional properties, which are in some cases species-specific, and also that general trends are observable for all microalgae protein ingredients. In fact, the pH is the most influential parameters. pH being possibly correlated with foaming, with emulsifying, and water properties. We can see here, for instance, that when we increase pH from 3 to 9, all these values of, in this case, the emulsion capacity increases. And now I start talking about the all work done in this food and feed. I present the feed products, and later on my colleague Gert will present the. I will start talking with food, and my colleague Gert will talk about feed products. Okay. Then about foods. When we start the project, we had only these three strains: Smooth chlorella, Tetraselmis, Chui, and Spirola platensis. And for us to fit this microalgae to the different products we have been working was quite difficult. At the end of the project, we got other strains, all these strains that have been improved for the first stage of the project, Iago and Inma. And this helped us to fit all these microalgae to the food. Therefore, it's very important just this research of this making research on new strains to be able to fit all this protein from microalgae to the food and, of course, to the need of the consumers. In this case, we start now with the different foods we have been worked. And in this case, the company Tradizione Padane, Italian company, they had the aim of getting a vegan organic dry pasta, high in protein and fiber claims, and with a lighter color than the pasta with the spirulina they have in the market. It's this one. Several studies were done. Sorry. Yes. Several studies were done. With, in this case, they use chlorella, smooth chlorella, honey, new honey, and white chlorella. Also Tetraselmis chui, different concentrations. But also they studied, or they tested gluten just to help reaching this high protein claim, and also fibers just to be able to reach this high fiber claim. In this case, at the end of all the results, they end with the final recipe, that is the one that has been scaling up at industrial level, with fusilli, and it contains 3% of smooth chlorella and 5.2% of organic apple fiber. In this case, they found that it was not possible to reach a claim high in fiber only with microalgae, and they choose 3% of microalgae just to avoid fishy flavors or this type of aspects. And when tried to add gluten for increasing the protein content, it showed that it didn't give good results. Just bubblegum-like texture and of some of flavors, and they skip. And this is why finally they decide to get us a claim source of protein. While in fiber, only the organic apple fiber was also they got good results. The other fibers they tried, they didn't get good results. This is why it's high in fiber. The next product is the microalgae soup development. In this case, the Swiss company Algae. They aim at also to have a vegan organic clean label with a carrot ginger flavor, high in protein claim, and with a long shelf life. This is why it's dry powder form. In this case, also several studies were done. They make the studies with smooth chlorella, honey chlorella, new honey, and white chlorella. They also tested ingredients like pea protein, just also to reach this high protein claim. They need also orange carrot powder from GODN just to improve color, playing also with the color of the microalgae. And for the flavor and taste also they had to play with some carrot aromas and several spices just to get the final product. Is the one that has been scaled up, a soup with 5% of a new honey chlorella. The next product is the microalgae sausage, the plummet. In this case, the German company Viva Maris, they aimed to have a vegan sausage with a low impact to taste and also light colored to avoid a green sausage. In this case, they work also with several strains: golden chlorella, honey chlorella, new honey, and white chlorella. We can see here that when they added 3% honey chlorella and new honey chlorella, the color was too yellow for the goal. While when they work with white, 3% white chlorella, the color was nice, but not the taste. This is why at the end they choose the sausages with 3% of golden chlorella, and this is the one that has been scaling up at the industrial level. Next product is the microalgae baked goods. In this case, the Portuguese company Calais, they had the aim of increasing nutritional value of their products with a low impact to taste and the aspect. And during the work, it was optimized the formulation for the different baked products. In this case, grissini, cracker, crouton, muffin, and brioche was studied, or yes. And they apply, in this case, only spirulina, Arthrospira platensis, as smooth chlorella and tetaselmis at different concentrations. And then, after the sensory analysis and consumer studies, they selected to scale up these three products, the grissini and croutons with 3% of chlorella, and crackers with 1.5% of spirulina. Still more work should be done with muffins and brioche, maybe also using other strains just to help changing the color and the aspect. The next product is the vegetable cream with microalgae. In this case, the Spanish company Cutarra. They aimed also to have a vegetable cream, a high in protein claim, and with a texture similar to the one that they have in the market. In this case, also we did different studies and different strains were checked, were studied. In this case, we see how the color is affected by the strain use. You can see here tetaselmis and spirulina are the darker ones. But the same, the taste and flavor was changing depending on the strain. The consistency of these soups, in this case, we work it between 1.5 and 6% of concentrations just to reach the high protein claim. And in this case, increasing the microalgae content increased also the consistency. And just notice that tetaselmis 3 is the one that has the stronger fishy color and salty taste. And because of this, it was discarded from this type of product, a vegetable cream. It didn't fit to this one. And this is due probably because it's cultivated in salted water. The final recipe that has been scaled up is this cream with 1.5% of spirulina. And the last group of products is the sport bars and drink. In this case, Enervit, Italian company, they aim to improve nutritional properties of these products, protein content mainly, of sport bars and instant shake meal replacement. And also, several studies were done. In this case, we show one study with different strains at different levels of addition, and the same. The color it depends on the strain, the same taste and flavor, and the level of addition also enhance these effects. Also, a point about the candy attribute that gave some of these microalgae that is good if you think to develop sweet products, so can be good developing this type of products. And also in Airbit, they scale up 2 products. One, sports bars with 5% spirulina, and an instant shake meal replacement with 5% of chlorella. In fact, Marie-Christine told me that we will be able to taste these products tonight, I think. If you want to go deeper to results, there are some publications going on. Some of them are already published, and okay, they are open access. Yes. And just ending this food part with some remarks. Well, just saying that the addition of microalgae ingredients to food products is feasible, that research and development must be done to adapt the best microalgae strain to the food. It's not so easy. You must make some trials. And also very important that newer strains must be developed to facilitate the addition of these microalgae to specific food products. Also, spending just the protein isolates is needed to be developed and tested. And finally, just saying that the price of microalgae ingredients may limit a general use in foods. That's it, and now I give the floor to my colleague Gerd Bruggeman. It's fine that he will continue with the feed part. Is it okay? Thank you.
To ask questions before or at the end to both of you?
Maybe at the end we'll see how the time we have.
Okay, then Gerd works at Nutrition Sciences and co-innovated innovative ideas resulting into the extensive patent portfolio of the company, and he will talk about feed reformulations.
Thanks for the kind introduction. Indeed, next to the food part, the feed part, myself, Gerd Bruggeman, one of the private partners in the consortium. And why did we join this innovation action? Indeed, to bridge the gap from algae, what's known from theory, towards real application. We are based in Belgium, and indeed 2 sections, why feed reformulation our business, and the next one, what about the feed reformulations. Now, why feed reformulations? Because we are in an urgent need for new types of protein sources. Today, we mainly use soy, as you see, as major protein source. At the moment, 80% of the global soy production goes towards feed. So it's an enormous amount. And when we talk about Europe alone, 25 million tons of feed or soybean meal is processed in the animal feed, and 15 million tons of soybeans are going to that direction. So it means a lot of soy is used. And the other one is indeed fish meal outside the European Union. The animal species where we talk about today are the terrestrial animals, pigs and poultry. So we were mainly involved in the pig feed formulation, which is huge volumes. Ilsta more in the poultry feed formulations. And then we had also partner Vitafor, who is present there in the back of the room, dealing with aquaculture, so carp and catchfish, and then shrimps represented by Inve, by Celine, also in the back of the room. Now, indeed, as we all know, we are looking for sustainable solutions, but Marisa will talk later on about the sustainability part. Are they at sustainable and to what extent? Because indeed, soy is mainly related towards deforestation. For sure, a lot of efforts are already made in that field. I mean, there are already existing responsible soy, so a lot of efforts by major players are already made. In the beginning of the project, this was less the case. On the other hand, fish meal is produced to produce fish. So it's even some kind of cannibalism that is used. So in terms of ethics and sustainability, a lot can be discussed over there. Now, to cope with the sustainability goals of the United Nations, as well as the Green Deal in the European Union, this was our commitment to the project. Now, there exist already some alternatives. Today, a lot of effort is based on the first one, biomass. Using biomass from all kinds of food industries in our business. Think in terms of DDGS as an example, the distilled grain solubles. Whey permeates cheese production, produce a lot of whey. Distilled grains from the brewery industry of distilled yeast is also already used in our business, but still has a lot of bottlenecks, mainly drying, because our business is a dry market. There's also a shift towards liquid feeding at the moment, but it's still a problem. The other one was plant-based proteins, leguminosa, the lupins, the faba beans, all these kinds of vegetable alternatives. There we still have also some issues, yields in Europe, because it's mainly produced in Argentina, Brazil, and so on, where the climate is good. In Europe, we have a standstill at that moment. We had a standstill. Now a lot of efforts are made in that respect, but okay, still a lot of work to do. Single-cell protein is the other one. So single-cell protein in terms of fermentation, so fungal biomass as an example. That's also good, but yeah, still some work to do. Like for instance, in Belgium, we have now some nice initiatives that are coping with that. Still some grouping there, but still a way to go. Insect proteins. These companies are booming now as well, but still some bottlenecks. And then, yeah, what's remaining? Macro and microalgae. And that's indeed why we are in the project, to see what we can do there and to see where we can bridge the gap towards the real implementation. Good, so ProFuture has a role to play and a right to play. So that's an important point. Good, the second part is we try to formulate this algae that we receive from the ProFuture partners into diets, because there it starts. We can do a lot of animal trials or thinking about replacement, but when you cannot formulate them, then you have a problem. So in first instance, that's the feed production process, so a lot of steps where we have to cope with, because it's a dry market. It means it has to be compatible with feed solid materials, with minerals, because we use a lot of concentrates and premixes, so very aggressive raw materials. So we have to check the compatibility with these types of raw materials. So this brought us to assembling samples from the partners. As you see, limited amounts in first instance. And okay, thanks to the partners here also present, we received them in good shape, and we focused on single-cell proteins, not on the isolates. Why? Because isolates are too expensive. When we look for the moment, the benchmark for price, when we use soy more or less, we count around €1.5 per kilogram feed. It's not a lot. So it means we have to make the exercise not too difficult. We have to look for the best feasible production, best feasible solution. So what we did is we received the different algae at the moment, and then we mixed them in different feed matrices. Simple feed, so simple feed, low aggressivity, till very heavy feeds. Heavy feeds where, for instance, you have a lot of hyaluron chloride, and there was a question already earlier about the antioxidation power or the oxidative power of the algae. This can be harmed by these types of minerals. And then we try to replace part of the protein, because it's utopia to think that we can replace all protein. Because when we see the volumes today available in the market, they are still quite low. I would be already happy if I could replace a few percentages of soy or fish meal. So we did different substitution degrees and different temperatures. And you see temperature is increasing year by year in the European Union as well, and not only outside the European Union. So we have to take care that at least the shelf life of the feed is 6 months. It's a lot. 6 months, this algae has to be stable for 6 months in the feed. So that's why we accelerated it by higher temperatures and saving them also for 6 months. And that's the last line. Different matrices, as you see. So the conventional raw materials were presented, barley, corn, so the carbon sources. And then soy meal was replaced by the algae sample, sorry for the Dutch language, or mixed Dutch-English. Yeah. And then indeed replacement and the samples. And then indeed characterize them for visibility. It's easy to mix them, but when they are there, you cannot do something with them, you have a problem. Yeah. So what we looked for was the particle sieving distribution, because we don't have something in silos that are blocked. It costs a lot of repairing, maintaining the silos, so we have to take care that it works there. The free flowing is as important, because we are working with powder technology. Yeah. Then the visibility. we export a lot of products, and as you have already seen, the color is important. Green as an example, you have to change that green stays green. That green does not fade towards light green, because then we have a quality issue, especially in the feed business. And the hygroscopicity. Humid climates, different climates, so it can attract water. So a lot of potential bottlenecks. What were the major conclusions? Particle size distribution difficult to measure because it's quite sticky, it's still wet, quite a lot of wetness, and hygroscopicity. The free flowing, yeah, we could solve this by adding some silica. So that at least the free flowing of the feed was okay, but silica sustainability is another question. And the visible stability, in the beginning we had some problems in terms of stability. I mean, the color faded away. You will see it in some next slides. But okay, this was solved by looking for the packaging as well. The packaging that we have light, tight, and airtight packaging. This solved the problem. As soon as this was not the case, then you had a problem. To some pictures here. Here, that's the starting point. And then you see some color changes happening during conservation for 6 months further. Yeah, this is the feed, and we did similar for concentrates. So we did a lot of measurements at the end, and we saw a lot of changes, but we could, at the end, control it. I think that was important by looking for the good packaging and the good mixing technology. Hygroscopicity, the same. As you see, no standard light, and it depends on the type of algae. Some increase hygroscopicity, others decrease it. But when it becomes too dry, then you have also problems. Then you have humidity disintegration, what causes huge problems in industry. So in other words, after 3 months, all samples showed a decrease in quality, mainly due to the presence of minerals that were present. But at the end, indeed, we could solve most of the problems. And we did not decide to work together further with Tetracelminus in our case, because indeed we saw also some strong smell. Sometimes it tended to a rotten smell, but okay, what's rotten? It depends on sensory characteristic. But it's very sensitive for piglets. When a piglet doesn't like the smell, it does not eat. So no animal production, no meat. So I think that's an important point. At the end, we did some trials. We mixed them, and the story is told, I think, later on by Alex, what were the results. So in other words, we succeeded. Then scrimps, done by INVE. The trial is still starting with scrimps in Ecuador, as I understand well, at the other side of the world. The good news is we were able to formulate diets with that as well. This is a nice opportunity because the less possibilities in piglet feed, because we need the volumes. For scrimps is another story. Scrimps, we enter more a niche market, and there indeed that's less crucial, the volumes. Then a lot of work was done for poultry feeds at IRTA, yes. And sorry for the messy slide here, but what we want to show here is that we checked hygroscopicity, the flowability, the particle and this in vitro digestibility. And at the end, indeed, we were able to formulate diets out of that. They all showed some different characteristics of that, but by good management of the feed composition, the good composition of the feed, we could also formulate diets out of that, and also the results will be presented by Alex after this presentation. Last but not least, Vitafor, who made some nice feeds as well, because there is an extra challenge. Because some feed has to sink to the bottom, other ones has to float. So there we have indeed also to see where we manage not only the composition of the diet, but also the physicochemical characteristics of the diet. So for the carp trials, indeed, some good feeds were formulated, including 10 to 20% algae, and the same for the African catfish. And also there, soy was indeed the replacement. So there was a successful control feed production. It took some time, but at the end we managed it. So thanks for that, Vitafor. And then at the end, there was an identification of the 2 most promising algae strains. The other consortium members mainly worked with Nanochloropsis, because this was the best one. Why? Also because we have learned that it causes less physical interaction in terms of viscosity. We have to avoid viscosity. In the gastrointestinal tract, when we have too much It's not an earthquake, I hope. So Belgium and earthquakes. We have to avoid viscosity in the gastrointestinal tract, because this can delay digestion. When you have too much viscosity, that's why we also look for tetracelmines. Here, indeed, we worked with Nanochloropsis and Chlorella, and also the trials are now finished, I think, Marton. So also some results will be presented by Alex. Here you see an example of the two different feeds that were formulated. The one sinking for the carp, because the carp lives at the bottom of the water, and the African catfish, yes, lives not at the bottom, is floating. And as you see, they were able to formulate good diets with these algae. So the technical suitability of the production was good. The good water quality is good, because the leaching effect has to be measured, and the dissolving in water. This was cross-checked, was checked. And then the good nutritional value, and here you see again the formulations that will go into the animal trials. So that's in a nutshell. So in conclusion, we could formulate diets. This was the first surprise, and that we could do that. And now, for sure, they have to perform. And this, you will see the results in the next presentation. Thanks to all partners, especially Vitafor, for the patience in first instance, and thanks for the great work done. Invi as well, looking forward for the trial results, more to the end of the year. And then IRTA, for sure, the poultry trials are done already. Some first chicken fillets are checked, and also some surprising results. But this will be explained by Alex. Thank you. And some questions.
Here is a place.
Proposa Josep is joining. Yeah.
For lots of questions. First of all, you, the scientists of Europe in this field, you are doing a very tremendous work. But there are a lot of questions. For example, you speak for proteins, and the proteins, the animal proteins. Here we don't have neither an animal nor a plant. This algae. So we don't know what's the absorption. If we get this protein from this kind of organism, what's the absorption in us? Second, you are oriented, you are speaking a lot of times, because it's connected with sugar, with glucose and gluten. And in gluten we have problems in the research on the health sector. Especially we know for sure for celiac diseases and for diabetes, and we are researching on the cancer issues for the gluten. And also you are mixing pastas and all this kind of stuff, which lately on the research of the Alzheimer and all these kind of diseases, we have a problem with the amyloids, because they create holes in our brain. So it's a bad news for pasta. Of course, you can eat pasta and mixtures of pastas every 6 months or once. For the Italians, it's not a good news, but it's the science in this way. And about the spirulina, you speak for after 3 months there is an expiry date, let's say. But on the trade, when we buy spirulina, even on pills or on powder, they don't have an expiry date on it.
Yes, maybe let's start with the first question about digestibility. Digestibility trials are done, you're right, and I think Alex will also refer to these trials, as I remember well. If not, I can explain. Yeah, so then I will explain. So indeed, some digestibility trials are done, both for humans but also for animals. When I refer towards the chicken trials, and when we have the results from IRTA, please feel free to comment, Josep, on that, then we see indeed a decrease in digestibility. So I think your remark is right, that we see an initial decrease in digestibility. And in the meantime, since yesterday, the trials in piglets are also finished, and I did not yet process all results, but the first impression is going in the same direction. So indeed, we have to take care that some new types of anti-nutritional factors pop up by using microalgae. That's for sure. Another type of anti-nutritional factor that can happen in the gastrointestinal tract of animals, and now I'm talking about animals because for humans it can just be it can be an advantage, but in animals it's a disadvantage because in animals you want to increase digestion because the more protein you give, you want to have it transferred into meat, more meat. So we have to increase the digestion. What we see, and that's also why we look for tetracelminis, nanochloropsis in that respect, was looking to lower as much as possible the intrinsic viscosity in the gastrointestinal tract, to increase the potential digestion of nutrients, including minerals. So this was why we choose nanochloropsis. But indeed, you're right. I think in terms of digestibility studies, we need some further profound research on that before we implement into the market. The other questions were more food-related, I think. Yeah.
Well, about pasta, you said.
Amyloids, not only pasta.
Yeah.
And also the gluten.
Yes. Yes, of course, we didn't take care of these things. Many work should be done on this. In fact, I took away a remark in the presentation in this direction, that research also and development must be done in this direction to know exactly which health benefits or this inconvenience that may happen. And yes, also about this digestibility. Of course, we don't have the level of a meat protein digestibility. Then there is a lot of things to go forward and to make research a long way. Just this.
Thank you. You looked at pelletization. In aquaculture, extrusion is the common method. Did you look at the effect on extrusion on the algae?
I have to check with Celine on the extrusion of the fish. If you observed some specific abnormalities or things like that. No. Okay. Yeah. Yeah. Indeed, at one side you have indeed the microscrims.
So for us it's fine. But also, we extrude and we break and sieve because we are really in the larval stages. So we are talking about particle sizes smaller than 100 micrometers and between 100 and 200 micrometers. So this is very, very small.
Yeah, that's true.
So it's completely different, while Vitafor needs to have these specific characteristics of their particles. I think maybe they can find some.
Can you comment on that, Martin? Yeah, I will give the mic.
Yes, sorry, what was the question?
What's the effects of extrusion? If you see an effect of extrusion on the feed composition, effect of culture.
So, yes. Well, the influence of extrusion was quite interesting in this topic because first our main aim was to see if the feed can be extruded at all, because with some algae strains it was not possible or was not homogeneous like tetracelmis, as Gert mentioned it before. But well, at the end our main point with these particle sizes was to meet with the requirements of the fish, basically, because we discussed it with our colleagues, and with these extruder machines we had to produce as big pellets or extrudes as it can be consumed by the fish. It was successful. It was well extruded, so we had no problem with this, and as Alex will show it later, it was no problem with the feeding experiments as well, so the fish could consume it and they grow quite well.
Thank you, Martin. And indeed, for the terrestrial animals, we have poultry feed and piglet feed, but that's no extrusion. That is best case pelletization. We did not do that. I mean, we used the Belgian formula, so then it's meal as such. We do not use a French formula or a Dutch formula in that aspect. And for the poultry feed, yeah, most of the time it's crumbled feed. So this is less a question. But as I learned from Martin as well, from Celine, indeed, the extrusion did not pose huge problems.
Yes.
I just wanted to make a comment about the digestibility, because in these trials we compared nanochloropsis, the whole biomass, so not the protein of nanochloropsis. We compared the cells with the protein of soya. So it's a disadvantage of nanochloropsis.
Use a whole cell, you still have to break the cell in terms of digestibility. Indeed, it's a confounding factor. You're right. Yeah. Any other question? No? Oh, yes. Sorry.
Yeah. You mentioned in your presentation that the nanochloropsis and the chlorella are the best strains. So I would like to ask that at what percentage can it best replace, for example, soybean meal in parameters such as digestibility and growth performance for...
Yes, the fact that I will not talk about the clue of the presentation of Alex. I will keep the cliffhanger over there. Okay. But indeed, we tested different percentages, and depending on the animal species, the results are different. That's what I can say, but the details...
going to mention, like, for example, in piglets.
Yeah.
Let's say in pigs, for example. Yeah, like...
In piglets, I have relatively good news. You will see it in the presentation.
All right, thank you very much.
Okay. If not, okay.
Then, thank you very much. Thank you. And we're going to continue with the panel discussion now. We will take just a couple of minutes to bring in some chairs. And I would already ask the panelists maybe to come to the front, and Fabio as a moderator. Can I give you one microphone?
So, good morning, everyone. I'm Fabio Fanari, and I'm the project manager of ProFuture. And also, I'm the pleasure to be the moderator of this session. I will try to do my job without thinking that I'm the project manager of the project, so to be not in my position. So I think this project had two main goals. One was to develop a product that can be presented to the market that were, let's say, attractive for the market with a competitive price and properties. And the other one was to bring this product to the market, so to meet the consumer taste, to elaborate strategies of marketing, and also to see which are the legal barriers to bring this sometimes novel foods to the European market. We have seen a first session of presentation where we focus on the first main objective that I just remarked. That was, as I said, the development of products competitive and ready for the market. So we have seen that we worked on the microalgae cultivation, on the development of single-cell protein ingredients and protein isolates, and then in the last presentation also in the integration of these ingredients into foods and feeds. So the question, I think, we will try now in this panel discussion to summarize this first part of the conference, and the main question is, as already Imma also told, how far we are from our objective. So, which was the advance that ProFuture provide in this topic. And I would like to start the discussion with a question to Iago, because we have seen different improvements in the microalgae cultivation, both in the energy consumption reduction, in the development of new strains. And I would like to ask you, which do you think are the more interesting to lower the price and continue this challenge of bringing microalgae ingredients in the market, or if it's a mixture of all these strategies that is better to follow, or a comment from you about these results?
Mike? I think it'll be better. Thank you for the question. Yeah, we have been talking a lot about it in our group for the last at least 10 years since I've been working there, but for the last 25. And to see the development of the sector and of these issues in the last 5 years, it has been quite impressive. Short answer, I think, and I think everybody here would agree, but please feel free to add your contributions as well. It's a combination of things. And number one is to get rid of the electricity costs, unless you are in a place that has very cheap electricity. That can be done via some of the strategies we presented here. Optimization, operational changes in your process to make it more feasible, more efficient. Of course, organisms that can grow faster are more adaptable, have less necessity of cleaning up the facility or breaking down the facility. But there is one issue that came to the world recently, that artificial intelligence, but it's another take and another approach to the issue of automatization. I think automatizing also, it's removing the human resources that you need to run a factory, so the production is very expensive, and in some cases it can be close to 50% of the cost, the production cost, have to do with salaries. Not entering in discussion of if you are going to lose jobs, but a combination of these factors, I think. Yeah.
Okay. And linking with this, with the results that you present, we have seen different strains of chlorella and also the Galdieria. And about this, I have a question for Jean-Paul. That you are in contact with different companies of producing microalgae, and you, in first person, are involved in this field. What are the microalgae strains and, let's say, species that are interesting for future novel food application, that you heard from producers that they are interested in going on for this process, and they are interested in cultivation of this kind of species?
It's not easy to talk about the future, because usually we are wrong, and each time we talk about the future, we can have impressions. So what I know is there are applications as a food for Phaeodactylum, there are applications for Galdieria. I think it's linked to the fact that if you find a fantastic algae, to make a dossier as a novel food will be not easy, but will be natural. So if you have a fantastic product, you will go for a novel food dossier. There is an evolution anyway. You saw that chlorella now, the 6 or 7 or 8 chlorella are food because it was proven that they were eaten before 97. We're going to, I hope, make the same thing with spirulina, maxima, fusiformis, and all of the things this year. So there are trends on that. Now, you could choose also to have a market in the States and making a grass dossier, which is easier. So this is, and we think that for microalgae we go to the million. So there is plenty of place to find original and interesting algae.
Okay, thank you. And I don't know if there are some questions from the room. If not, okay. Mari, can you bring a microphone?
What you told about the production costs, these are logical in a science or let's say industrial sector which is new and is still experimenting. But you are rich and you don't know because you have the stock and the stock has a price. And when you put the stock working, this can finance the research from the private sector and it can decrease the costs of the production. So the matter is what kind of stock is this and how many years exists and what are the conditions that the stock is. Now the markets, it's a simple marketing way to fund, especially in our era where we have ecological ways of thinking. But the standards of the product, I don't know also in what level are they.
The story of the stocks. I just know that there is stocks. It's difficult for me to talk about the economy. Probably you are better than me. I know that there is stocks and that everything comes back to prices, the cost of productions. If we were talking this morning about the soy, what is the price of the ton? So it's very low, and there is a big gap for us. And again, if you want to compete with our raw biomass against the raw biomass of soy, there is a big gap. So that's the reason why we have to put value on this biomass. Otherwise, I cannot answer to that question because this is not my job. Somebody probably in the Olivier? I know, okay.
Olivier Lépine from Algae Source. Iago, you mentioned the cost of electricity. I would say that one of the main costs is water. We need to deal with water. So one way to decrease costs is to decrease the amount of water in the system. Are you working on this and where are you on this axis?
Thank you. Genuinely, thank you for the remark because that was something, Elena is looking at me right now, that I was not able to fit in the presentation. Actually forgot. We tried inside ProFuture water recycling trials that was done at pilot scale at all microalgae. We know that it's common practice in many water-based industry, aquaponics, hydroponics, microalgae falls somewhere in between there, to recycle the water. After a certain amount of cycles, people use the term usually recalcitrant effect. That means there is something in there that it's hindering the growth or collapsing it. Some things that you can bypass with a simple water treatment technologies in your, like activated carbon filtration. But that was something that we did in the ProFuture and needs to be better understood. It seems and sounds like a straightforward thing. Oh, we're just going to recycle the water, clean it. But it's not that straightforward and difficult to change when you have already established process that uses only, let's say, clean water from the local supply. And the same is valid for using, let's say, waste streams that are basically a little bit dirty water. So sometimes we have residual nutrients that is another possibility as well, and that we have more efforts coming in the last few years at the levels of European projects, cooperations with companies as well. It is an important factor. Thank you for reminding us of that.
So there was a question about the price. So I have one for Ima. And you show that the yield of the protein extraction is, let's say, quite satisfying comparing to the soy in terms of extraction of proteins for kilograms of biomass. But what about the price and your strategies to lower the price and see if also the price can be competitive compared to other protein isolates?
My microphone? Is it fine? Yeah. Well, lowering the price, we are related to the raw material. So actually, if we can get a raw material with low price, it's impossible to produce isolate with good price. That's the first point. So there is a work to do on the raw material, on the entire biomass to reduce the cost. And then the yield, I showed that we had good yield, only for one strain. Actually, it was spirulina. And yes, the yield was comparable. The cost of the extraction was not really high, but this is something that will be presented later, probably. I think that for the moment, the good investment for us for producing protein isolate is really targeting the right strain for the extraction, because we saw that spirulina was adapted for the extraction with sustainable process, but the protein produced were not appealing in terms of color. Probably we can have another strain in the future that is really adapted for the extraction, and in the end we could maybe achieve, a product with the right quality and even acceptable price. But there is work to do, so I think that we should not focus on the strain that are now accepted as food or novel food, but maybe we should go further. And of course, the regulation in the end can be a bottleneck, because already in the project we decided to focus on these 4 strains that are accepted as food. But there are many opportunities outside these strains, and maybe our right strains can be out of this list. So it means that if we find something interesting in the future, we should be aware that we have to finance a novel food dossier. I agree with Jean-Paul, so we can finance something if we think that it's really important and we find the gold in protein isolates, but it's really expensive for the moment. So let's imagine we asked for a price, and if we want to support all the analytical part and the consulting service to achieve the novel food dossier, it's like 300,000 €. That's quite important for, it's relevant for a small company. So we need to boost the sector. We need some help on this point. I don't want to say that, European Commission or the government has to finance the novel food dossier for all the little companies, and neither that we have to put all the microalgae strain as food grade strain. But I think that we need some help here. We need a kind of centralization and regulation on this point, so that we will have fair, price for small company. At least we can, we can ask European Commission to centralize and fix some certified laboratories for the analysis that are applying right prices, or even select some consulting company that can really help little company as the one of the project to achieve a dossier. And another point that I want to underline is that, when we perform extraction, actually, even if we are starting from a raw material that is accepted as food, our extract is not considered food. So it's really tricky. It's a tricky point. So each new extract, each new protein isolate has to go through the novel food regulation. That is a cost. Last point, if we want to go faster on this point, on this project, on the production of protein isolate, I think we also have a possibility is to use some residue for the current extraction, because in Europe and even out of Europe there are already companies that are extracting high-value product from microalgae, high-value molecules, and they produce some residue. They are not valorized in most of the case, so we can focus on that residues and try to use them directly as protein sources, or even extract protein and produce protein isolate. But of course we should take care and analyze the quality of the residue, because sometimes we can have development of flavors in the residue, or increase of microbial charge, or accumulation of toxic compounds. So we need really to analyze the residue case by case if we want to take this direction. Don't know if you have comment about that.
Dario.
Just a brief comment about the costs of a novel food application. Actually, the main costs are related to toxicological study, in my humble experience, whereas consultancy can be much less costly in respect to what you said.
We can ask for other, we learned about that. We will ask for other partnership with consulting company, but that will be good for people that don't have knowledge about this field, to have some suggestion from the European Union or for other organization.
So very quick on that subject of the European Commission helping us, we have tried hard. And we had projects. We asked the European Commission to help us to fill in for 30 algae, and we made a survey with all the members. What are the 30 microalgae that you would like to have as a novel food? And we gave that, and we made the project, and it was very long. It was very long, and we discovered after that the European Commission is terrified. Totally terrified, having to be sued or to go in court with one company saying the algae I want is not here. You are helping companies and not me, and so in that sense they say we do nothing, and they stopped everything. So we're trying in another way to bring this list of algae, but this is very tricky.
Let's say that for the protein isolate or extract or whatever, we will have the same problem again, because accepting algae, the entire algae doesn't mean that the extract or the isolate will be the same, will be accepted. So I agree with the European Commission. We are facilitating someone, but
because you talk about protein, tell that to the people that are selling nanochloropsis, for example.
Comment right there. Can you? Okay.
So about water recycling, there are some microalgae that are known to produce exopolysaccharides and exopolymers that could be challenging to isolate. Could be a solution, for example, to grow first an autotrophic EPS microalgae and then a mixotrophic one with the EPS water remaining.
So I think Iago is the man for this question.
Well, if the person is listening, thank you very much. That's an interesting idea. We're going to write a proposal on it. There are of course, some knowledge about the EPS producing microalgae. Some of them, the exopolysaccharides, as the name says, they're carbohydrates, and they have different lengths and compositions. Some of them might be too big to be consumed by microalgae directly. They might require some treatment. They could be also processed by other microorganisms. But I think the starting point is to consider the composition of the exopolysaccharides, known as EPS, and start from that. But certainly, it's a possibility. but not every one of them produced that high amounts of it.
There are 2 companies in Europe selling EPS as a medical device and selling it.
So that's why people don't treat it, so they're selling it.
Follow-up question from the same person. That is, this follows an agriculture model of rotating crops. Is something in this regard already tried?
I will continue. Let's see if somebody else wants to add. Rotating the species, actually Necton did that as a result of another European project. And they do that also in all microalgae. The seasons change, we're in temperate areas. So it's common practice that they have a winter strain, a summer strain, and that's sometimes a challenge because you would like to have your summer strain growing all year round because maybe your summer strain produces something that it's a high value and very interesting. And that requires modification of the strains, of the process. But this is, I think, kind of common practice, yeah.
Any other comment? Right there.
No, there are simple questions. We have 25,000 species of algae. Why do you discuss about, are you discussing about 30 only? Because artificial intelligence could assist this on the database we have on the materials. On the raw materials, we have the...
Can you repeat the question, please? We couldn't hear it.
We have 27,000 species of algae. And we gather as humans the 30 because our research doesn't have the funding. Why don't you use artificial intelligence where the Commission can assist you with a database like we have on the raw materials? We have a database of all the raw materials. And as second, you have problems of the costs because you spoke that the CO2 is very expensive. And also the water, somebody mentioned. But there are solutions, circular solutions with the photovoltaics also, where we get methane, which is cheaper, and there are, with pyrolysis, we can divert to CO2. And the CO2 also, we can divert it to methanium and water. But I don't know if these needs feasibility studies to. I don't know the costs of your way and the cost of buying the CO2. I don't know this, but there are circular methods to production of CO2.
There are a lot of questions actually. We don't know how many species there is actually, because it depends on which publication you take. If you take Norton, it says 200,000. If you go to the biological stations like Antordon in Napoli or in Roscoff, or my colleagues think we are go over the million, but this is not published. Michael Gairy was very, very angry, and he says how many species there are. I think he says 35,000 point something. So we don't know exactly, but there are a lot. Now, why we choose this 30? This was a survey. If I would say here, what is the interest for you? Which species you would like to see as a novel food? We make a survey, and with this list, with a poll, and we say, okay, we choose this one. It might be that you choose another because you find that fantastic for an EPS or an exopolysaccharide, something, and this is your story. But we have to be, as EABA or our European Commission, we have to be consensual. Talking about the prices and the CO2 and all of this is quite a tricky story. I'm not sure I have the time to talk about, because, and you mentioned that, a production culture, a medium, is very loaded in a lot of things. A lot of things. You cultivate your algae, and you separate the algae from the water, and I come back to the price after. You separate, and you have a medium with very rich in remaining nitrogen, hormones. That's the reason why if you use the medium, remaining medium, as a biostimulant, it's worked quite well, because you have a lot of things that are still in there. And if you use this medium again to produce again the algae, you bring a signal to your algae that they are in an old medium. And this is very, very, very interesting. This is signaling, and you make a new production, a new volume with an old volume, and the algae, they have the signal that there are a lot. And this is very interesting. There are publications on that. Now going back to the water, and I finish. our story is a drama because you pump a lot of water, you move a lot of water, and you get rid of a lot of water to get 1 gram per liter. And this is a real cost.
Okay, thanks for the discussion. I have one final question, just to talk a little bit about the food and feed reformulation. So I will start with Giuseppe, and I would like to know from you which were the challenges that you faced in the project, and which are the things that we should do in the future to see microalgae products in the market, and to see the end of the microalgae product as a niche product for the market.
Of course, to integrate, to feed the microalgae to the food, it depends of the microalgae, as we have seen. If you have a microalgae strain that helps you to integrate by the color, the taste, and the properties to the food, this makes easier to this integration. Okay, this is one thing. Of course, there is the challenge of getting new strains just to help this, and just focus, as Ima told before, focus to the protein, to isolate protein, also focusing to have for the food, the target food. This is two things. And of course, when you say when on what must happen to see the protein coming from microalgae to the food standard, no? As soy protein. Okay, this is, I think, a long way to go. We must follow step by step, just doing these improvements, and make the system, microalgae system, sustainable economically and in all the aspects, and just step by step. But I am positive in this sense. I'm sure that maybe someday will be a source of protein, or it can be a source of protein for food also.
Okay, thank you. Gert, any remark about the feed? Which are your impressions for the future?
Yes, I will be short. I agree indeed with Josep on the protein volumes. It's a dilemma. I mean, we need huge volumes. We are not yet there. We need several new innovation actions to deal with that, to bridge the gap towards practice. But I'm hopeful. What I mean, I may be born too early, but at the end, I see also some possibilities when we include it in low volumes, like for instance the scrims, where we work with the young, it's fingerlings named, the small ones, where you're really entering a niche market. I think that sounds like music in your ears, Celine. And at the other hand, also for terrestrial animals, but not as protein source, because there is still a lot of functionality there. For instance, antibiotic replacement. We are still looking for a lot of substitutes for antibiotics. And algae, not only microalgae, but also macroalgae can offer a solution over there. And this will allow a higher price, a higher inclusion. But this is another type of project that we need for that. So I'm quite optimistic, but as a protein source, I still have a lot of questions.
Okay, thanks to every member of the panel discussion, and thanks everyone for joining the conference. Now we will continue with the lunch. For the details, Marie, please.
Thank you also, Fabio, and also to the audience for all the interesting questions. We have now about an hour lunch break, so we see you back here at 1:15. And exactly, again, on the first floor, downstairs. See you then in an hour. Is my mic on? Yes? Okay. So I know it's not easy after lunch break. We're all a little tired. But there's another coffee break later, and we also have a stretching break to stay awake. So I would like to introduce you now to our next speaker, Alexandre Rodriguez. He is a biologist with a passion for biotechnology, and he has a doctor in aquatic organisms. And now he's working as an innovation coordinator at Necton, which is a microalgae company in Portugal.
Thank you, Maria-Christine. Thank you very much for the presentation, for the invitation to be here presenting our work. Not this one. Not this presentation. The one that says Necton.
Yeah. Production at industrial scale.
Yeah. Do you need help?
Ja, dat is lastig zitten, maar ja, ik kom nog uit de generatie dat deed.
Minutes.
Nou valt het mij nog mee wat ik nu opgeschreven heb, maar meestal kan ik het zelf heel hard mijn best doen om het terug te lezen. Ja. Dat is wel beter aan de nek. Die noemen een paar dingen die veel beter zijn. Het veiligheidssysteem is veel beter. Ja, die directe koppeling, dat heb ik wel eens begrepen tussen hard en software. Hè. Dat kan nog, dat hoort bij elkaar. Dat je mee kan. Ja, dat is wel fijn. Dat ga ik natuurlijk niet bij wat ik aan vind. Dat heb ik er moeite genoeg mee. Dus, ik heb dus maar binnenkort nog wel ik heb er echt tegen gezet.
Hello? Let's go. So this is the presentation that some of you are expecting with all. So I will go through the objectives of this work. It was focused on the food and feed production at industrial level. And from the objectives of the work, then we have 4 outputs that I will go into more detail. So the main objective of the work was to demonstrate the feasibility to produce at industrial scale in a sustainable and affordable way 4 main outputs. The microalgae biomass that was mainly dried, the protein isolates from these microalgae, also innovative foods with the microalgae and the innovative feeds. So now entering the first output, the industrial cultivation and the drying of the microalgae. To achieve this cultivation, we got the inputs of the work that Iago presented already. We also got inputs from the sustainability assessment that we'll presented later today. And we basically, the producers that were Necton and Al Microalgae, produced 4 different strains of algae. And then we dried the algae to provide the dried biomass for the industrial production of foods and feeds. The drying was also with the input of the work that was presented by IMA. In parallel, we also did the protein isolates, or a task that was led by Alga Source. The initial plan was to use these protein isolates for the foods, but as we already discussed, the costs and the low yields then led us to the conclusion that we would not do this industrial scale production of food with protein isolates. So the microalgae cultivation, we use different reactors. At Necton, we focus our production in photobioreactors, tubular photobioreactors. And for this project, we cultivated Nanochloropsis and Tetraselmis. You already heard about this algae. In Al Microalgae, the focus was the production of chlorella, the different kind of chlorellas in fermenters. And we also did there in Al Microalgae the production of spirulina in raceway ponds. Then the drying. For Nanochloropsis, we selected freeze drying, although, as Ima presented, the solar drying was a good option, a very nice option. Then for industrial scale, it was not yet well established at the company, so we moved on with the standard procedure at Necton, that is to freeze dry. For the chlorellas, Al Microalgae has industrial spray drying, so that's the way they did to dry the biomass. And for spirulina, we did mainly solar drying. Just a brief conclusion of this first part of the work, just to show you the biomasses that we gave to the rest of the partners. For Alga Source, for the protein isolates, we did mainly paste, in this case, Tetraselmis paste and spirulina paste. For the foods and feeds, we provided dried biomass. So you have here the amounts. For the foods was mainly Al Microalgae, providing spirulina and chlorellas. For the feeds, we produced Nanochloropsis and Al Microalgae smooth chlorella. So the scale-up to industrial level of the production of protein isolates, as I said, was not fully achieved due to the low yields and high cost, but we tried. We had the frozen microalgae, Tetraselmis and spirulina, and with the inputs from what Ima presented, we tried to do the protein isolates at industrial scale. I will not go into much detail, but this is the process flow diagram for the extraction of soluble proteins of Tetrasalmis and Spirulina. The steps are very similar. There are some differences between the two strains. There is a thawing. In Spirulina, there is also a maceration and the addition of additives. This step is basically to burst the cells, so we release the contents that they have inside. Then we have a centrifugation step to separate these contents that are in the water from the pellet, let's call it in the end, it's an insoluble green residue that you can valorize later. In the water, we have the crude protein extract. That is what we use to move on. For Tetrasalmis, we move directly to ultrafiltration to remove salts, small protein sugars, basically to clean it. In the Spirulina, we do two steps. We have a microfiltration for clarification and then the ultrafiltration. And with this, we get the protein isolate. And I believe Ima already showed this slide. So Tetrasalmis, as you heard, has a very low yield of protein extraction. We could only achieve 3%. And even so, this protein isolate was not pure. It only had 27% of proteins. So Tetrasalmis is not a good option to move on. Spirulina, it was nice. It provided a yield of 31%. If we look to phycocyanin, that is one of the main pigments in Spirulina, and it has a commercial interest. It was around 80% of yield of extraction of phycocyanin, so it was quite good. And here the protein isolate is quite pure, with almost 80% of proteins. Conclusions about this part of the work. Not all the microalgae strains are suitable for a sustainable and solvent-free protein isolate at industrial scale, as Ima already said. If we go to the isolation of molecules or proteins, we have to know that this, of course, will add a cost to the product. This cost has to be justified by an increased value of the isolates. Maybe if they have a higher functionality, it gives value to it. Or isolation of other valuable compounds, for instance, omega-3 fatty acids, or as Ima also said, the valorization of the side streams. Now entering the food formulation at industrial scale. We had the dried microalgae, mainly were the algae that are food approved, chlorella and spirulina, and with the input of the work presented just before me, we made the food products. We have this that you already heard about, and then they were used for consumer tests. I will not speak here about consumer tests. This will be talked about afterwards. So just briefly to show you the prototypes that the industrial partners did. So Gutarra did a protein source vegetable cream with 1.5% of spirulina. They did it at industrial scale, a lot of Tetra Paks that were then provided for the consumer testing. Enervit did two kind of products, shake drinks and sports bars. The shake with 5% smooth chlorella. These ones went for consumer testing. They also did sports bars with 5% spirulina, but these products were then not chosen for consumer testing. Calais did grisinis and toasts. Grisinis are breadsticks with 3.5% smooth chlorella. They provided several bags with around 20 pieces each for the consumer testing. They also did small toasts with 1.5% spirulina, also for consumer testing. Alver did the carrot ginger soup with 5% honey chlorella for the consumer testing. Tradizione Padane did vegan fresh stuffed pasta with 3% smooth chlorella. And Viva Maris, together with Dill, did vegan meat sausages with 3% golden chlorella. In this case, because they are vegan, no animal gut was used for the coating. And it's a product that has a short lifetime, shelf life. So it was a bit of a logistic issue that the partners for the consumer testing had to deal with, so that they could have all the products together to do consumer testing. So, as I said, I will not present the results of the consumer testings. My colleagues will present it later. And what we can say here is that the innovative food formulations were successfully produced at large scale by the industrial partners. Now, about the feeds, I will show some results. So, what is the work? What was the work plan? So we had the dried microalgae, nanochloropsis, and chlorella, and we used them to make the feeds, and then the feeds were used to make the in vivo trials, and then we also did meat quality tests. For the feeds, we again got the input from previous work, and we produced, as you already heard about, feeds for 4 groups of animals: poultry, swine, fish, and shrimps. We did in vivo trials in all those, and the meat quality tests will be done in all except the shrimps. I will not go into detail of this table, just to tell you what nutrition sciences did for the piglet trial. So they have a control feed, normal feed, and then they did 3 replacements of crude protein from soya with different amounts of nanochloropsis. And what these numbers tell us is that basically there is no significant differences between the feeds. So nanochloropsis is a good replacement of soya protein. About the poultry, it was not the case. So here, IRTA did a feed with 30% of soya protein replaced by nanochloropsis. What they observed was a reduced growth at the later stages of the trial. They also observed a changed skin and breast color, that there was a tendency for yellowness. But on the other hand, there were no changes in the quality parameters of the meat. But in overall, we can say that nanochloropsis here is not a good replacement for soya. About the fish, the trials were done by Vitafort. They also did the feeds. So we had 3 kinds of feeds: a control and 2 experimental. The first one with 10% microalgae inclusion, the second with 20%. And depending on the fish that they used a different algae. So for the common carp, they used nanochloropsis. For the African catfish, they used chlorella. And these are the results. Basically, no difference in both cases. So in overall, nanochloropsis or chlorella is a good replacement of soya. We also did meat quality assessment, and again, no differences between the treatments. So once more, a good replacement of soya. About the shrimps, the trial and the feeds were done by INVE. 2 inclusion ratios, 10 and 20% of nanochloropsis. The first trial failed, so it's now being repeated, and because of that, the results are only expected in the next few weeks. Here you can see the larval stages of the shrimp, so you can have some nightmares today. And these are the conclusions of the innovative feeds, but I will finish also with a general conclusion. Nanochloropsis is a good replacement of soya in piglet feed and in carp feed, as chlorella is in catfish feed. but nanochloropsis is not a good replacement of soy in poultry feed. There is still some work to do. The sensory evaluation of meats and the shrimp trial is ongoing. And in overall, although most results are good, as we already discussed, price-wise, we are still a bit far to be able to compete with soy. It's a completely different market, and microalgae are still expensive because we are an industry that is quite new. Agriculture has hundreds of years. Microalgae has a few dozens. So we are still, and we hope to reach there. And I want to thank all the partners for this wonderful work in this project. And I'm now waiting for your questions.
Any questions? Okay.
Hi, thanks for a really interesting presentation. Do you know or understand or have an idea about why it doesn't work for poultry, but it does work for the other organisms? So the fish and the...
Not totally sure. Might have to do with digestibility that we already spoke about, but maybe Gert Josep can give an input there.
Yes, maybe digestibility. That's one aspect. On the other hand, what we saw at the start of the trial, at the poultry trial, it worked. It was only at the end of the poultry trial that something happened. Now there's a huge difference between a swine and a chicken. I mean, a chicken is mainly based on texture and color. That's why chicken is attracted. While a piglet is more on taste. So most probably also the organoleptic characteristics were different. So we did not explore further. But in terms of digestibility, that's clear. We did some digestibility trials, and the digestibility was lower compared to soy. So what's the reason? We don't know yet. Yeah. But there was a clear difference in digestibility trials between the two animal species, as well as in the physiology of the animal. Yeah. Thank
you. On this topic of digestibility, Nanochloropsis has a strong cell wall. Did you break the cell wall before?
No, that actually was one of my comments that I forgot to mention. Yeah, we are in disadvantage. We are comparing crude protein of soy that is there, the protein, with a cell that is closed and has nanochloropsis, as you said, a tough cell wall. So, yeah, in the next project we should tackle this question. Massimo.
Thanks. An issue that keeps coming up in the presentations and the discussions is comparing the low price of soy with the higher price of the algal inputs. And I wanted to ask a question because obviously it's frustrating to hear that because we know that the soya is doing all kinds of damage, to the Amazon, et cetera, and it's being transported halfway across the world. So that's problematic in a moment when climate change is such a massive issue. Conversely, algae could avoid those costs. And I guess if we drew the circle a little larger, something that we could look at would be how, production of microalgae to replace soy could be a recipient of climate mitigation money. It seems like that would be something that'd be very worthwhile exploring because it's a question of the different revenue streams you're gathering. And, a ton of carbon is I think it's 100 euros now. It's a lot of money. And the reality is that you'd be avoiding these very damaging things. And the only reason why it's cheaper is because those are externalities that are being ignored by the market. But that could be addressed. That's what I'm trying to say.
That's a wonderful point, yeah. We don't say that soy should be taxed for the deforestation, of course. Because then it would increase the price of the food of the people. Yeah. But the thing of the carbon and how can we help to expand the production of microalgae? At this moment, we are very small and we are competing or trying to compete directly with a huge business. We cannot give the jump to that level. So maybe we need to go step by step. And one is to receive money from entities because we are more sustainable, not to tax the others. But
to outcompete the others with the additional revenue streams.
Yeah. Thank you.
No more questions? Okay.
Thank you. Thank you for the presentation, really inspiring work. In the beginning of the presentation, you mentioned something about production of protein isolates not being economically feasible. And so do you think the opportunity to make it economically feasible lies in the downstream processing, optimization of the downstream processing, or in the optimization of the fermentation itself, kind of optimizing the yields, reducing energy costs, or would you go to genetically modified organisms? And have you done something in this regard?
So I'm picking some words of Ima that we already discussed something related to that question. First, thank you very much for the question, very important one. It has different factors. Yes, if we reduce the cost of the microalgae production, it will then reduce the cost of the protein isolate. But there is still a lot of work to do with the protein isolate production, with the extraction of the proteins, test new methodologies or invent new methodologies. So there is still a lot of work possible to reduce all the costs since the beginning, the cultivation, until the production of the protein isolate. So that's why the main reason we are still far from the price of the soya protein in the market. Thank you.
Okay, thank you very much. I think we're going to continue with the next speaker. Our next speaker is Juliette Sulmana from Apex Agri. She's an agri-food engineer and consultant specializing in sustainable development. And she will talk about the responsible and sustainable microalgae value chain.
So thank you very much for being here, and thank you for the quick introduction. So I will be fast and quick. I have like 5 different projects to present in 20 minutes. And then I will let the floor to my 2 colleagues, Marinella and Marisa, which are here. So the first thing that we studied is we tried to map the European value chain and made a graphical representation. So we published this figure in 2020. So I think that this that repetition is not. It's a little bit outdated, but we have the different stakeholders here, like the different steps, which are still the same now. And we also identifying different key points which are really important to face for the European value chain. The first one is that all the actors of this value chain are a little bit fragile and have like fragile financial structures and are barely profitable. We also observe that the market is far from the nominal level of trade despite the sustained growth. There is a constant technology renewal. We see it like there is a lot of innovation, a lot of technical improvement, also different type of new strains. We don't see any strong lobbies, committee or grouping of actors who can bring a like shared vision of microalgae market and we also don't see any common or equivalent basis on calculation of the product cost. So Marinella will talk about this, but we try to create a tool to foster this calculation. Then Lisa, here she is, and ZSI work on the social perspective on the development of responsible microalgae value chain. So they organized and facilitated 2 multi-stakeholders workshops and co-created 4 scenarios of sustainable, just and responsible microalgae production and value chain. And these 2 workshops led to a publication of an article. And this article details different key findings. The first one, Lisa can complete if I... Okay, so the first one is it's a key point to identify all the different stakeholders in order to strengthen and to enforce the dialogue and the collaboration between the different stakeholders among the value chain. We also agreed that microalgae food and feed products is niche sectors, and it's really important to get political support, to get the necessary funding, and to build the new requirement for the sector. It's really also important for all the company to be totally rooted in the food sector. Financial and technical uncertainties have to be minimized by the support of the policymakers and the funding agency. It's also important to have the collaboration with large and well-established industries. And finally, at the current stage, the agency of consumer and civil societies is underestimated in the microalgae-based value chain, food value chain, and we know that the demand is key to render the microalgae food products relevant and sustainable. This morning we talked a lot of the valorization of the microalgae side product. So Simon here worked on this aspect. So due to delay, he were forced to work on spirugase, which is let's say the waste of the spirulina extraction. Okay. So spirugase show interesting amino acid profile, good techno-functional properties, also a good amount content of protein in the biomass residue, around 60 and 70% of protein. But it also shows it's difficult to valorize for food application due to high microbial contamination and difficulties in drying. So they wanted to try something to reduce the microbial load. So they try to compare 2 different techniques, so the HPP, the high pressure pasteurization, and to compare it to the normal one. And also they work with Nectin to dry it like the solar drying. So the result of this comparison between high pressure pasteurization and traditional wine, so it showed that both of techniques are sufficient to reduce the microbial load and to lead to safe food products. But HPP showed also more advantages because it reduced the effect on protein denaturation, color and particle aggregation, and also maintain or, in certain cases, increase some techno-functional properties on the contrary of heat pasteurization. Yes. So what we can conclude on this part is that spirugase is really interesting for application for food and feed, as it contains high content of protein and also high content of essential amino acids. But due to microbial issues, it's important to find a way to reduce the microbial load, but high pressure pasteurization looks like a valuable option for the decontamination. And we also see that the HPP increased functionality of the spiragrace compared to the normal one. And in case we try to work with spiragrace, is really cost effective because we estimate that spiragrace is half the price of the fresh spirulina. So really interesting for our next food and feed try. Now I think Marisa or Marinella will...
Yes, we have Marinella as our next speaker. She is working at Aksha Innovation, and she is specialized in bio-based advancement, and she evaluates impact studies as well as data to help us create tools that assess sustainability and circularity.
Thank you for the introduction, Marie. Hello also from my side. I will start saying that something that we already know, something that we already all of us experienced. Today we are living in an economy that tries different alternatives, okay? Here we are gathered all together to search for different alternatives, in food and feed. So the way that we have decided to feed ourselves and our animals has changed. And we are doing this because we are searching for different ways towards a more sustainable and circular future. When I talk about alternatives, in my mind comes the word options. So I have different options. I have different options to select different raw materials, different resources, different technologies, and different final applications, different final products. If you consider that we have a lot of options, at the end of the day, at some point, we will have to conclude and decide for one of these or two of these, or three of these options. So we need something to guide our decisions. So what are companies, what are companies struggling to do within this sector and within all these sectors that are struggling with these new alternative sources of energy or biomass, is that they are struggling to find ways to assess their processes, to assess their value chain. So they pay money, they need some consultants, they need some softwares to achieve that. They pay money by consuming time because they need to take one number from here, one number for another report. Let's see what is in the literature. So this is a very time-consuming and a very cost procedure. So we thought that what if we could solve this problem? What if we could solve this challenge? What if we could gather all of this into a single decision support tool and provide a holistic environment where the user shouldn't be an optimization expert or an LCA expert. He can just run a study selecting the value chain that he wanted to study. So we created a tool that considers all this together, considers energy, considers cost, considers LCA data that we thank very much ESU services that Marisa will explain you the environmental aspects after my presentation. So we started by defining the value chain. We developed a methodology based on process engineering because we are chemical engineers in our team. Then we collected the data and then we created a database formulation that will be able to include all this material and the scaling up of this material. Finally, we developed an optimization code to optimize, to screen all these value chains. And finally, we developed a user-friendly interface in order to be able to provide this tool to the audience. And we gave it a name. We named it Algavantage, from algae and advantage. So here it is our logo that we created, and I will explain why we created also this logo. Optimize, innovate, aggravate is our slogan. And I will show you a brief presentation of the user interface. In the first step, you will be able to review all the processes that are included in the analysis that we have. The second part, the user can develop his or her study based on step-by-step development of the value chain, and step-by-step he will be able to see the energy consumption, the LCA, the costing, etc. All the things that are major, but as I told you, this is customized, so we can include more aspects and more factors if somebody needs to. And the final tab is related to the optimization code. You are selecting the path that you want, you are selecting the final product that you want, you are selecting maybe otherwise the raw material that you have, and you are running an optimization problem without knowing anything about optimization. So approximately, this is how it looks like. This is the second tab when you are working step by step. You are selecting the raw material, the protein, that you want to produce. Here you're selecting the different categories based on cultivation or disruption or drying, etc. And here you get the results. This is confidential, this is why it's not shown here. The results, you cannot see it here, but this is the greenhouse gas emission, energy consumption, energy cost, material cost, labor cost, etc. And this is the total route. And finally, the last point. I told you one of the problems that you can solve is to select whether you want to go to feed or food, or maybe you can select both of them. Then you select which one, then you determine the quantity, you play with some factors that are critical for food, for example, the color, the taste, and then you get some results, some ranking results about the optimization of this value chain. I will be in the poster session also tomorrow, so you can also review the tool there, approximately, not all the tabs, but we can show something. And finally, we are very happy because with Algae Vantage, we were invited from the European Union for the Innovation Radar Prize. So we are waiting for the whole procedure to start. It will be at some point a public voting, so we will engage you all if you like these results to vote for us. And finally, this is our team from Axia Innovation that we are working on the back, the data collection, the data formulation, the optimization codes. This is our team. And of course, RDC, our partner that are developing the user interface, which we'll thank all very much. And of course, as I told you, we also thank the LCA partner that provided us the data for the LCA analysis. That's all from my side. Thank you very much.
So next speaker, we have Marisa Bussa. She has a background in energy and environmental engineering, and she will tell us today about life cycle assessments of microalgae.
Yeah, thanks for the introduction, and yeah, I will give you a quick deep dive in part of the results that we generated in ProFuture. Just as an introduction, we had two parts mainly. The first one was comparing all the different technologies that were presented to you in the morning in terms of costs and environmental impacts, to see which ones are the best: cultivation, drying, disruption, and we didn't do the protein extraction part. That was the first step, and afterwards the second step was to look at the food and feed products and compare them also to conventional alternatives, and to see how the microalgae-based products perform in comparison. just a very short methodology slide in case that there are some LCA people here in the group. So what we used as a functional unit, so as a basis for the comparison, it was always a provision of 1 kilogram protein, because that's what the whole project is about. And we had the different pathways which we compared. And for the comparison, we used the environmental footprint impact assessment method, which aggregates a lot of different environmental indicators and allows to aggregate them in one single score, which makes the comparison a bit easier. As background databases, we used our own ESU database and ESU World Food Database. And on the right side, you can see the systems that we analyzed. So in the first step, we just had a look at the production of single-cell proteins or protein isolate. And then in the second step, we analyzed the whole product system, also including the processing ending up in a food or feed product. And we excluded the disruption and protein extraction because the yields were too low. So we focused on the single-cell protein. And I have just one example to show today because we don't have too much time. So I picked the vegan sausage. And here we can see, first of all, the comparison of the nutritional values. I used 2 benchmark products. The first one is a pork sausage. So that would be the animal-based protein source. And also as a plant-based comparison, I used tofu. And what we can see is that we have a algae content of around 3%. The protein content of the vegan sausage is lower compared to the pork sausage and the tofu product. The fiber content is a little bit higher, and the calories are somewhere in the middle, a bit higher compared to tofu, but below the pork sausage. And based on the cost estimation that we did, we assume that it's around plus 30 cents due to the inclusion of microalgae in the product. In the first step, we analyzed the contribution of the different ingredients, and what we can see here for the 3 main ingredients in terms of environmental impacts, we can see that microalgae, we saw the quantity below 3%, but it contributes with around 23% to the to climate change impact. And we also saw that rape oil and pea protein isolate contributed over proportionally compared to their quantity in the recipe. And now the benchmark for the provision of 1 kilogram protein, including a lot of different environmental indicators into one single score. What we can see is that the vegan sausage and the pork sausage are pretty much in the same order of magnitude. It's around 8% higher, the environmental impacts of the vegan sausage. But it's important to keep in mind that in general we have an uncertainty of 10 to 20% in LCA, so this difference for us is too small to say that the one product is better or worse than the other one. And it's also important to highlight that it's kind of an unfair comparison that we are doing here. The microalgae is still in development, the whole industrial sector, as we also heard earlier today, and we are comparing it to very mature sectors. So that also explains the, at least part of the difference that we see here. And to conclude, what we saw is that microalgae can compete with animal proteins, but not yet with plant-based proteins. And what I didn't show you, but what I learned in the other calculations that I did, is that the cultivation stage is by far the most important part of the value chain in terms of impacts and costs, and that's mainly due to electricity consumption, and that also gives a hint what to focus on for downstream processes. it's quite important that you have high yields in terms of protein extraction, but also, for example, for drying, if you lose a lot of biomass, which was expensive in terms of environmental impacts and costs in the production, then it's a drawback if you lose too much in the downstream processes. Yeah, thanks, and maybe you two want to join in terms of questions.
Are there any questions?
Thank you for your presentation. Sorry, I'm Olivier Lépine from AlgoSource. When we speak about LCA, one of the key issues for microalgae is the land issue, meaning that we have discussed this morning that soya is associated with deforestation, whereas microalgae can be cultivated on non-arable land. Well, it's not always the case, but it can be. And usually the models, the LCA models, do not take into account this positive aspect of microalgae. So I wonder, how have you treated this parameter in your analysis?
What's taken into account is direct deforestation. So if it's really deforestation to afterwards plant soy in that area, what's not taken into account in LCA is indirect deforestation. So if soy cultivation in Europe is increased, which pushes cultivation of other plants to Brazil, for example, that would be indirect impacts, which are usually not considered.
Okay, well, I just want to insist because I think this is key. So, if I understand correctly, there is an indirect impact for soya, and there is also for microalgae cultivation, because the model as a basis does not take into account any positive issue. So, if I understand correctly, in fact, the fact that we cultivate on non-arable land is not taking into account as a positive factor.
It is, let's say, taken into account as a less negative factor, because mainly we talk in LCA about negative impact, so that's definitely an advantage of microalgae, that you don't need arable land for cultivation, but yeah, the electricity consumption is the main reason for microalgae still having a higher carbon footprint compared to soy.
And one last point on this. Electricity will be the European mix energy?
Yes, yes.
Okay, the current energy mix. So Portugal or, well, in Necton, they did this trial with PV, so decarbonized electricity. This was not taken into account in the results that you showed us.
In the results that we saw here, I think it was with chlorella, if I'm not mistaken, for the sausage, and that was not the one tested with PV.
Okay, so we would have had different results if you had taken into account the optimization that were done here in the project.
Yeah.
Okay. So maybe this is something we could do before the end of the project, to actually have this scenario where we integrate optimization to have a fair comparison between where we want to go and where we are now.
Yeah, that would definitely improve the results if continuously renewable energies are used for cultivation of microalgae.
I have some follow-up question, not on the electricity or on this framework, but in this work you consider the chlorella, so it was fermented, right?
Yes.
Do you have comparisons using autotrophic biomass and heterotrophic biomass? Is the impact of the production mode, or is not included in your other analysis that you didn't show today, of course?
I've collected the data and I did the calculation of each individually, but not yet the comparison in detail. But I think that the heterotrophic performed better compared to photoautotrophic, but that's a guesstimation at the moment.
Thank you.
Yes. I've seen a hand somewhere. No? Okay. No. Okay.
Just have a question. Have you considered also the LCA of omega-3 or
No,
not?
we didn't.
Yeah, just focused on proteins.
Yes, exactly.
Okay, thank you.
Okay, one last question then.
This is a question for Apex Agri on your modeling. No, sorry, for Axia on your modeling, on your tool. Well, could you give us an example of what you mean by optimal value chain? For example, comparing two different value chains.
Okay, take into consideration that you are discussing for different species of algae to produce a particular product. For example, pasta. It can be made by, I don't know if I'm correct right now. It can be made by spirulina, by chlorella, or whatever else. You don't know which is the best way to sustainably achieve that, to achieve it in a less energy consumption, in a most lower cost that you can do this. So you can run this model to say that my target is to produce, for example, 1 ton per year of pasta based on algae, which is the best possible way to do this, and you select the objections that you have, the objective that you have. I want to reduce my cost, I want to reduce my energy. And then this selection is taken by the optimization model, and then you get the optimal solution for your case. Or maybe you can say that what will happen if the raw material that I have is not enough? What is the next protein that protein source that I can use to produce this pasta, for example, to make my industry working during the year, because I have to make it feasible during the year.
Hello, my name is Paul Vos. I'm from Wageningen University and Research. I have a simple question also for the second speaker on this decision tool. So I'm involved in another EU project where we focus on a lot of different alternative protein sources. We also want to look at value chains and LCAs. I'm interested just to learn from the tool that you've developed. Can you explain how much is it open for people outside of this consortium or in the future?
I was expecting that question, and we discussed it also with some of the partners. For the time, it is just for the partners of the consortium, but we will discuss it internally to its availability after the project ends. But I just wanted to comment that this tool is customized. For example, if you want to add 5 different extra species, we can incorporate that, okay?
Yeah, thanks so much to the 3 of you.
Thank you very much.
So we now have a look at the consumer. So I would like to ask to introduce you to Christine Jung-Hung. She's a professor at Ghent University, and she combines both social and natural sciences in her background. And yeah, she's looking at behavior towards innovative products and services.
Thank you. Thank you very much for the kind introduction. And hello, everyone. Very nice to see you. And so far, you have seen different results related to the production side, the whole value chain, and now we will look at the consumption side. And this is where the money comes from usually, so that's quite interesting. Before I start, I would like to first introduce my team, because this would not have been possible without them. From UGent, we have Professor Wim Verbeeke, who is not around here, and we have our PhD researcher, Helene, here. She's there, so if you have any questions related to our studies, you're very welcome to contact her. And we also have partners from Wageningen. Unfortunately, they're not around, so we have Arnold and Emilia. And then in IRTA, we have Luis, Anna, and Israel. And Luis is there as well, so if you have any questions related to the sensory part, you're also welcome to contact him. before we start, I have a question for you. So, have you heard of or tried food products with microalgae before this conference? You have 3 options. The first one, I've heard of these products and already tasted them. And second option, I've heard of these products but never tasted them yet. And third, haven't heard of it, neither you have tasted it, of course. So first, who have heard of them and tried them already? Okay, majority of you. And second group, who have heard of them but never tried them yet. Okay, your chance will be here. Your chance is coming. So today you will be able to taste the different products later. And I guess no one have never heard of this product. Okay. And we will have a look at what European consumers find them and whether they are aware of them. But I guess you already know they are not as aware of or they are not as familiar with microalgae products as you. We have 4 main topics that you will look at today. The first one, we talk about familiarity, like the questions that I just asked you. And then second part, about perceptions, what they think about microalgae products. Then third, whether they're willing to try them once they have heard about them and whether they're willing to pay for certain attributes. Then we have so many different individuals. Everyone is different. How do we try to group them? How do we put them into meaningful segmentations that we can have more targeted marketing strategies? We will have a look at what we can do with this insight. So the first one, since the general or average consumers, they are still not very familiar with microalgae, and you will see how our results will be different. And compared to you all, in general, European consumers are not very familiar with microalgae, and there is quite a huge country difference. For example, more consumers from Spain have heard of these products and might have already tasted them, compared to, for example, in Hungary. And in general, more consumers from the Netherlands and Hungary, at least the majority of them, have never heard of this product. So there are some country differences between the countries. Then, because we want to know what they think about this product, but we also realize microalgae may not be as familiar to consumers compared to macroalgae like seaweed. So some of these results also included findings related to seaweed, and we can look at them with in 3 different ways. So we have ABC. We first look at the associations they have, and then we look at big data and consumer survey. So first, when you get to a new concept, very often we as humans, we will come up with different associations, even if we are not aware of what they are, or even if it's the first time we hear about them. So the first study is related to associations, and that was conducted by our colleagues at Wageningen. Keep pressing the wrong button, sorry. And this is an interview in the Netherlands with 20 individuals. So we asked them what are their first impressions related to this product before they were told about anything related to, for example, microalgae like spirulina, chlorella, and then some of the macroalgae in different names. And then we asked them about their association, so what they would think about or what feeling they will have when they see these terms. For example, spirulina, they didn't come up with a lot of associations that become significantly, that can be significantly grouped into any of the characteristics. But let's say chlorella here, they first think of scientific terms. So they think of this more as some kind of scientific product or scientific compound. But then when we move down to, let's say, macroalgae, then they sometimes talk about visual sensory properties, for example, like colors, shape, different characteristics that you can see them visually. And when it's about sea spaghetti, they talk of nature, water, landscape, algae. For nori, also the color, shape, etc. And then for hijiki, they think of culture or geographical places. Then these participants were shown a 30-second short video clips of these products in food products. So they see, for example, someone eating those items with such product. Then after the clip, then they started to associate spirulina with food and drinks. So before seeing the clip, when they are shown this word spirulina, they did not think of food and drinks immediately. But after the clips, that's where it shows up. And some of these associations changes. For example, before they saw this video clip, they did not really, they immediately thought of, for example, related to color and shape, but they did not think of something else after they watched the clip. So this is more exploratory to see what people immediately think about when they hear the terms from a different type of microalgae and macroalgae. Okay. Then the second part related to big data. Then we look online. This is conducted by colleagues, Israel and other colleagues in IRTA. So this is with big data. They look at the different social media, news, blog, online, and they try to search with the keywords with spirulina, chlorella, algae, microalgae, and seaweed to see what would be the post about and related to microalgae consumption. So in total, there are many posts related to these keywords. There are 2 million posts out there, but not all of them related to food consumption. For example, some of them, if they mention it as, I have a microalgae painting, then it is considered as irrelevant. So only the relevant posts were retained for analysis. And based on this post, we could analyze for the sentiment, whether it has a positive sentiment or a negative sentiment among consumers. And we can group them into different classifiers. So I will show you the highlight of the result. Most of the posts have a positive sentiment. It means most of the consumers have a positive feeling related to microalgae or macroalgae in this case. Health benefits were mentioned the most often, and some of the associations on the post, not associations, so on the post, they were related to sustainability, nutritional properties, and good taste or different organoleptic properties. So these were the benefits that are highlighted or posted on the internet when we look at the big data. And there are also some of the negative sentiments that we could find, but there are only 3% of them. So mainly they were very positive, and there were 3% of negative posts related to that, and mainly related to side effects on health, perhaps bad taste, and the composition. So in general, the positive side is a lot stronger than the negative side. There are a lot more posts related to it. And some of this information related to positive sentiments can be overly optimistic and not always supported by the scientific evidence. This could be a risk in the long term, because then people may start to develop distrust, or they may get a little bit disappointed if they find out that all of this so-called there are posts related to superfoods as well. So sometimes microalgae were called superfood on the internet and social media as well. So those were not supported by the scientific evidence. And sometimes if when it's related to the negative sentiments, interestingly, most of the negative sentiment or the potential risk that they mentioned in the post were more supported by the scientific evidence. But of course, that's only 3% of them. Okay. Then this is based on a large-scale consumer research survey that we have done in 2021. That were in 5 European countries linked to the result that you have seen just now related to familiarity. So if we ask people what they think about microalgae, this is what they think mainly. So from the top here, are more positively rated. For example, most of them think that microalgae food products are innovative, sustainable, and healthy, and relatively less of them would think the opposite. And if we look at the main challenges that microalgae products would face in this graph, then you can see that more of the consumers would think that it may tend to be more difficult to find, or it could be highly processed. So this is to rank what they think related to food products with microalgae. Okay. Then, now the question is whether they will be willing to try, because the attitude is relatively favorable. So now we will see, are they really willing to try, or they just think it has a positive image? And we asked them based on different products, different carrier products, and also different microalgae species. You could see that they are quite different between the products. For plant-based sausages, less than half of the participants indicated that they were willing to try. In contrast, vegetable soup was the food product that most of the participants, or at least more than half of them, were willing to try. And we, at the same time, also asked about plant-based cream, energy bars, plant-based pasta, and bread, and they were in between. So we've seen that there's such a big difference between the carrier products when it comes to the willingness to try the product. But the species of the different microalgae, Corina or Spirulina or this Tetrasomes, the differences between them were not big. It's just that very often consumers find Corina and Spirulina more familiar, we suppose, and that's why it has a slightly higher amount of consumers who are willing to try products with these two compared to Tetrasomes. And now we will look at the example with plant-based pasta when we talk about willingness to pay. Because this is a survey, it's not actual economic experiments in the room. So this is more choice experiments that we try to see if different type of informations that consumer will be willing to pay for the different attributes and information that are given to them. For example, so from this result, we could see that when this is positive, it means that consumers are willing to pay more for the different attributes that are listed here. So in this case, for pasta with microalgae protein, that we could see when it carries a organic label, consumers were willing to pay 1.38 euros per 500 gram more compared to when it does not have an organic label. So consumers do value these products with organic label more. And secondly, it will be when the products carry a Nutri-Score A label versus when it doesn't carry one. And thirdly, followed by a vegan label. And in this case, we also give them the information that either the product is yellow to light green or light to dark yellow. So this is just an information. And we've seen that it has some effects, but not so much in terms of willingness to pay. So the color description itself is less important compared to having such a front of pack labeling when it comes to marketing communication. So now we know what they think about the products. We know how familiar they are with microalgae-related products. And then we will see how do we deal with this consumer insights, or what can we make out of the different consumer profiles. So if we try to put all the consumers on a graph, and we can try to put it in two axes. So here, y-axis is related to the perception. So the higher it is, the more positive their perceptions would be. For example, the more they think that it is healthier, more innovative, it has more nutrients, etc. And then when it's lower in the axis, it will be more negative. And for the x-axis, it's about willingness to try. So the closer to 5, the more willing they are to try such products, or for those who have already tried it, the more willing they are to eat again this product. So here will be the most willing, and this side will be the least willing. And we can group all the consumers together to see which segments or which groups they belong. And we can find 4 groups of them. We have the ones who are very enthusiastic about the product, so we call them enthusiasts. And we have some who are relatively, they would be willing to try, but they are half and half, and they are still thinking whether they should eat this product. So we call them cautiously waiting. And then we have a group that is in between, so half and half for both perceptions and willingness to pay, and they are the indecisive. And finally, we also have a group of consumers. Luckily, that is also the smallest group here. They are relatively uninterested. So just a question from theories. who do you think it would be the most interesting for the marketeer to target? If you would be a marketeer, which group would you target? Who think it would be the enthusiast? Oh, sorry, not the profile yet. Who would target enthusiast? And who would target cautiously waiting? Indecisive? Uninterested? Wow, you all have marketing background, I think. Indeed, based on marketing theories, indeed, these are the more interesting groups. Because if they're so enthusiastic, you probably don't have to do a lot anymore and they would try it. And if they're really uninterested, it would be really hard to change them and they may even not like it if you push too hard. So you all have marketing background. And now we want to look at their profiles. So who they are, what make them different from one another. Some of them could be slightly similar. So now we can highlight, just note that the profiles here do not mean that the whole groups are them, but it just basically means that these are the highlights who are overrepresented in this group or what are the bigger proportions in this group. And I will explain the two together, the cautiously waiting and enthusiast, because they're quite similar. They're overrepresented by participants from Italy, by participants who have a relatively higher educational level. They are bachelor's or above. And based on financial situation, so perceived financial situation that they think that they are managing very or quite well. And many of them are flexitarians. And for the group of enthusiasts, they seem to be in the younger group. So this survey was only done by adults. So this is the youngest group that have completed the survey, age 18 to 29. Then the group of indecisive, many of them are from Hungary, and they're also relatively young, and most of them have a slightly lower educational level compared to the other groups. They don't follow any dietary regime, and they're overrepresented by the group that is underweight in terms of BMI. And lastly, the group that are relatively uninterested, they're from Germany and Hungary mostly, and they are the slightly older group. They're the oldest group in the survey who completed the survey, and they also have secondary education. And in terms of perceived financial situation, quite many of them think that they have difficulties. They also do not really follow diets, and they have a bigger group of underweight individuals. So this is how we can profile the different segments and enable more targeting marketing strategies to see what they need. For example, if you want to now target cautiously waiting, they already have quite a positive perceptions and willingness to try. Maybe you can let them taste the product to let them know that they actually taste good. Then they may be encouraged to move forward to become enthusiasts. And maybe for consumers who are indecisive, if you give them more information, if you stay more transparent with the communication, they may get more informed related to the product, and hopefully that they will move towards to decide as well. So this is how we use different consumer insights to come up with more targeted marketing strategy. And we also noticed some different trends. For example, people who are uninterested or moving towards the side of uninterested, some of them will have a higher level of food neophobia, so they don't like to try new food. Some of you might be able to identify it with yourself. Sometimes I have a bit the same. And food technological neophobia as well, when the products seem too innovative, that sometimes some people do not really like it. And when we moved towards the enthusiast, then we saw some of the attitudes that stood out from their profiles. Those are people who have a higher general health interest. They have more concern for the environment, and they find the products more positive. They rate the product more positively. For example, or especially related to nutrient profiles, like the different like protein, fiber, vitamins, and minerals that we have in our survey, that they rated them more positively. And finally, they're more interested about the related information as well. But this also makes it more challenging, because if they are more enthusiastic already, and they are more interested to the information, so you will be reaching them if you give information. But the other way around, if they are not very interested, and their interest in related information is actually low, then it means that it's much harder to reach this group compared to the ones that are already enthusiastic to start with. And that's why sometimes marketing efforts can be so difficult, as you might have heard of this preaching to the converted. Okay, then key messages. You've seen different things, but before that, you might be wondering, how do these products actually taste? And indeed, there were tasting test sensory evaluations conducted and led by our colleague, Luis and Irte. And there are some preliminary results available on the poster. So we invite you to have a look at our poster, Assessing Consumer Sensory Acceptance Food with Microalgae. And indeed, their liking of the food products would be heavily influenced by the sensory attribute. And you can compare your personal result with the result of the tasting panel. So key messages. We have ProFuture. And if we try to organize the key messages into ProFutures, we get 4 key messages. First of all, P perceptions, they are generally positive, and most consumers have a more positive and favorable attitudes towards this product, although the products are not very familiar among them yet, because they think about natural, healthy, sustainable. And second key message is related to willingness to try and willingness to pay. So the readiness to eat, they are different between countries, and they are very different when we look at it with the different Korea products. So not just with the microalgae as ingredient itself, but if they are used or applied to different food products, it also influences whether they're willing to eat them. And then the optimisms, or if we look at the favorable attitudes, mainly they are related to the innovativeness, sustainability, and healthiness, while the opposite, the challenge, mainly related to them thinking these kind of products can be highly processed. So the positive side of this, and then the challenge is that it could be difficult to find and highly processed. And finally, because of the differences between the European consumers and also countries, the future marketing efforts should be targeted to the consumer segments. And that is all. Also, thank you very much to the different partners. It would not have been possible without the input from all of you. And if you're interested in this kind of studies or more consumer-related insight or interdisciplinary research, you're more than welcome to contact us. Thank you very much.
Do we have any questions? We have time to take 1 or 2.
So the results that show about willingness to try, it's mainly based on interviews. So somehow you have been able to describe to a consumer the difference between chlorella and tetrasalmis.
Yeah, indeed. Yeah, indeed, the results are so far based on the survey. So they did not see the actual products. They only see the descriptions and the information that was given to them. So they did not get any explanation what exactly tetrasalmi is.
To the poster and to the sensory attributes, what would be the impact if you do the same questionnaire, but together with tasting of some samples?
That's exactly what we would like to find out. And because now the product is fixed, the ones that they can taste it, then we can only see whether they really accept it or whether they like those products with the carrier products attached. Because that it could be a very interesting research maybe for the next ProFuture projects. We can do experiments with the economic experiments, for example, economic experimental options. So people get an extensive explanation related to the different species, different products, and they can taste them, and they have to use, for example, money out of their pockets to bid for those products. Then we get very realistic insights about whether they're willing to pay for them and whether they really accept them in a realistic situation.
And the aim is always to go to ready-made products, or is it also the aim that you stimulate people just to use kind of microalgae during their own cooking?
Yeah, we actually have similar questions related to that. So we try to ask them under which conditions they would be willing to try or eat the product. And we saw there are some differences. And we also have questions related to whether they're willing to consume products that are, for example, animal proteins or meat products that were fed by the different type of microalgae. And if you're curious, you can always request for the result, or I will be presenting those results in a conference in France in November. So if you're interested in any of this, you're welcome to ask us. It's a very big survey that we've conducted, so it includes quite a lot of different results.
Thank you.
Thank you.
Yes, thank you for the results. My question is about what is the sustainability of the interest? We have seen that we will be more expensive. We are, and probably we will be more expensive than other even vegetable sources of proteins. Well, in the presentation just before, the environmental impact is not dramatically better than the existing products, and is definitely less than soya-based products. So yesterday there's interest, people willing to try, but what will make people buy sustainably those products if they're not better, if we cannot demonstrate that they bring benefits, and if they are more expensive?
That's definitely a very valid point. Thank you. And indeed, for food products, for consumers, we often look at firstly taste, the sensory aspect around it, how it looks, how it tastes, and sometimes we look at the healthiness or sustainability. And indeed, for consumers, we should not forget that we tend to look at the visible aspect. We tend to look at the experience attributes that you can prove immediately what you think about the product. And while we talk about naturalness, sustainability, or healthiness, it's not something they can feel immediately. And that is something that would be a challenge for marketeer, because if we talk about sustainability of the consumer interest, not the product, of the consumer interest, the price is definitely something we will have to find solution for. Because now, at this very moment, if the price is so much higher than the conventional product, while they cannot taste the immediate difference on health, sustainability, or even if they don't stand out in terms of taste, it's very difficult to maintain. I would even say it's almost impossible to maintain if they don't sense the benefits immediately, while the price difference is so big. So that's definitely a valid point to mention. The sustainability interests have to be coupled with the actual attributes of the products in both experience attributes that they can feel and they can prove themselves, and also the credibility part of how healthy or how safe, how sustainable those products they believe in.
Okay, unfortunately we have to continue, but Christine will be taking part in a panel discussion later, so we can also address the questions then. Thank you very much for those insights. We're going to continue with the market perspectives, and I'm pleased to announce our next speaker, who is Lina Waher. She's an associate partner at Civita Eesti and has a background in entrepreneurship and technology management. And in international projects, she supports innovations in defining their business opportunities and market perspectives. The floor is yours.
Thank you. Okay, it's simple. So I will try to squeeze all the 5 topics into the dedicated time and go through our studies, which included market dynamics investigation, competitive landscape identification, profiling markets and consumers, but not on the consumer level, but macroeconomic level more like. And also thinking about business models and about the market entry and marketing strategy. Starting with where we are currently stand. In principle, we targeted the European single market as our domestic market because it carries the similarities. It is easy to follow the same regulations. There are a bit similar expectations, policy supports, and no trade restrictions. So therefore, it was our first target. And what we discovered, we know that the world has 2 hemispheres, northern and southern. Perhaps we have the same. We have the northern and southern part of Europe in the European Union in the single market. But also we have 4 distinct geographical areas which carry some kind of similar characteristics. So our first message was that Europe is not unanimous. We can't take it as the one that everyone see and think at the same way, and everyone consumes the same food and prefers the same kind of value offers. So we discovered that the northern part carries the characteristic to be very good innovation adopter. It concerns the Scandinavia and also partly Baltic states who tend to be with the focus, growing focus, and also with sort of public discussions on the side of healthy living, addressing the health issues very seriously, and also are well digitalized societies, which means that the consumers also are a bit better informed perhaps, or have the access to the information and to the global networks. It is important. And also industry tries to move towards more digitalization and optimization of processes. Across the Baltic Sea, we also have a quite strong aquaculture behind. And based on our history, house plotting, picking, cooking, it is part of the history. So the natural food and also the feed is very well welcomed. From the southern side, we see that there are very strong tradition behind. It means that if you make pasta, it needs to be exactly the same how grandma made. And if you use different flour, everything is ruined. You can't accept it. It's not right. So this is the culture which also expressed through the food and food culture and food production, and keeps, of course, the culture vibrant and alive, and also is connected with aquaculture due to location. It means that the access to the marine resources. And in between, we have 2 completely different parts. First, natural and evolving. It means that Eastern European countries, big markets, indeed, within the Europe, but at the same time very rich and diverse of the food practices, and still challenging some of the normative and regulatory aspects, and still perhaps not aligning well with the structured Western food systems. But great opportunity, and carrying the strong interest to take over the Western culture, food, habits and processes, and also the systems. And then we have the Central Europe, Green and sustainable, as we know, with a strong focus on the bioeconomy, on the sustainability, and also have been promoting organic food for a long time already. So stable and knowledge, and also well-informed, even though integrating incoming cultures constantly. Some of the key takeaways from our market studies. We started 4 years ago. 3 years ago, the picture was one. We sort of saw the one economic structure, and now we see a bit different picture. Why? Because meanwhile, we had interrupted food chains. Because the transportation and also the supplies moved between the continents, not between the states, but also continents a lot. So we saw that it caused a lot of trouble to the producers, but also consumers and to the general European food security. War consequences, we see the influence of the sanctions, especially at first the feed sector was hit hard because, yes, again, interrupted value chains, interrupted supply chains, and also increased energy prices, which at the end influenced at most the producers. Because if you have higher price for your product, then you need to see if your buyer can actually afford it. And as the feed is not food on the human table, but food for the food, it is a bit different mechanism behind. We see the climate change as it is. We are feeling also this year shifting seasons. We see droughts, we see heavy rainfalls, we start to feel the freshwater scarcity. So those are the things which actually change the economy. Not only the production that before you heat it, now you start to cool and etc. It's all about the energy you put inside. And also saving or sparing the resources, reusing, circulating the resources. It's up to that. So basically we can say that economy is changing. So old models, when we concentrate on the price as the most important aspect about potential new microalgae-based proteins, it's not perhaps only about that nowadays anymore. Because if you do not have food, then price doesn't matter, right? That's the difference. You need to have at least food. So world and also European market is ready to rethink the things. They are not the same as they used to be. Also, we see that some environmental and social connected aspects as the volatility of prices. We see seasonality of the production, and we see the adaptation cost to the climate and also to the European sustainability policy. So it brings a lot of costs along, which are not subsidized for the companies. It means that where the price comes from, if we talk about the price a lot also today, it comes from input costs plus a bit extra. So nothing you can do about it if you need to pay environmental taxes, if you need to pay European labor, if you need to pay for energy produced in Europe, if you need to pay for the water, then this is the structure of your price. So you can't reduce it just like that. You need to find a way how to optimize then if you need to reduce the price. About the competitive landscape, why we chose the European single market? Because we wanted to see who operates there. And it is very good to know in the light when we have the stock in Europe about the spirulina. Yeah, and also the map shows that microalgae is produced in quite balanced way across the Europe, more in the coastline, but spirulina is used everywhere in the Europe. So a lot of production or use of spirulina. So we investigated 255 companies. who operate in some way with microalgae. They might grow and harvest it, they might valorize it, they might use it in some kind of product. And we figured out that 214 of them are somehow visible also in digital channels. They offer something and they would like to show their clients what they are doing. We identified that 15 types of microalgae is in use. It doesn't mean that it is grown there, but is in use in product formulation, which somehow are placed in the market. Of course, spirulina is leading, 166 companies somehow use it, so here is your stock, right? And in second place, of course, chlorella, nanochloropsis, and tetraselmis follows then other strains. And the leading producer is France. And what is something to think about, 41 companies are not visible at all. They are there, they are doing something, but no one knows. Perhaps they have the stock, we don't know. But we know that quite a number of those companies are located in France. Something to think about how visible you actually nowadays are, because everything goes digital, especially trade. And we investigated what kind of products are today's produced, and these are the products in the market already or somehow formulated and offered. So 68% dietary supplements in most forms, like this green, and pills, still a lot of pills, 40 years of pills. So this is the traditional based on spirulina. And 5% for agriculture. And of course, 11% a bit more for cosmetics, and then also for pharmaceuticals. This is the picture of the products on the market. There might be more, because my numbers deviate a bit from the previously proposed numbers, is 460 something. We identified 456 companies who produce algae. But microalgae only we discovered that it's below 300. Something we listed as the useful information. In many cases, producers hide the origin of their feedstock. There is quite a doubt that perhaps this is not European origin feedstock they are using. And feedstock means it might be the biomass, it might be valorized biomass, it might be in form of powder, oil, whatever form they use. This is feedstock for the product formulator. Producers depend on traditional cost-based business models. It means that price actually plays a very big role, and if they produce end-user product, then they need to have supplies, the components from different sources, they pressure on the price. This is important. This might be also the explanation why European spirulina is in stock still, because there is a price pressure. And producers are not are still connected to the grids, influenced by high input prices. And also they produce rather small scale. If we think about the potential export and conquering world markets, then it is very small scale. And many of producers who have production facilities are still so-called experimental in the research phase, not fully exploiting their industrial capacity. So we would say for small scale. And producers do not collaborate with each other much or well. We completed 17 targeted interviews. with some of the partners and also external experts, the industry side. And yes, competition is rather on the table than the collaboration. So here is the round of people who potentially could collaborate and change the current practice that everyone competes with everyone. Perhaps companies can help to valorize the biomass and something useful comes out of it. And also, products still cover very small range of applications and items. Here is the opportunity. Because if there are only green pills and something else green, then it's not enough. The opportunity relies actually to scale up the applications and not only produce the items to the store shelves, but also go into the restaurants and cooking. Really go there. This is the introduction method of the microalgae, which is absolutely not tested, not exploited, but it is very valid in the Asia. So something to think about. We did also a little profiling of the markets and consumers, most of it in the report, and it's too long anyway. But what we do need to understand about it shortly. 5 years ago, when we started this project, planning of this project, what we knew based on the literature and public understanding, plant-based is for vegans, vegetarians, and maybe in some extent flexitarians. That's it. Healthy is for people who struggle somehow with food intolerance or some chronic diseases. And proteins are for athletes. This was the starting point. I remember writing it down in our proposal. And then what is the reality we see now? All of those are commonly interested on the healthy choices. There are no such thing as proteins only for athletes. Potential consumers, as it was seen from the questionnaire from previous representative, people may not know the microalgae as it is, but they definitely know what plant-based alternative is, because each of the restaurant provides it. And among us, I assume several of you expected to have only plant-based versions of the lunch, or at least vegetarian variant of it. So it is here. It's known very well. We do not need to label it for the vegans only. Regular people may sometimes prefer vegetarian or even fully vegan food. And what we know that they are not chasing only the vegan, but they are chasing also the origin, the formulation, and availability. And it came out again nicely from Christine's presentation, that availability is somewhere, but it is perhaps not sufficient. So we might say that the market is there. Products are not. The problem is not how to create the market or how to prepare market. It is prepared already. But the question is how to place products into the market to make them available for the consumers. This is the main question, at least the understanding we have today. And also, we see that younger and more mobile, perhaps more connected to the global networks, perhaps more traveling people are those who are eager to try. Because it's interesting, and they do not have such presumptions. So these people are there ready to have, and perhaps yes, not needed to be very highly pressed or marketed on, but informed definitely. Then they also keep going to have more understanding and knowledge about the microalgae. There are people with a specific need. who actually looking for certain type of products to avoid certain type of chemicals, or to have certain type of nutrients. So these are also there, and they are used to actually navigate with the apps, because the store shelves are quite empty for them. They used to have their products ordered by the delivery, not going to the store and picking up. And also people who are more aware about let's say sustainability, and they do not actually eat meat because it is not good for the world. It is not good for the environment. And we might say that also we agree that perhaps people with higher income, but it is related with the age as well a bit, because people get married later and have families later, so they have their money for them after graduation of the university. They have their money, they can freely select what to buy. Perhaps a premium food, perhaps pay a bit more for the sustainability and also for the organic labels, because they believe that this is safe and this is healthy for them. And don't forget the parents who try to perhaps demonstrate with their lifestyle the sustainable values. And how to change then, let's say, from the cost-based to value-based. It means that the sustainability is definitely the key. It is enforced to the industry and to the society through the regulations, through the taxation soon. This is agreed at the highest political level. So this is definitely something we need to understand and need to use. Currently, it is a bit enemy to the industry, because it brings along a huge amount of investments, but no returns, right? So some of the key factors. And the red is added value from the sustainability, or sustainable way to do it. Each company targets efficiency, safety, and good value for money. So what if it is possible to target also collaboration, transparency, reputation, and integrate it into the ESG policy? Basically, each industry should have at one point the sustainable goals, and also need to report it back to the regulators. So what if not to use it for the both purposes? How to gain efficiency? Yeah. Optimizing the processes. It was keywords already were there. At first, the Necton sort of little demonstration, which need to be actually presented as the showcase, to do something with one particular production unit to take it off-grid. So it would be interesting what happens, because one item, important item, input price of the energy will change. So what happens? And also AI was mentioned. Nowadays we talk about the smart manufacturing. So going back to the stock, it was a highlight of the day for me at least, why that stock is there. Because if you produce with good faith, something, harvest once per year, and expect that the sausage producer will use it. There are several steps between. So basically, if you harvest once a year, you put your biomass to the stock, or valorized biomass to the stock. But the shelf life of the sausage is 3 months. So it's not okay for the sausage producer to have the ingredient or component only once per year, right? Someone needs to hold the stock. But smart manufacturing means that supply and demand meet. And demand is there already before the supplies are created. It is constant flow, not storage in massive way as it historically is, that we have the mass production, put into the stock or store it somewhere, and then start to sell. And salesmen go around the world and try to sell. This is old model. It can't happen because we do not have resources, and it is too expensive. So it means something needs to be changed. It means that the smart manufacturing need to adjust with the supply. And before it was keyword economic need to be put there. Economic is very simple, complex process, but very simple. Basically, if you have higher demand, then you can press on the price and the price higher. If you have higher supply, then you need to reduce the price that someone will buy your stuff. So it is very simple mechanism. So question is how to balance it in the situation when Europe produces but can't sell, Asia sells and we import, and at the same time we would like to export. This is general macroeconomic question for everyone. But anyway, if we think about consumers for the sausages or soups or other items which have the great potential, the reputation can go first. It means that no more green lies there. European consumers are quite sensitive about the green lies, because if you claim that your product is sustainable but your package is not, this is not like a honest business for the consumers. So something to think about, to use the sustainability, the higher awareness, and also political push behind the sustainability on behalf of achieving the price level, which actually covers the production costs and provides you a bit extra to put into the next research and innovation. Therefore, what we proposed for the consortium to think to switch into the sustainable business model. What it means that it is not only financial performance what is actually decisive and matters. It is integrated. It is integrated thinking which connects also the consumer's expectation to the business, not only shareholders, because shareholder always says, is it my business or not? It's up to him or her to decide. But in today's business and changing economic model, it would be beneficial also to consider connecting with the stakeholders, and consumers are one of the big group of stakeholders because they provide demand. And the last info piece, honest branding, in our opinion, is the key. Christine nicely presented the branding or the nice slogan behind and how to brand or how to market certain types of products. We are saying that it would be perhaps hard to market because there must be something extra which creates the bigger fuss around the topic. It means that if you want to introduce microalgae as the protein of the future, there needs to be information available for the target groups you choose. Information, not pushing your product, but information, because consumers might be quite smart, especially those who pay more. So provide the information, and perhaps as the ProFuture project ends, promote the proteins of the future side of each of the product branding, because branding will ensure that you will actually get selected, not the first time, perhaps tried, but selected next time. And of course, the big question, 3 questions, and then I'm out. Where is your market? The question for the industries, where is your market? Are you capable enough to conquer the world, or perhaps it is wise to start from the domestic market or region you know the best and you can provide. Because if you do not have the upscale production, then Asia might be too big at first. And the second question, who is your consumer? So try to meet the expectations of this specific consumer group, what they expect more than lower prices, perhaps. And the third question, what is your value offer? Do you offer the product or you offer value-added product? This is the question. What extra comes? Sustainability. What extra comes? Support to European microalgae. What extra comes? So those are mainly our thoughts. And the final sentence, changing the paradigm is not merely about seeing the same things differently. It's about seeing new things that were never visible before. Yeah, thank you.
Yeah, thank you very much, Lina. She's also going to be in the panel discussion later this afternoon, so I think we can take the questions then for Lina, okay?
Yeah, okay.
Cool. Then as the next speaker, we have Helena Cardoso from All Microalgae, which is a biotech company in Portugal. And she has a background in bioengineering, cell and molecular biology.
Thank you. Thank you for the introduction, and thank you all for being here. My name is Helena. I'm a researcher at All Microalgae. And I'm here to give you a little bit of the industrial perspective on things, but I think also the previous talks approached many of the topics. But maybe I can give you some examples of our case. Okay, so I'll just introduce the company and tell you a little bit about our products, and then I'll tell you about the challenges and the opportunities that we have in large-scale production, although you've heard this throughout the day. And then specific examples on how All Microalgae differentiates itself and positions itself strategically. And then I'll leave you with a ProFuture take-home message, which I also believe that microalgae can be a really present option for the proteins, not just a future option. Okay, so All Microalgae is one of the largest European microalgae producers, and we're located at the western corner of Europe in the center of Portugal. We are a team with highly specialized staffs that knows how to work industrial fermenters, tubular photobioreactors, and raceway ponds. We can produce over 100 tons per year, so as of now we're at up to 120 tons 120 tons per year. And we produce mostly Chlorella vulgaris, spirulina, and Nanochloropsis, but we also have other strains. And All Microalgae started as a research project aiming to show that microalgae are really efficient at carbon fixation. So this was a project from a cement plant that was trying to counteract the pollution caused by these large industries. So when we moved on to the industrial production, taking advantage of the photosynthetic ability of the microalgae in our industrial plant with all the tubular photobioreactors. Then we launched the Alma brand. Now, the macroalgae for food that we produce are not produced with the CO2 coming from the cement plant, because that has its own problems, as you might expect. So we now buy food-grade CO2. And then in 2015, All Microalgae gained its own identity, and soon after we started production of microalgae in industrial fermenters, what we commonly say is fermentation, but it's not actually fermentation, as it was explained in the morning. And then we launched these two brands for feed, farm animals and pets, which is Alvitae, and we have Alfertis for agricultural biofertilizers or biostimulants applications. And then in 2021, we installed industrial raceway ponds that we now use to produce spirulina. And then just last year, we were acquired by Necton, which you've heard also about. So now we're part of a larger group of Portuguese microalgae producers. Okay, so microalgae grow through photosynthesis. So we scale up from the cell culture room into flat panel reactors gradually, and then as we get the culture concentrated enough, we go into the tubular photobioreactors, and this process can take a long time. So we can also skip and go through fermentation to have much more concentrated, much faster, large amounts of biomass that we can inoculate the tubular photoreactors with. But this is only for some strains. So chlorella does allow this, but for instance, Nanochloropsis, we have to go through the autotrophic route. And then we can harvest from the fermenter, or we can harvest from the tubular photobioreactors, pasteurize the biomass, concentrate it by centrifugation, and then we can have a paste, or we can spray dry it and store it or ship it. So the paste, we freeze it and store for less time, but the microalgae powder is actually pretty stable. So it was talked about the expiration date, and what happens to the powder is throughout time it loses pigments, or it can lose some qualities if it's not in the airtight packs. Otherwise, it can be stored for a long time without losing its nutritional value. For the spirulina, the production is more or less similar, so we gradually scale it up from the lab to the flat panels to the pilot and then the industrial raceway ponds. And here we can concentrate it by sieving it in a vibrating sieve, so the permeate is returned to the raceway and we have a better use of the water. We can let the small cells to regrow in the reactors. And then the slurry, we can further concentrate it in a hydraulic press. And then we have a cake that we extrude to have an efficient drying in the solar drying. So there we have this biomass in flakes, which we call nibs, or we can grind it and have the fine powder, or we can also spray dry it to have that fine powder. And then we also can sell it as a paste. Okay, so this, I'm not going to go into much detail because you've seen this throughout the day, but this is high in protein with all the essential fatty acids. It's suitable for the vegetarian diet, but with increased B12. And it has reported health benefits. So it's a broccoli, but in greater value, basically. So rich in minerals and antioxidants from the pigments, mostly. So this is our product portfolio, which we sell online in the Alma shop, if you're curious. We have the different types of Chlorella vulgaris, from the dark green one to the light green one, the yellow, which we call honey chlorella, and the white. I should say that the honey chlorella does not taste like honey, okay? It's just a, it's just a commercial name. We also have tetraselmis, which can be used as a condiment. It has that marine taste. And we have the spirulina, either in powder or in the crunchy flakes, which we call the nips. We also have these products, pills and capsules, or we have mixtures of different microalgae species, or sometimes microalgae with spices. So if you like to cook and you're curious go check them out. We also sold some vegan sea crackers, which is a light snack, but with marine taste, reminds you of the sea. So, as you've seen throughout the day, there's no wonder that the marketing is going up, and it's not just in food applications. Microalgae can be used from aquafeeds to biostimulants to high-end chemicals or pharmaceuticals, but then you have to put into extra steps to get that value out of the algae. So we are focusing on the whole biomass at the moment. That's our product. So as for large scale, you know, there's the demand, but we need to have large scale to have a reduction in the overall costs and to have routine, consistency throughout the year so that we can compete with other land crops that are seasonal or with the fish meal that is scarce at the end of the day. So we can also use the microalgae ability to skip the middleman. And what I mean by this is that microalgae are the primary producers of pigments, of the polyunsaturated fatty acids. We know that we choose the fish because it has the omega-3s, so we couldn't just go straight to the source and try to improve the omega-3s in our biomasses. So as for water use and land occupation, microalgae are an example, but we also have shown that we can still work to improve this by reusing several times the waters. This was talked here before, but we have tested and cultivated continuously Nanochloropsis on reused water for over, I think it was 7 times continuously versus 1 in fresh water every time, and we had no difference in growth parameters, but we're still working on this. The same thing with spirulina. We reuse it up to a certain point, and we analyze the quality from time to time, but we need to gather more data. We're working on that. As for the products developed with our biomasses, we feel like there's a lot of unawareness, so we need to really show that these have biofunctionality. We need to inform sometimes our clients on what's the percentage rate that we've tried in different kinds of products. Sometimes they are pleased to know that when they use microalgae, they're substituting more than 1 ingredient, because it's not only protein, it's protein with increased minerals or other micronutrients that might be relevant. So in a recipe, we have always to think that the food producer, which is our client, has to change their procedure somehow. So that can be a challenge. They need to adapt the manufacturing process to incorporate a different ingredient that was not in the conventional recipe. So that's a challenge, and we need to help them. Sometimes they come back to us and say, this is impossible because there's this problem. And some things we can address in our production line to try to answer to that problem. So I'll show you an example focused on Chlorella vulgaris. So this is what we've been doing, and so it's sort of our strategic positioning. So first of all, we have some versatility of working with closed systems and open systems, or combining heterotrophic growth or the fermentation with autotrophic, because then the biomass has different features. If it has more chlorophyll, it has less of that grassy taste. On the other hand, if we're developing new strains, then the new strains are unknown to the public, so there's a trade-off there. But then again, we can try to select the strains and have tailor-made solutions in response to the client's needs and wants. And then Well, that's it. We have to be sensible to the industry dynamics and try to work collaboratively more than in competition, as was mentioned. So as to improving our efficiency, if you pay attention to graph A, you see that over the course of 2 weeks, a photosynthetic microalga can grow up to 1.2 grams per liter. But in fermentation, in half the time you get 100 times more concentration. So we can have the inoculum in the fermenters and inoculate all the tubular photobioreactors instead of doing the scale up so gradually. This is something we tested and we published already, that we reduced the scale up time and industrial occupancy. Then as for versatility, we have developed and demonstrated the industrial production potential of several strains of different colors. Plus we're continuously optimizing the growth conditions, the medium. So maybe at the start of ProFuture, we didn't have that yellow, bright yellow mutant that we have now. Plus, over the past year, we've had white chlorella with more than 50% protein. So we know it is possible, but we have to work towards it. And this is also for other strains that might not be yet used for food, but we can maybe refine a given pigment. So we work on optimizing the growth to then have a biomass that has increased value. And as for the trust and the partnerships we establish, I can show you some food products that were developed in other research projects besides ProFuture, where we worked together to integrate microalgae as ingredients. These were with some academic partners and some industrial partners. But at the moment, these food were tested and showcased at a pilot scale, some of them, others at a smaller scale. But then the market, you won't find them in the market, but some of them were really nice. So we need to take that step. Sorry, I don't. Well, yeah, I just wanted to make the point that the future is now, because we do have this biomass ready. So if you'd like to try, just go buy some. But me, as I say this, but me as a consumer, I'm not every day cooking microalgae. So for me, it would be easier, more straightforward to go into the supermarket and buy something already, even if it's the green bread or you know, the couscous. It's green, but it tastes good. So I quoted the ProFuture project because I think it really did shape some of the future proteins that we'll be using. And this was already shown as well, so I'm not going much into those. But you know, algae contribute to the sustainable goals that were set in several ways. They contribute to our health and food security, to business development, and to the environment, and indirectly to other of the sustainability goals. And the final point is we should work together. We show work by demonstrating what is feasible at large scale, but we can also try. My commercial team is keen on giving feedback on the products that were developed, on the bioactivities that we know exist, on the levels of incorporation. That sort of feedback is really important for us as well, to establish our client base, because sometimes we're the ones looking for clients instead of the clients coming to us interested in the ingredients. So it's still a very immature market, I'd say. So thank you all of you that were involved in this nice project. I think for us it was a leap in terms of the technology that we tested here. We are implementing it on our activities. Definitely, and in terms of incorporating the ingredients, I mean, that's our business, so thank you all for your contributions. And please contact us.
Thank you, Helena. Are there any questions?
You have a lot of nice facilities in Portugal for cultivation of algae. How far does the climatological conditions play a role? Do you think you can just transfer your model and your business model to other, like more northern countries? Because you also do a lot of work with fermenters, not necessarily linked to photoreactors.
Yes, so fermenters would not be dependent at all. Maybe they would be more dependent on the CO2 and on energy prices, but they could go, they're not dependent on the environment temperatures. Now our facilities are located in the center of Portugal, which is more or less stable throughout the year. We do have some winter and summer strains, but we can manage that.
Is, for example, investment from your government also a reason why there is so much algae activity there, or?
Well, there have been some research projects in microalgae, but I wouldn't say there's a lot of investment from the government. Well, there is some, but through research projects mostly.
Could you comment on the protein content and also the taste of the white chlorella powder that you show us when compared to the colored one?
Well, the ones that we retrieve directly from the fermenters generally have a lower protein content than the one that we produce autotrophically. But still, we're optimizing conditions to bring it up. So maybe instead of 60%, you'll get 40 to 50, sometimes 25% protein content in the fermented ones. As for the different colors of the fermented ones only, I don't think that's necessarily a bottleneck. I think if we can increase protein content of the white chlorella to 50%, why not the others? We just have to play around with the conditions, I think.
And does the white one taste better?
Oh, well, I brought some samples if you're curious. It's more like a flower with a neutral taste. The dark green is really strong. I personally don't like the dark green, but you know, I've taken it in some bread and soup, so it's an acquired taste as well.
Thank you for a very interesting talk. If it grows, your chlorella grows so well under fermentation, why grow at all using light?
Because when we grow it exposed to light, then it produces a lot of chlorophyll, which means it's enriched in these antioxidant pigments and also in the polyunsaturated fatty acids, which are at the membrane of the chloroplasts many times. So it's an increased value to the biomass, although the taste also comes with it. Plus, in the photobioreactors, you have that microbiome that stimulates B12, all those extras.
Thank you for the very interesting presentation. I have a comment and a question. On one of the slides, you mentioned several health benefits that are, I guess, related to the chlorella, I think it was specifically. There were some things mentioned there that I think, at least from an EFSA perspective, would, well, not rather, how to say, classify as a health claim that can be substantiated. So it's good to think about how to communicate that, at least, so to also make sure that well, we keep the scientific maybe say communication of information. On the other hand, I think I just saw the slide briefly on the levels of B12 and iron that are in there, and I think that could be very interesting. Actually, maybe not just looking solely at the protein or biomass purely from the microalgae, but potentially also in combination with other alternative protein sources. Is that something that you're looking at? To look at these kind of specific benefits where the high level of B12 or iron could really be beneficial, potentially in combination with other sources.
Okay, first of all, thank you. I also struggle sometimes with distinguishing marketing from the evidence. We have some evidence about the health benefits, but tested in cell models or in animal models, and human nutritional trials are much harder to control. So I completely understand. On the second part of the question, we have discussed perhaps cultivating together with yeast, and but we didn't try anything like that yet. We have tried to select the microbiome, so mostly bacteria living with chlorella in the outdoors reactors, and try to select, and we have shown now that we can grow those bacteria and join them together with the chlorella and enrich the biomass in some pigments. We're testing for the content in B12, but we have shown that the bacteria can help the microalgae to grow better and to have those nice nutritional features that we look for. I think for now this is it, but we're always looking to improve our biomass. Yes, thank you.
Okay, thanks a lot. Then we have a little coffee break now, and again downstairs, and we see each other at 4:10 again.
Test. Okay, welcome back, everyone. I hope you had a nice rest. We're going to continue now with a video message from Kim Anderle. Unfortunately, she couldn't join us today, but she recorded something for us. Kim Anderle is part of the EU-funded project, and she works for the sustainable project GmbH and the Submariner Network for Blue Growth, EEIG.
Hello, everyone. My name is Kim Anderle. I am the facilitator of Working Group 4 Algae for Feed under the EU-funded project. I'm sorry I couldn't be there today in person, but I hope this virtual recording will suffice to give you a short little overview of what EU-funded is and what you can expect from the working group. EU-funded is a collaborative platform for stakeholders interested in micro and macroalgae, where they can share relevant experiences that they've had and also find support. The overall objective is to accelerate the scale-up of a regenerative, resilient, fair, and climate-friendly algae industry within Europe. There are multiple organizations running it, such as ESPRO, the one that I work for. Currently, we have just over 800 members registered and participating within the different working groups. We have 7 working groups, spanning across different sections or sectors, such as this one is for feed, there's one for food and youth and entrepreneurship, and others. Where can you find us? On the Maritime Forum, circled here in green, you'll find EU-funded. You can also use your phone to scan this QR code. Then you will come to this page where you have the different working groups. There is Algae for Feed, the one that we were involved in today. As you may know, the EU Algae Initiative was announced in November last year, which includes 23 actions to upscale the algae industry, which also resulted in the EU-funded project. And here I've listed the 23 actions, and in green I have highlighted the ones that are most pertaining to this working group, and with an asterisk, the most relevant. So I'll just read the ones with the asterisks through quickly. Develop market stimulating mechanisms, develop algae-based feed, promote carbon capture, nutrient extraction, and LCA methodologies, support for SMEs, align safe levels on contamination and iodine, new processing biorefinery systems, new cultivation systems, consumer awareness campaigns, and labeling frameworks. Addressing these points will lead to the strategic development of the algae sector, and these are points that we hope and should discuss within this working group. Overall, the goal within the next 2 years of this project, or the full 2 years of this project, is the promotion of algae feed product development by improving the business environment and cooperation across algae feed value chains. Our expected outcomes are also listed here. We hope to develop fact sheets on research and development needs, produce lists of funding opportunities for innovation, produce guidance on business support, report on legislative barriers, and to produce some campaigns for algae feed products. We have this action plan which guides the work that we do within this working group, and it was developed with the working group members at the beginning of the project, and some of the key tasks are listed here. The ones with a little check next to it are in progress. Integrate knowledge from relevant projects and studies, develop a knowledge hub with these relevant studies and projects, host regular meetings, which I'll talk about a little bit later on, develop 1 to 2 product licensing roadmaps. It's one of the biggest barriers identified here. Define next levels for research and development, and raise awareness to understand the feed market and consumer trends. Some of the networks and events that we're collaborating and engaging with are shown here. Obviously, FIFAC and FIFANO are big organizations that we collaborate with. We will be at the Mission Arena in November and the EU Algae Awareness Summit in October. So if you're at any of these events, please come over and let's have a discussion about what you're doing and how we can cooperate. Here's a little draft mock-up of the Knowledge Hub, which you will be able to find on the EU Algae page. It's a project database that you can easily filter through and find any types of projects or studies related to the work that you're doing. On the left, you can find a mock-up presentation of fact sheets that we want to use for raising awareness and campaigning some of the projects that are out there, which will be posted on websites and social media. Some of the main barriers identified within our previous workgroup meetings are listed here. So long time to market and costly, legislation, regulation, extremely complex, and there is a big barrier around safety and risk assessments, especially when it comes to using some of the newer species. This we then developed into some needs within the working group, and these are all things that we're working on currently, these guidelines, how-tos, and kind of best practices, funding opportunities. We actually will have a report coming out through EU4Algae within the next couple months, which is a non-exhaustive list of funding opportunities, tools, and resources within the industry. We want to produce guidance on safety requirements and also show some success stories. So keep your eyes out for that because they will be coming on social media soon. Here's a little meeting timeline of our past and next meetings. Our last meeting was in April, which we had representatives from FIFAC, FIFANO, and DJ Sante giving a presentation, and then we had a really nice discussion afterwards talking about regulation and legislation for bringing feed to the market. Then the next one will be in November now coming up, where we will have some EU projects discussing some of the regulatory barriers they have been facing, and also have some scientists give some specific evidence for using algae within feed products and the benefits of this. If there's anything interesting that you are working on or you want to pitch, please get in contact. We're always happy to have people present and share the work that they're doing. And this basically already brings me to the end of my presentation and the short little overview. Here you have my email. So contact me if there are any questions or if you think you'd like to present at one of our meetings or get involved. And yeah, I thank you very much, and I hope you still have a very nice day. Bye.
Yeah, thanks to Kim for this overview. Next, we have another algae project called CircAlgae. And Amparo Jimenez Quero from Royal Institute of Technology in Sweden is going to present. She holds a doctor in biotechnology and focuses on the valorization of biomass into chemicals, materials, and food and cosmetic additives. Yes.
Thank you very much. Thank you for the introduction, and it's a pleasure to be here today. Also seeing the wonderful results that have been achieved by the ProFuture project. Hopefully, us, in some years, we will be presenting our results. So let me first introduce the project, CircAlgae. CircAlgae is a circular valorization of industrial algae waste streams into high-value products to foster future sustainable blue biorefineries in Europe. I'm still surprised that the Commission found this project with these long names. Anyway, so what we are aiming in CircAlgae is something that has been discussed a little bit this morning, is how we make food ingredients a bit more sustainable. and also maybe economically feasible here in Europe. So our idea is to integrate this biomass valorization of industrial relevant macro and microalgae, that's why I'm here now, waste stream into food, feed, and cosmetic ingredients. Meaning we will make a holistic approach in order to get the most from this biomass. I will give you examples from macroalgae, just to talk about a different type of algae. We produce, together macro and microalgae, almost 40 million tons of biomass worldwide. However, there is a specific production of algae. I will talk about agar. I mean, most of us, we have used this molecule, right? At the kitchen or in the lab. Agar is a molecule with a very specific molecular weight and structure that is obtained from red macroalgae. This algae, macroalgae, seaweed, we need to import it from the tropics. So it's not even produced in Europe. And you know how much agar represents from the whole biomass of this red algae? It's just 30%. Meaning we bring that with all the CO2 impact that suppose, and then we just obtain 30% of it, and the rest is discarded. In most, or like a likely scenario, is going into the soil again, but in some cases it's just burned. This biomass is highly rich in other molecules, and this is where Circalgae is trying to make their work. So we are aiming to develop, three different biorefinery schemes in a upscale process. So we are going from hundreds of kilograms of biomass, and we are creating 12 different demonstrators by the end of the project. So the idea is like 2 final products will include also consumer assessment and be qualified for the market. So we are really trying to reach from the research point of view until the market. Something that has been discussed many times today about the stocks, etc., is like how fast is growing the industry of algae in Europe. And that is because there is an interest. Has been highlighted just before, like the market and the business is there. We just need to provide the ingredients, to provide what the algae can give us. So it's quite impressive how that is growing. So what we are expecting from the future blue bioeconomy is more products into the colloid industry, of course proteins, as the niche that is gathering us here today, but also fiber, very important for food and for feed applications, other nutrients as well, bioactive compounds, that is where also cosmetics and biomedical are really interested into algae nowadays, and of course energy. So here you have a schematic overview of what we do in Circalgae. So the main idea is to use this side stream waste in order to extract the maximum of it. The idea that what we are implementing is an innovative cascade extraction. Some people has asked, I think, to Imad this morning, why you didn't use high pressure homogenization. That is one of the technologies that we are tackling with Circalgae, together with other alternative extraction techniques that they are using just water. So the idea is to really prevent the degradation of the bioactive compounds that they are in the biomass. With that, we are assessing different algae ingredients and characterizing the functional and the bioactive properties. That is very important because the idea is not just upscale something and create a biorefinery. It's to really make something that the stakeholders has an interest. And that has been planned from the beginning in the proposal, but now with the project, a stakeholder has a main role in order to tell us, in my case, coming from a university, where to drive my research, but also in the people that they are processing algae in Europe, what they want, what type of ingredient are they interested in. And the final, let's say, real products that we will be testing are a bunch of different approaches, so for feed, food, and also cosmetic, that of course will be assessed in the terms of the health benefits and also in the terms of sustainability, for instance. Here is a representation of who we are. So me, I'm representing in that case KTH, which is the coordinator of the Circalgi project, but we are in total 21 different partners. You can see a couple of partners that have been also participating in ProFuture. Our project has a length of 4 years, and we started in last October, meaning we still have some time in front of us in order to reach our goals. We have an estimate budget of more than 10 million euros in order to reach all these objectives that we have. And we are very proud to see like it's really industrially oriented. So 15 of these partners are industrial partners. And we are also very diverse in the background and in the location. We are coming from 11 different European countries. So let's focus in that case in this part, which is the microalgae. No? We were talking microalgae can be refined. We can do a biorefinery out of it, and that is something that is already in the macroalgae business. Some people cultivate microalgae for the pigments, for the lipids, for the proteins in that case, but there is still leftovers biomass that is very important to tackle. So once that we have separate, for example, the soluble proteins, or we have separate lipids and pigments, there is still a solid effluent. We have a lot of unextracted proteins, fiber and pigments that we claim with our novel cascade extractions can be obtained as an ingredient. So that is the high point of why we need to valorize also biomass, or this waste that is, of course, not a waste, it's never a waste, part of the biomass. It's the same case also when we use brown algae and red algae, as I presented before. So just to finish, and as a main take-home message, Circalgi project is a set of cross-sectorial and systemic innovative strategies that aim to create a sustainable and competitive algae biorefinery by fully utilizing the biomass into high-value, healthy and functional ingredients. Of course, I invite you, if you want to know a little bit more about the project, like you can visit our main webpage, but we also are in different social media. And of course, and today has been clear, there is a lot of synergies to explore here, a lot of products or ingredients that can be tested by different stakeholders, and that will be great if we can find a way to integrate the end of this ProFuture project with this continuation of the Circalgi. Thank you very much.
Are there any questions for Amparo? Mm-hmm. Other questions?
Thank you. I forgot to tell to your community, which is a scientific community, that actually my work is I'm organizing a pan-European and Mediterranean political movement according to Aristotle, a regional movement, which is based in 3 pillars: in direct democracy, citizens' assemblies, in science is the 2nd pillar, like you, and in ecology and arts. So from this section of the scientific group of ours, I'm here, and there are, of course, a lot of questions about the pH en anglais, pH of français, because all this you are doing, when you say waste, what do you mean? Because the algae, as we know, it depends from the pH of the environment they are being developed. So the wastes, what kind of pH they have, and what exactly do you mean by waste? So, and how you make this actually beneficial for our use as humans. Thank you.
So, as I say in the presentation, we use the name waste when we present the proposal. I'm not a fan of calling any kind of biomass waste, because in fact, and now it's very important, like we change our mindset to that. Circular valorization of any kind of biomass, meaning no waste, make it. When we mean waste is this side stream biomass that is discarded in a way. So if there is a producer of agar, in that case, and they focus just to get the molecule they want, is all the rest of the algae that they are not using. In the case of macroalgae, there is also an important fraction of proteins that they are not exploited in that waste. Also cellulose, which can be a very interesting ingredient as texturizer for food and for cosmetic application, or even use as a fiber itself. So it's not waste, it's just a side stream from the current industrial production, I would say.
On this question of a name, we speak about co-product or co-products. Then there is no question of waste, especially because waste then has regulatory issues. So even like when we want to use carbon dioxide from industries, well, it's gonna not be a waste. Could you be more precise or give example, please, on what type of products you are targeting from the co-products you will be using as raw material?
I mean, we have, of course, a very diverse number of raw material that we are starting with. Some of the industry, they are generating not just the solid waste, but also some liquid effluents. In the liquid effluents, for instance, there are very interesting bioactive oligomers that could be used as ingredients because they have prebiotics properties. So meaning as food or feed ingredients. There is proteins, soluble proteins that they are not tackled sometimes when you just want to separate long polymeric fractions, and that is part of the liquid effluents. In the solid, I say before, there is also sulfatate polysaccharides that they are very interesting for the formulation of different final products. Also cellulose, for instance, since we are aiming to do a cascade, the important part of it is like we are extracting from the most valuable to the less valuable compounds, meaning we will put focus in implementing technologies that allow the extraction and the solubilization of high bioactive compounds, which normally have a higher price in the market. And then we will continue with harsher technologies in order to get the more recalcitrant. Once that you continue extracting, at the end what you get is the most pure fiber. So that will be, for instance, cellulose or a very recalcitrant polysaccharide that can be attached there. So that are some of the examples of the products, and of course that will be implemented in different demonstrators.
Do you receive your biomass from industry, or do you start with the most optimal seaweed you have from harvesting?
No, everything is coming from industrial side stream. That's why it's very important, like we have contact the main producers of algae ingredients in Europe.
And, and how is the status or condition you have? And do they keep into mind that there is a cascading, that they use, that like they don't use certain solvents that is determined for the rest of your cascade? So
it's very important, this point is a very good question. It's very is essential, in fact, to understand from where this side stream is coming. So we know well what is the procedure the industrial partners they are implemented into the biomass, meaning if they have been using some harsh solvents that later on they will have some problems in order to use ingredients for food or feed, for instance, we will avoid to put it into the cascade to obtain the small molecules that probably will be affected by the use of solvent. So we will go for more harsh extraction, so we will get fibers that they are stronger, a bit less affected, and of course there is also a downstream process that need to be down there. In other cases, most of these soluble polysaccharides that they are obtained from macroalgae, they are obtained with mild extractions. So they do a maceration or something like that. So in some cases, they don't even use solvent. They just heat it a little bit and then they obtain it, meaning this waste is just biomass. It's just a raw material that can go to another biorefinery path. Yeah. No, we don't pay. We have partners in the consortium. So they got even money, so no.
Thank you very much. Thank you. Okay. Go ahead. You can.
Yeah, I was just wondering, you know, we talked about our co-product, and you also said that you have some microalgae partners that provide co-products.
Yes.
Do you have an example, or you want to give us more details? You know?
I mean, our partner is for the microalgae are from Portugal, so Algae for Future. They are providing different species that they are also refining there, so we are getting also waste. Roquette, that is not more Roquette, Klotze, that they are also providing some of the microalgae, and EGB also in Germany. In that case, they are cultivating new species that they are a bit less trendy, let's say, but we want to explore the use for biorefinery. So the biomass is a bit more diverse. They are not just cultivated for having 60% of protein. They are biomasses that we know will fit better in our cascade. So we want to really see that. And one of the points of the project is also to increase the yield of the biomass for the biorefinery process. So we are also having a study on that. But that, I mean, we are not working with the spirulina, I have to say. So this is no.
But can you say if most of the residue you get from microalgae are, let's say, microalgae were biomasses where they already extracted, for example, oil?
Yes.
Yeah.
So that is one of the points. So, I mean, when they cultivate it for the obtention of fatty acids, for instance, because they want to sell pure omega-3 or whatever they produce, what we get is a residue that is high in proteins, but also in fiber. Because it's something that we are forgetting, but in the cell wall of different microalgae, there is a big part of fibers that is also very interesting in order to use as a food ingredient, for instance. Okay, thank you.
Thank you very much. Yeah. Okay, we're going to have a very, very quick stretching session just to get some energy. And then we're going to continue with the presentations. Okay. Now it's the pleasure to have Estefania Noriega Fernandez here from the European Food Safety Authority.
Thank you very much for the kind introduction. I'm not sure whether I will be able to keep this relaxing momentum with this presentation. But anyways, my plan for today is to give you an overview of what's new on the EU menu from the novel foods perspective, with particular focus on the safety assessment of novel microalgae proteins towards pre-market authorization in the EU. But first, let me remind you that EFSA is the reference body in the EU for food safety from field to fork as established by the General Food Law. And EFSA's key activity focuses on risk assessment, or in other words, EFSA provides independent scientific advice on food-related risks in order to support regulatory decision-making by the EU risk managers. And together with the European Commission, EFSA also plays an important role in risk communication. Much has been said today about the novel food regulation, but still I would like to confirm that the new novel food regulation, enforced since January 2018, applies to the placing on the EU market of any food not consumed to a significant degree within the Union before 15 May 1997. And among the new provisions of this new regulation, the risk assessment is now centralized at EFSA. Legal deadlines apply to both the risk assessment and the authorization procedure, and new novel food categories, the Union list of novel foods, and data protection provisions are now in place. And in parallel to the implementation of this new novel food regulation, EFSA developed scientific and administrative guidance on the preparation and presentation of applications for authorization of novel foods. But I will come back to this later on in the presentation. With regards to the authorization procedure, it starts with the submission of the application to the Commission, which may consult EFSA on the suitability of the dossier. And once the application is declared suitable by EFSA's front desk unit and the dossier is validated by the Commission, then the Commission will mandate EFSA for the risk assessment. EFSA will launch a public consultation on the non-confidential version of the dossier, and eventually the working group on novel foods, coordinated by my unit, will perform the risk assessment. And it's important to mention that in 80% of the cases, the adoption of the EFSA opinion on the safety of the novel food by the NDA panel takes place within 20 months since the validation of the dossier, which includes not only the 9-month legal deadline for the risk assessment, but also the time needed by the applicants to provide additional information. Then, within 7 months from the publication of the EFSA opinion, the Commission and the Member States will submit the draft implementing act to the PAF committee, which is composed by representatives of all EU countries, and following a positive vote by a qualified majority, then the novel food will be authorized. Important to mention that following the provisions of the new transparency regulation, the list of intended studies to be commissioned or conducted by the applicants to support a novel food application must be notified on the EFSA Connect portal before, this is very important, before the starting date of the studies. And the non-compliance with this mandatory pre-submission requirement may cause some additional delays in the process. In addition, the applicants can benefit now from general pre-submission advice from EFSA, and therefore applicants are strongly encouraged to contact EFSA well in advance before filing the application. Finally, another interesting point in the novel food regulation is the introduction of a faster notification system for traditional foods from third countries, which is a subset of novel foods with a history of safe use in a third country for at least 25 years. And in this case, both EFSA and the Member States have 4 months to raise any duly reasoned safety objections to the placing on the EU market of the concerned traditional food. But moving now to more tasty aspects, just to confirm that novel foods can fall under at least one of these categories, which, as you may notice, cover different food sectors, and among others include foods consisting of, isolated from, or produced by microorganisms, fungi, or algae, and also foods derived from cell or tissue cultures from living organisms. And on this graph, the number of novel food applications that enter EFSA's risk assessment since 2003 is sorted according to the different novel food categories. And as you may notice, a significant increase has been observed since 2018, if you recall, when the new novel food regulation entered into force. And since then, we have received typically about 40 dossiers per year, and a substantial part of them correspond to foods derived from microorganisms, fungi, or algae. And to give you some figures, since 2018, we record a total of 88 adopted scientific opinions, including 12 negative opinions, and about 22 applications withdrawn by the applicants. Now, with regards to the latest trends in novel foods, which of course also reflect recent food innovation and consumer drivers, typical categories include novel proteins and carbohydrates, plant extracts, nanomaterials, and foods resulting from new production processes. And in relation to novel proteins, they can be derived from novel protein sources or from traditional protein sources using new production processes. Examples of novel protein sources include, as you know very well, insects, plants, algae, byproducts, or microorganisms. And on this part of the slide, you can find a few examples of microalgae or products thereof, not necessarily proteins, which are already authorized as novel foods or otherwise are currently under risk assessment by EFSA. In addition, cell culture-derived foods of animal or plant origin and food ingredients derived from precision fermentation, for instance, using engineered microalgae, promise indeed to revolutionize our current food systems. And at the Scientific Colloquium 27, EFSA brought together relevant stakeholders in order to discuss ongoing trends and research in these areas, and also emerging safety and methodological aspects to ensure the fit for purpose of our risk assessment approaches. And in relation to the risk assessment of novel foods, as already mentioned, EFSA developed two guidance documents, which are currently under update, on the administrative procedure and the scientific requirements for the risk assessment, which include, for instance, information on the identity, production process, and composition of the novel food, nutritional, toxicological, and allergenicity assessment, and anticipated intake of the novel food under the proposed conditions of use. But it is noteworthy that our assessments focus on the safety and nutritional aspects of the novel food under the proposed conditions of use. But the efficacy of the novel food with regards to potential health benefits, health claims, is not part of the risk assessment. Before jumping into more concrete examples, I would like also to emphasize that microorganisms, including microalgae, can play three different roles in the context of novel foods, and this will influence the scientific requirements for the risk assessment. First of all, viable or non-viable microorganisms can be intended as novel foods, as this was the case, for instance, of the microalgae Euglena gracilis. Then, microorganisms can be used in the production of novel foods, such as paramylon, isolated from Euglena gracilis. And eventually, food enzymes of microbial origin could also be used in the production of novel foods. But considering the scope of this conference, the first two roles might be the most interesting. So having this in mind, I'm going now to give you some examples, more concrete examples, for the risk assessment of microalgae and proteins thereof. So first of all, the microalgae strain should be deposited in an international culture collection under the Budapest Treaty. The taxonomic identity should be unequivocally demonstrated. And for GMMs, the purpose, characterization, and structure of the genetic modification should be reported. In addition, information about potential toxigenicity and pathogenicity should also be reported unless the QPS status is granted to the particular microalgae species. But I will come back to this on the next slide. Then, in case of novel proteins derived from microalgae, their identity should also be characterized, for instance, through molecular weight distribution or molecular fingerprinting. Then a detailed description of the production process should also be provided, including information, for instance, on raw materials, culture media, processing aids, propagation and culture conditions, downstream processing, and also company certifications for quality and safety assurance systems. And for GM, microalgae strains used in the production of novel foods, the absence of viable cells and DNA in the novel foods should be demonstrated according to the corresponding EFSA guidance, which is currently under update. Then the composition of the novel food should also be characterized, preferably on at least 5 batches of the novel food by accredited laboratories using standard validated methods and including, as you can see here, I pressed the wrong button. As you can see here, main constituents, impurities, proximate analysis, substances of toxicological concern, microbial contaminants, particle size, and storage and food matrix stability. In addition, nutritional information on the novel food should also be provided, including, for instance, amino acid, vitamin and mineral profile, protein quality, including protein digestibility studies, and the potential presence of anti-nutrients. Then, ASME and toxicological studies should also be provided according to the tier approach described in the corresponding EFSA guidance. To give you an example, the tier 1 includes evidence on gastrointestinal absorption, in vitro genotoxicity, and in vivo subchronic toxicity. And the toxicological studies should be conducted in compliance with OECD guidelines and GLP principles and using representative test items. But I would like to confirm that the results from the tier 1 may still trigger the need for additional studies under higher tiers described in the corresponding guidance. And finally, the potential allergenicity of the novel food should also be discussed, for instance, by providing a comprehensive literature review, reporting the protein content, or through in silico analysis. As I mentioned, I would like to say also a few words about the QPS assessment, which is a fast-track safety evaluation of microbial strains belonging to QPS taxonomic units. And for your information, for bacteria, yeast, microalgae, and protists, the lowest taxonomic unit for which the QPS status is granted is at a species level. This QPS assessment is triggered internally by EFSA when receiving applications for market authorization, is independent of particular dossiers and legal frameworks, and it is based on an extensive literature search on the particular species, is coordinated by the EFSA Biohazard Panel, and includes taxonomic identification, body of knowledge, and potential safety concerns with regards to toxigenicity, pathogenicity, and the safety for the environment. Important to mention that safety concerns with regards to QPS taxonomic units are reflected when possible as qualifications to be tested at the strain or product level. And then for GMMs for which the species of the parental or recipient strain qualifies for the QPS status and for which the genetic modification doesn't give rise to safety concerns, then this QPS status could also be extended to the GMM. Therefore, to conclude, for microalgae strains belonging to QPS species, the taxonomic identity should be unequivocally demonstrated at the species level. And if relevant, the safety of the genetic modification should be confirmed and potential QPS qualifications should be met. But this in addition to the specific data package that is requested in the corresponding sectoral EFSA guidance. And just to confirm that the current microbial species included in the QPS list hold all of them the QPS qualification for production purposes only, which means that the absence of viable cells in the product should be demonstrated according to the EFSA guidance. And now I think that it's time to start wrapping up the presentation, but still I would like to confirm that EFSA's role in the novel foods area includes the development of scientific and administrative guidance documents, the scientific assessment of food safety risk, scientific cooperation and communication activities. But what EFSA doesn't do, what is beyond our remit, is to develop food safety policies or legislation, to adopt regulations, to determine the novel food status, to authorize the marketing of novel foods, to define labeling and post-monitoring conditions, or to enforce food safety legislation. And trying to anticipate some of your potential questions, I would like just to confirm that the Novel Food Regulation establishes a procedure for the determination of the novel food status, where the food business operator should consult the member state where the novel food is intended to be placed first. And the outcomes of this consultation process on the novel food status are published on the website of the European Commission, together with a brief statement on the corresponding decision, which has EU-wide validity. In addition, I would like also to remind you that EFSA has in place a series of support initiatives for applicants that are summarized in the corresponding EFSA catalog to be published by the end of this year, to be updated, sorry. For instance, they include general pre-submission advice, clarification teleconferences at the suitability check and risk assessment phases, and also closer support to SMEs. And in addition, you are strongly encouraged as well to consult the toolkit for applicants, which, for instance, includes information about the new requirements of the transparency regulation, to ask EFSA question on the EFSA Connect portal, or to visit the Open EFSA portal where, for instance, you will find information about applications and public consultations. And if I have 1 minute, just before finishing the presentation, I would like just to make a very quick announcement. First of all, EFSA is organizing a webinar on novel foods on the 26th of October, where the different steps and tools for the submission of applications, requirements of the transparency regulation, and also the main issues encountered by the applicants will be discussed. On another matter, and as a result of a negotiated procedure, EFSA, together with the corresponding contractor, will kick off, by the end of this month, a developmental project on the effect of processing on protein safety and further impact on the risk assessment. And this will include a stakeholder consultation, so if you are interested, please contact me so you could be included in the list of stakeholders to be consulted during the project. And finally, EFSA, together with many other relevant organizations, will join the EIT food training on algae biotechnology, which will provide relevant insight from both research and innovation perspectives. And that would be all from my side. Thank you very much for your attention. And I don't know if we have time for questions.
I think we have time for 1 or 2 questions, if there are any. Mm-hmm.
Thank you very much for your presentation. If I understand, so far, what has been done is on novel foods. So has there been like an EFSA guideline, or is there like a guideline for also novel feeds for farm animals, or is there an ongoing like risk assessment for animal feeds? Yeah.
I must say that I work at the at the Nutrition and Food Innovation Unit, Novel Foods team. But yeah, indeed, there is some ongoing discussion as well about a guidance on the novel feed. But I'm not really involved in that area, I'm sorry.
No problem.
We are, separated units. Yeah.
All right, thank you very much.
For your novel food, also the processing and everything is important. So does that mean that each company has to submit its own dossier? Because each company has a bit his specific way of processing and producing?
I don't know if you're aware of that, but the authorization of a novel food, in principle, is generic. Generic. It means that, well, as you know, in the Union list of novel foods, there is an entry for the particular novel food, a column with the conditions of use, a column with the specifications, and as you know, the specifications include a brief description of the production process and parameters related to the identity, composition, and safety of the novel food. So anyone who wishes to market the novel food within the Union, provided that the product complies with the specifications and so on, I mean, there is no problem. Unless, this is the unless, unless the first applicant, at the time of submitting the initial application, requested data protection of proprietary data. If it is granted, then this applicant will get an individual authorization for 5 years, unless a subsequent applicant manages to get the authorization without making a reference to the proprietary data or with the agreement of the first applicant. But this should be included on the union list. It's indicated on the last column whether this is a generic authorization or an individual authorization. Then the name of the company, details, and the timing for the individual authorization are included.
And like in the case of tetrasalmins, I think this is one of the few that is already approved. Is that generic?
If I recall well, because tetrasalmins was not evaluated by EFSA under the new novel food regulation. It comes from the previous one, and in the previous regulation, it was the member states assessing the dossiers, and EFSA was only requested to assess those for which there were unresolved safety issues. No? But if I'm not mistaken, tetrasalmins, I think that is a generic authorization. Yeah.
Which is the rate of data protection? Which is the rate of data protection?
I cannot. It's a very interesting question. I cannot give you right now some figures, but what I can tell you from my experience is that lately, more and more, we are getting this request in the application. The most important that you need to know as well is that this data protection is granted for newly developed scientific evidence that is really crucial for the risk assessment and the authorization, and on which the applicant has the exclusive right. And then a justification, when they submit the application, a justification has to be provided on the...
And do you confirm that even a scientific review is deemed to be sufficient to require the data protection?
I cannot comment on that.
Oh, I mean, it's not. I'm not asking for a comment. I was just acknowledging the reality of data.
I think that when it is in when some results are published in a scientific publication, then the IP belongs to the journal.
Yeah,
if I'm not mistaken.
But before publishing?
Before publishing.
I mean, I make a scientific review, and I bring it to the European Commission, therefore to EFSA as proprietary data.
It depends on how relevant this scientific review was for the decision, because at the end of the opinions, there is. Let me show you, because I think that I have it here. Sorry. Okay, here. At the end of our opinions, there is always this section. I put it because I always get these questions. There is this section where EFSA has to confirm that the data requested by the applicant as protection for proprietary data were really essential for the risk assessment. And yeah, indeed, but it's not EFSA, as you know, granting the data protection, it's the Commission.
It's the Commission.
Yeah, it's the Commission.
Thanks.
Okay, thank you very much. I think we have to continue with the panel discussion now. So I would ask Jean-Paul to come to the front. Okay, all panelists can come to the front.
I'm supposed to stay like the other.
You have to stay standing. Yes.
I was just going on the side. You are supposed to sit also. He was standing. You have the right to sit.
You cannot. Do you want to stand?
Yeah, that's okay. As you want.
Okay. No, it's better. It's better.
So it will make a difference between the people who are talking. So actually, I have a list of questions that were prepared, but some of you didn't have the chance to ask. There are two that had not time. This is also your fault because you were too long, no? No, sorry. If we could start with, if somebody had questions and didn't have the time before for the you and well, somebody else had no time for the questions. Yeah, Alexander. No? Okay, for you. Olivier. Olivier, go on.
Yes. No. Yes.
Yes. Olivier Lépine from AlgoSource. Lina, just wanted to put a bit of blue in the discussion because you showed only green stuff. So it's a blue product and that exists. And it gives me the opportunity to ask you a question, because I think we are dealing with sustainability here. And one of the questions is really how we make our business sustainable on all pillars. We've discussed the LCA. Well, first comment is that we were comparing microalgae products with other vegetal, but in terms of sustainability, there is the question of European products sustainability and also in terms of social assessment. We said that electricity is the main driver. So if we compare the electric mix in Europe and where it's going to the electric mix in China, for example, well, when we import biomass from China, we import their emission, we import their coal, in fact. So there's a big difference, and we are not communicating on this. Second point is that, well, I try to pinpoint the fact that we really need to demonstrate where our products are different and why. And I think that in the communication, we should be more focusing on where we can get to and show that with best practices and best technologies, there is a difference. And today, for example, because we chose to present an average in terms of results, when we don't show this. And then last point is that really if there is no difference between our product and products coming from China, products coming from other sources, then people will not buy them because they are too expensive. So there's really a question of showing the difference. And I think there are some differences, but we are not communicating enough on those differences. And also, I mentioned the soil issue, the fact that we are not on arable land, and it's not positive. It's not counted anywhere. There's no value in it. So, well, if you have any comment on this, I would be pleased to hear them.
Yes, as we had a little talk during the coffee breaks, yes, sustainability and life cycle assessment are not equal terms. I was talking about the sustainability in terms of also socio-economic and environmental combination. It means that if we take only the sustainability as the life cycle and assess this part, we leave out very important features as actually European ability to provide jobs, European ability to export their products, because there is a difference if we bring in or take out. We are in the balance regarding the algae. When we bring in more, it means import more than we export. This is not good for European economy, nor good for the European producers wherever country they locate. It means that the balance is, in our opinion, important, and the added value, because as it was shortly explained, or at least I tried to explain, it is not anyhow possible to compete with Asian prices. Even if we switch off from the grid, even if we switch off from the fossil-based resources, anyhow, yeah, Europe is more expensive, but our task is to provide jobs and to support European companies. And if microalgae is the one of the biomass we see, it gives us benefits in several fields, not only for food but also cleaning perhaps our environment and etc. etc. The balance needs to be found there, and as I said, perhaps we stuck too much on pricing. Perhaps we need to concentrate on the value created, and perhaps we should protect our single market to enable companies to grow, to scale up. It takes time, and perhaps we need to think about incentives or subsidies for the production companies to somehow make the landing on this pricing rally a bit softer for certain period, to give them time to scale up and build cost-efficient processes and infrastructure.
I think this is something we should bring back through the EU-for-Algae initiative of the European Commission. Again, as I said this morning, to help them to help us, because in a way we're playing the same football. We are playing football with China, but each team has a different rules. So it's, for example, I could import organic algae, but I had no right to produce it. So I was selling organic spirulina in France, but I didn't have the right to produce it. So we have to find a way to with equivalence. Yes.
Okay, thank you. Good afternoon, Vittorio Ramazza from COB. I want to thank you, all the speakers, for a lot of very, very important amount of information given, in particular from my point of view, Lina and Christine, because they talk about the market. I have a comment or suggestion for further studies, not this, for further studies. It's very, very important, in my opinion, to analyze well the composition of the market, because, for example, when Christina talked about the segmentation of the market and talking about the enthusiastic group, so the first one, in particular in Italy, it appears from this study that in Italy, young people have a good financial situation, from those figures, of course. And I know that probably is not so, because the boomers, as me, have probably good financial situation, but the young people in a country that is getting poorer and poorer in the last 15 years probably has other economic conditions. So a suggestion for the next study is to maybe have a wider samples or look better, because this situation should be updated. That's all. Thank you very much.
Thanks a lot, but maybe just to clarify, definitely is not the case shown in the results that young people who have good financial situation, but it was mainly that the group who are enthusiastic seem to be overrepresented by the younger group, and also people who have a perceived better financial situation, so they are not linked. I wish that the young Italian people are having a good financial situation, but not really in the result.
Yeah, I can comment this topic also, because in Christine's study there were only 5 countries represented, and very small selection. And Nordic countries were not involved at all as the best innovation adopters, and also with quite high living quality level. So this is not exhaustive, but it shows something that yes, the age group which is the easiest to target in Italy, but also whatever in Estonia, in Germany, everywhere, the age group sort of overlaps with our study. And also one more perhaps comment on the study where it was brought out that Spanish answerers sort of knew microalgae better. It is very logical because it's grown there. There is an industry, and sometimes it appears in the news when some new bioreactor opened or something. So it is very logical that people who live in the areas where the production units are, they know better.
Right. Hi, my name's Jules. I'm affiliated with University of East Anglia and University of Malta. It's a question for Christine. I loved your presentation, but I do have a question. On the consumer preferences, you were talking at one point about the people before they had saw a video and after. And I guess I just want to raise this issue about giving people information, because I know it doesn't always work as a way to, get a message across. And I guess I want to ask if you've studied or are planning to study the idea of associations. So you have some known person, some admired person making a pitch, maybe a football player, someone that a lot of people would like, right? But seriously, and so it's not just the information, it's that they're getting, it's been condoned by someone they respect, just because human nature is funny, we don't just respond to information. So I don't know if you're thinking of that, but.
That's definitely some very often used in social science, that sometimes they use maybe like a role model, or sometimes they use like a cartoon or some kind of association for anchoring. So you sort of interpret the results based on the baseline that everyone can have the same. So in this project itself, we did not do it, but indeed it is quite commonly used in social science that we do it. And maybe one extra point related to this, that when we look at the results just now from Lina and myself, when we have the segmentation that the results are so similar, while we use microdata survey, while Lina used macro data, it means that actually both studies are quite robust, the result. And thank you for the suggestion.
Perhaps to add, thank you for the question, because it's related to the marketing, and as Christine brought out, to direct the marketing, or you decided to who to direct mostly the enthusiasts or some other groups, but influencers play today's world quite a big part, and influencers are not teenagers who promote their content. Those are famous chefs, some of the very important figures who need to be engaged with the marketing. And the marketing, besides going into the product level, connected with certain segment, should be also content marketing, which is information. This is in very high need currently, because most of people do not read scientific literature. The translation is needed, and to transform the key messages into understandable format, easy to perhaps to access through the smartphone or other very much used channels by this particular age group. This is the key, we think.
Thank you. I'll end my today contribution to the evolution of the thinking of your community and sector by posing 5 questions in the research field, on the industrial field, and maybe on the new field which you haven't developed yet, which is the trade. So one question is: do we have algae in ourselves, on our microbiome? Because algae is a protist.
You raise your question to the panel?
Yes, to the panel.
Or if you have somebody that you think will...
It's an assembly here according to our principles.
Sure, but I still propose you to use the fact that we have the chance to have a panel.
Yes, to the panel mainly, yes. And second is, I'll give you for a research idea in the artificial intelligence and microorganisms, which is algae is a kind of microorganism, and bacteria together. The Japanese, they have a team. Yesterday I met them, the chief of this, and they take a special box, let's say it in this way. They put a chip with artificial intelligence, and they put also algae environment with bacteria, and they communicate through frequencies with the technology, so that they get information from this exchange of the artificial world and the microorganism world. The third is to the food security and safety. What do you say about what's going on right now with 3D printing, about cellular printing, cultural cellular printing of meat? We produce meat in Dutch in Holland and fish in Israel. You should know about this. It's very important, and I don't know the toxicity levels. And what about the genetic modification on the algae system? Now we are very good on deciphering the nature with the tools we have of changing the DNA. So what's going on this field, on the algae system? And ending, what's the share of the percentage of the algae inside the whole concept of the food industry, of the cosmetics industry, and I don't know where else you can use the algae. What's the percentage on the market level? Thank you.
To start?
Thank you very much. Thank you very much for your question. I think that you made a reference to cell culture derived foods, culture meat, and food ingredients derived from precision fermentation, for instance, using engineered, genetically modified microalgae. So I can mention that EFSA, I think that I said during the presentation, EFSA organized a colloquium in May on those topics, on cell culture derived foods, precision fermentation, in order to discuss ongoing research trends in these areas, and also to be sure that our approaches for the risk assessment still fit for purpose. I can confirm that under the novel food, ourselves in the novel food team and the risk assessment, we haven't received yet any dossier using genetically modified microalgae. And I must say that with regards cell culture derived foods, the first product was already assessed. It was published in June, I think July. It was an apple fruit cell culture biomass, so cell culture derived food of plant origin. And yeah, I don't know if because you had another question later on. Yeah. Yeah, I understand now. Sorry. No, we haven't received still any dossier for risk assessment in this regard.
Yes, those trials, yes, they happen, but still in very early age, so it is not sure which ones are viable to reach EFSA for risk assessment and approval, and then to reach at the end the market. But of course there are various of different technologies and also applications and food items which are tested.
This is at the moment at the lab level in a lot of companies, but the problem will come. Can somebody answer this, the question, what is the share in applications of algae or microalgae? What was microalgae, your question? Or algae in general? Microalgae is easier probably. Because if you put macroalgae, you have alginate story and you have... Macro? Oh yes, there is. I can introduce you to a lot of very fantastic lab. Only in Europe you have 10 or 15 very good labs on macroalgae and seaweeds. Somebody for the share between cosmetics and food and feed. Myself, I couldn't answer that. I think the cosmetics is quite important, but I don't know compared to.
Help in something answering that, but I will try. I think Lina was also presenting because they did the study in the case of this project, identifying the different companies putting, in this case, microalgae into the market, and I think she was presenting, and you correct me if that is not the case, for cosmetic was 6.5%. In the case of feed was around 12%, and then most of the microalgae is of course used for food application. When that comes to macroalgae, there is a portion of that that is also used in biomedical applications, cosmetics as well. A lot of all the alginates are also used for biomedical applications. But I cannot give you a percentage from the whole food market. What we could compare and maybe try to have as a goal is to reach percentages closest to the Asian market, where algae are really high represented in all the food community. And I think there is something around 10% of the whole food market is represented by algae. In that case, it's macroalgae mostly. I mean, something that Europe, of course, is very far now. No. About yeah, I mean, yeah, we don't know also the numbers from the Asia.
We have the data for the share. I could find it actually. What I couldn't find, even if I look for, is the prices and the volume in dollars or in. It's very difficult. Very difficult because even in France, somebody said that even in Europe, they don't really give the figures, so it's difficult. And in other countries, like in Asia, the figures are very, very fuzzy because they are controlled by the state. So it's difficult to have the real amount. What I can tell you is in the world, the production for algae in general is 36 million, and I think 35 in Asia. Somebody else? Questions?
Thank you for the presentation. My name is Robbie Maat from LG Capital. I have a question for Estefania, I think. To what extent does the novel food list apply for all the supplements that are made from processed algae? Because we see on the European market a lot of supplements derived from algae that are not on the novel food list.
First of all, I need to confirm once again that is beyond EFSA's remit to determine the novel food status, whether this is a novel food or not. This is under risk management. It's a decision taken by the Commission. Then, when an applicant submits the dossier, has to specify the conditions of use. And the conditions of use, for instance, of a microalgae could include as a food ingredient, and then the applicant has to specify the different food categories and the use levels. But the applicant can also propose to have the, for instance, dry biomass as a food supplement. And these conditions of use can be, again, checked on the Union list of novel foods. Yeah.
Okay, fine. I continue with the panel. We have a question, Alexander. And the question is, what is the challenge to bring microalgae to the market? For you. How do you feel?
I mean, it's what we have been speaking all day. It's price. It's the price at the moment.
It's only the price, but how you go to the price? I mean, you have an opinion because you're doing that.
Yeah, so
what is the priority? For example, I could say, I think there is a priority here, 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 or I have the feeling that.
What we can do to tackle the price issue is, of course, to improve production, to make it reduce costs in production, to be able to reduce the price of the selling of the product. Because just saying that it's more sustainable then might not be enough, like we are also said before. We can also improve a bit more the sustainability, but if soya is 10 or 100 times cheaper, it will be hard to convince a feed producer to change from soya to algae. maybe algae also don't need to replace all the soya. Maybe we can also go for the niche markets and do the business there. But of course, let's try to conquer the world. So.
To replace the energy, I agree with you.
Sorry?
I like to replace the energy. You have to find one way to replace oil, which is not true. So this is probably the same story with the algae.
By oil, you mean the?
I mean, this is the same story as energy. You thinking that one photovoltaic will replace every oil, for example. This is a kind of bouquet.
Yeah, you don't need to replace everything.
Thank you, Alexandre. I have a question for you. How far is the circa algae parallel to ProFuture, and how do you think it might complement, and in which way it will complement?
I said before, I think I understood today there is a lot of synergies in the way we see how to use algae biomass. In this case, it's microalgae. Of course, you have a specific focus in the protein part, while we are trying to aim to produce more things and not just protein, for instance. So ones that I think Elena was presenting, and you say now your focus is the whole biomass. In our case, it's the whole biomass, but by pieces. If we think about, I mean, in another way, no? Plant, a grain, wheat grain, have a value, right? But when you create from that flour, you create dietary fibers. You can also obtain proteins for it. You are gaining in value, dividing that, so you are refining. I think one important part that has to be more implemented into the microalgae business is this biorefinery, which is what Circalgae is proposing. In our case with the side stream, but can be, of course, implemented with the whole biomass from the beginning. That will also, hopefully, bring more opportunities for the producers. So hopefully, at some point, the prices will go down. So there is synergy there. I mean, and there is a different production of other type of microalgae that, of course, we will be very keen into try with our final cascade approach. So just to see if there is more things to valorize there. So yeah, there are ways to work together.
Thank you. Are there questions related to that? I think we go to the two last questions. Am I right? Olivier, again?
Yeah, I'm really passionate, so I have many questions. It's actually a question to you, Jean-Paul.
Panel, Olivier.
Sure, but you are bringing innovative products to the market. So I think it would be interesting for you to share your experience and your very innovative products.
Which I talked this morning about already. I didn't want.
No. This morning you talked about the industry, but in Algama.
Yes, I presented Algama with the egg replacer.
Sure,
so,
but.
That's nice that you offered me to make an advertising for my company.
I think it's quite a success, and we need to have examples of products, of food products.
Where you are right, where I'm at Algama also this, because there is so many things to go in the functionalities, to really go deep in the algae story, because now we know how to produce it, we know how to crack it, even if there is a lot of process. How we can understand the use of these different, because we claim there are so many different molecules, and which is true. There is such a biodiversity. Everything is in the sea, never came on Earth. When you see the pigments that you are using, when you see the omega-3, if you see so many compounds that didn't come on Earth, we can use it, and how we can really use it in a functional way. And this is what passionates me, actually, because I'm the research director of the story. How we can not going only to eat them, and I'm not saying that this is not good, but how we can go further and to use the functions of the algae, because they are so different. The Galdiaria is very interesting. Just an example, Galdiaria, this morning they didn't talk really, or who was talking about Galdiaria? you. Galderia, when we talk about thermoresistant pigment for coloring the food, it's interesting. pH-resistant food pigment is very, very interesting, and the people who do that, they cracked in a way how we can use the function, and there is everything that the young people will bring as an idea. So I think going deeper in the function. So this was, I was not supposed to talk. Do I have a right to a last question? Yeah. This is for you. If today we create here a consortium and we choose 10 algae and we share all the prices and all the cost, we can as a consortium come to EFSA and says this consortium want to have these 10 algae as a novel food. We can do that, or we have to be a company?
First of all, don't go to EFSA, go to the Commission. Don't go to EFSA. Our role is the risk assessment. So you have to go to the Commission to have this discussion. The definition of an applicant, according to the regulation and according to the guidance, is any legal or natural person. So it means individual, business operator, industry association, consultancy company, and so on. So indeed, it opens up the possibility for several interested parties to join forces and submit an application. But then, if you submit one application refers to a novel food.
I cannot make a group of algae.
You have to talk to the Commission. I think that tomorrow there is a representative from the Commission coming here to the conference, and I think that this question could be for him or for her. I don't remember right now.
Who is coming?
Yeah, I think I saw somebody from DG Santé, I think.
Yes, that's going to be Laurent Mercier from DG Agri.
Okay, fine.
Yes.
So we ask tomorrow. You're ready tomorrow?
Is this if you have a group of algae that you propose to go to the Commission and not to EFSA, but take that you have one algae, because like we work on algae that are not approved. A lot of companies are interested. Nobody wants to do the investment. But if you have 5 companies, that's another story. But this is done for 10 algae, as Jean-Paul proposed, but just for that one algae, with 5 potential.
I remember, sorry.
Just wanted to say that there is already experience. For example, in the insect sector, there are national associations of insect breeders, like the Belgian one, that have obtained a novel food authorization. So there is, as Mrs. Stefania said, every legal entity, also a temporary consortium of enterprises can present a novel food authorization application.
Should we stop, or unless there is a last question, should we stop now? I'm looking for the...
There's no other question. I would give the floor to Massimo for a little wrap-up of the day. And after that, we're all going to go to the rooftop terrace. There's a little networking aperitivo. There are some microalgae products to try. And yeah, thank you all so much for coming today. And thanks.
So after this interesting discussion, we can close these first days of the conference. I should summarize all we have said in this room today, so it's hard work. I I will try to make it without boring you furthermore. So first of all, I took also some notes to explain these points. First of all, I would like to thank all the speakers for their contribution today. Then I should say that I'm quite proud of the outcomes of the project ProFuture, because we reached we really actually implemented all the innovation we planned in the proposal, and this is a good result, I think. So thank you very much to the consortium for their work. And yes, another thing, I think definitely microalgae have a big potential as a source of ingredients for food and feed, and this is also something interesting for the future. But of course, there is still a need for more research, more development in many areas. And this gave us the possibility for another project for the future. This is also a good thing. Many areas, I think several things interesting are to be developed more in deep are the different strain, the selection of strain. We discussed it this morning, and I think probably is one of the most interesting thing. And the other one is what we discussed just now, the possibility to have a good extraction, fractionation of the biomass, and the valorization of all these compounds which are in the original biomass. And then another important point for me is the at this stage, it's quite important this point of the development of the microalgae ecosystem. It's quite important the networking with stakeholders, with all the actors in the value chain, and with also, of course, with the regulatory authorities to try to speed up the innovation and to speed up the development of products ready for the market. And finally, the last point I think it's quite interesting to underline is the importance of improving circularity and the valorization of the wastes, or better, side streams. In ProFuture, we made some activity related with this point, the use of insect frass and the valorization of spirograss are two examples. But of course, it's this is a big field of study, so there is a lot of work to do, as Amparo explained it right now. And so there is a lot of possibility to be exploited in the future. And now, as Marie said, it's time to leave a little bit the science and to go to the terrace for the aperitivo and the taste of the ProFuture product developed by our industrial partners. So thank you very much.